and how to cool streets and cities and decrease energy consumption and
on the image. In these pictures, we can see water will slowly immerse into the surface from this hole, starting from the lowest point. And finally, the overflow model will reach a state where only the top of the dams is exposed. The tops of these dams are water dividers, and the water accumulation areas that rise from different local minima are called sinks or pores. We can see figure A shows a CMM. To simulate the processing of flooding, we first calculated the complement of the CMM as figure B, which resemble two catchment basins. Assume that each basin has a hole punched at its minimum. Then we immerse it gradually into water. The catchment basins will be flooded. This algorithm can be thought to automatically build dams along the divide line to prevent water into neighboring catchment basins from merging as figure C. The constructed dams are called watershed lines and will be used partition trees. The two pictures below are made from experimental data. The experiment process of this article is shown in the figure. First, predict the canopy size window. This experiment will find out the nonlinear relationship between tree height and tree crown and get the variable window size. Tc is the crown diameter of each individual tree. Th is the average tree height of individual single tree. Then the CMM model is generated. In this paper, the CHM image is reconstructed based on the on operation, and the value of each grid unit is replaced with the maximum value of the lesser point cloud in the neighborhood to obtain the maximum canopy model. The highest point of the local pixel maximum direction, combined with the cone maximum model, it takes as the highest point of the tree, and then each local highest point is used as the seed point of k-means clustering for clustering. Step 1. The first clustering center represents the pixels as the treetop located by the variable window. Step 2. For each point, find the closest clustering center according to a given criterion and assign it to the area of this type. Step 3. The new clustering center obtained in Step 2. Step 4. When the cluster center no longer changes, the iteration is terminated. Watershed segmentation based on k-means clustering. Step 1. Suppose the image is divided into n blocks after k-means segmentation. Step 2. Define the gray variance of two adjacent blocks. Step 3. Define the mean value of standard deviation of gray value of 4 neighborhood pixels on the edge of segmentation block. Step 4. Define the similarity between two adjacent cut blocks. Set a threshold value t initially to maximize the variance between classes. Step 5. Use t to threshold the adjacent divided blocks. The third part is experiment. In this paper, The radius filter is used to denote the point cloud. A circle is drawn around a point to calculate the number of points that fall outside the circle. This paper adopts a semi-automatic path removal method that artificially sets the experience threshold and rarely judges the best path removal effect. Experimental results show that when using CMM model to monitor the tree top based on the local maximum value, the pseudo-local maximum value can be significantly eliminated, and the phenomenon of wrong and missing points in the tree top recognition can be reduced. The K-means watershed algorithm proposed in this article is compared with the traditional watershed algorithm. We can see the picture. Picture A is CMM model. The picture B is grayscale display CMM model. The picture C is watershed algorithm. The picture D is K-means clustering based on CMM. The picture E is grayscale display CMM K-means clustering. The picture F is improved watershed algorithm. Finally, a single-wood segmentation result display based on K-means clustering watershed segmentation algorithm is formed. The number at the top of the tree represents the tree ID. The fourth is conclusion. It can be analyzed by the formula that the number of unsplit trees and wrong-split trees are reduced. Therefore, the segmentation result of the improved watershed algorithm is more accurate. Thank you so much. Good morning, ladies.
Great. Well, thank you very much, Dr. Mu. Are you available for questions? Have you joined us? I have several questions about the utility of the algorithm that you've used, but I'm not sure if Dr. Mu is here. Yes, are you here? Yeah. Great presentation. Thank you so much.
Thank you too.
I'm wondering about your algorithm. Does it only work on airborne LiDAR data, or would it also work on ground-based LiDAR data, or even maybe drone-based LiDAR data where the point density is highly variable? I was wondering how the algorithm would perform with different point densities and where there may be gaps in points, if that makes sense from like the ground-based LiDAR.
Thank you for your question. Let me talk about my main algorithm. Step one, I think the step one is suppose the image divided into n blocks after K-means segmentation. Step two, define the gray variance of two adjacent blocks. Step three, define the mean value of standard division of gray value of 4 neighborhood pixel on the edge of segmentation block. Step 4, define the similarity between two adjacent cut blocks that there should value t initially to maximize of the variance between classes. Step 5, using to the there should the adjacent divided blocks. Thanks. That's my answer to this question. Thank you.
Thank you very much. Are there other questions? Well, I have one more question. Would your algorithm work with low height vegetation, or does it require trees that are taller? So would it work with shrubs and grasses?
The CMM is I think about first project is the canopy side window. This experiment will find out the non-linear relationship between tree height and tree crown and get the variable window size. Yes, that's my answer to this question.
Okay, thank you. Are there other questions?
Thank you very much.
Okay, if there's no other questions, thank you very much. This is my applause. Everybody applaud. I know it's hard to record a talk because you try to make it more perfect. Yeah. Okay. So our third paper in this session is investigation of cryosphere dynamics variations in the Upper Indus Basin using remote sensing and GIS. Is Javed Iqbal here to give this presentation? My understanding is it has not been recorded. Okay, again, the third paper, investigation of cryosphere dynamics variations in the Upper Indus Basin using remote sensing and GIS. Javed Iqbal, I believe, is the first author. Is he or she here? Okay.
No, they don't seem to be here, sorry.
They don't seem to be here, yes. Okay, so I also read this paper and it is quite interesting. If anybody is interested in time series remote sensing, they did a time series to track changes in glaciers. And it has a few methods for time series analysis with MODIS. So I recommend checking it out if you're interested in time series. Okay, so we're going to go to the last paper of the session, which is predicting land use and land cover changes using multi-temporal satellite images and multi-layer perception Markov model by Gwen and al. And I think we can go ahead and get started.
City in Vietnam. So today I would like to share with you the topic of land use, land cover change prediction using multi-temporal satellite imagery and multi-layer perception Markov. So this topic is a part of our project founded by USAID. He's the one of several topics that I want to share with you today. So the presentation is divided into 4 parts, which are introduction, the second material and methods, results and discussion, and the final part will be conclusions. So let's jump into the introduction. So we will have LULCC is relevant to human activities, have caused the dynamics of biological and geochemical process on Earth's surface. And the data is applicable for natural resources management and recommendation for socio-economic growth. So to understand the chain of LULCC is needed in sustainable resource management. And remote sensor and GIS are fundamental tools to obtaining accurate spatial data of a UAC and detecting the spatial alternations. And finally, many studies have proved the effectiveness of the MLP Markov model in predicting future LUSCC. And so for this research, we were working on Đắk Nông province, which has a high diversity of natural forest resources in the central highlands of Vietnam. So in the recent year, this area has experienced a burst in population growth, causing natural forest degradation. And the local management mechanism have exposed issues such as deforestation, encroachment led to decline forest cover in the province. Therefore, there's a crucial need for analysis of USC change over time and prediction on the future chain of land use transformation. So, and then we use the combination of multi-layer perceptron neural network with the Markov model is to apply to the detect temporal changes and model future spatial distribution of different land uses. So it hasn't considered to analyze this in a systematically way. The analysis of the changes as a basis for LUSCC strategies in the future has not been done in this area. So to understand the change of the changes in the past and current is really important for making proper decisions in the future to develop in a sustainable way to avoid the deforestation or any issue that's going on right now. So for the materials and methods, I want to talk about the area that we work on in this research, which is Đắk Nông province that I talked about in the last slide. So Đắk Nông is located in the central highlands of Vietnam, and its area is covered around 6,500 kilometers square, and it has a population of more than 600,000 people, in which 35% Kinh and the remaining ethnic minorities from other 40 groups. But actually, in the 30 years ago, there were just only 2 to 3 groups of minorities. But in the recent year, a lot more groups have moved to Đắk Nông province from the north side of Vietnam to do for living. So for the data we use for the research, we use the Landsat 5 and 8 in 2010, 2015, and 2018. And then we also have a lot of pictures involved in this research too. So based on the quality of the images and our purposes, there are 10 land use land cover classes were discriminated, including evergreen broadleaf forest, semi-evergreen forest, littoral carp forest, plantation forest, mature rubber, perennial industrial plants, cropland, residential area, water surface, and other lands, including other types of grassland, shrubs, bareland, unplanted land, abandoned land, and so on. So we have a sample here. So about the sample for image classification, the samples were randomly distributed on the whole area. These samples were interpreted based on field data collection, Google Earth, existence, forest map, Landsat satellite images, where the samples are discriminated against others based on our experience. So I would like to show you the map of our method that we use in for research. So we have the Landsat in 3 years, 2009, 2015, 2018. And then so we have to use the training and validation samples with the random forest classifier to classify those images in 3 years to LUFC 2009, LUFC 2015, and LUFC 2018. And then we also use the driving maps, which are proximity to road, water surface, elevation, and slope. And then we use the multi-layer perceptron neural network and Markov model to so that we can create the predicted LULC 2018, and then we have to compare the predicted one with the LULC 2018, and then we have to validate those images to get the predicted LULC in 2025. So here is the result and the discussion. So in this chart, we can see OA for all classified images range from 77.35% to 84, around 84%, with a cover from 0.75 to 0.81. And then the 2015 USC map had the highest accuracy of OA, which is about 85% with cover of 0.81, and the lowest is 77.35% in 2009 with a cover of 0.75, which is the lowest, and the PA and UH representative for above 30%, sorry. And comparing actual LULC 2018 and predicted, it showed most different was from plantation first within 15%, followed by the residential, which is 10%. And less different were evergreen forest, so to see the map, the LULC map projected for 2025 and the change scale in the diagram on the right side. Those are all the conclusions that we took from the research that we have done. And I just want to say thanks to the PIC program, which is sponsored by USAID and local authorities, Tengmin University, and collaborative research partners that have helped me to get this research done. Thank you for listening.
Okay, thank you very much. Is Professor Huang or the other co-authors here for questions?
Not Nancy, because I tried to get one of them in, but they don't seem to be online. So yeah.
Okay.
Unfortunately, they don't seem to be. It don't seem to be any of their team to answer the questions.
Okay. All right. Well, I have a couple of questions, but we can follow up via email with them later. Thanks, Abdullah. Are there any other comments or questions in regards to this session? I apologize that two of our talks were not available, but their papers are available, so I encourage you to go check out those papers. Okay, well, thank you for attending. I appreciate your attention and enjoy the rest of the conference.
Thank you, Nancy.
Oh, thank you so much for your help. All right, have a great day.
Thank you. Have a great day.
Thanks, Nancy. Yeah, very difficult circumstances then, but you managed to chair that exceptionally well. That was very smooth and very good for all the information to the audience. So yeah, thanks for that. Thanks.
Oh, no worries, and I understand you've got a lot of technical challenges at your end. So
we solved them all. They've all been solved. We've solved them all.
Oh, good for you.
Yeah. Everything's fine.
All right,
and
take care, you guys.
Yeah, thanks a lot. Thanks, Nancy.
Okay, take care.
Good afternoon. My name is Vanina Fissore. I'm a researcher at Ithaca, a center of applied research devoted to support humanitarian activities in response to natural natural disasters by means of remote sensing. Good afternoon, my name is Vanina Fissore. I'm a researcher at Ithaca, a center of applied research devoted to support
Hello, give me a second. Shall we start?
Just give me one second. We're almost.
Okay. Shall we start?
Yes, go for it.
This is not me. Me in the past.
Intro when you're ready, Sissy. Thanks.
We can start?
Yes, go ahead.
Okay, so hello everybody. Welcome to this session. This is a very special session, a keynote session. My name is Sissy Zlatanova and I'm going to chair it. Today we have very distinguished guest, Philip Gibson. He is professor at Fenner School of Environment and Society, the College of Science from Australian National University in Canberra. Philip is actually a very interesting person. He has 30 years of experience in land management, and he has been working for the governments of Victoria and New South Wales, and he has worked as a park ranger, firefighter, and forest ecologist. So very interesting. And after that, he decided to go to science, and he completed his PhD in 1999. And since that time, he started taking all kind of key roles in codes for practice for harvesting timber from native forests, native vegetation laws, biodiversity offset policy. He was also involved in protected area management and links between land management and house laws during bushfires. His research interests are in management of native vegetation, improving environmental impact assessment, and how to manage landscapes to reduce house losses and other assets during wildfire, and also providing cost-effective ecological restoration in natural and urban landscapes. So it's very interesting, Philip, what you are doing and what you have been doing. So I'm looking very much to your presentation. Please go ahead. The floor is yours.
Okay, thanks, Sissy. I'll just share my screen and we'll get going. So hopefully you can all see that.
All good. Yes.
All right. Thank you very much, and thank you, Sissy, for inviting me to talk today. So I'd like to talk about some of the research that we've just finished and are preparing for publication, and also a little bit of research that we've done in the past as well on the relationship between land management and house losses in Australian bushfires. So if you're from overseas, bushfires in Australia are a big issue, and house losses during bushfires in Australia represent considerable financial losses during bushfires. And most deaths of people in bushfires in Australia are defending or sheltering in houses. All right, and as you can see, with each of the large bushfire events in Australia, we're getting actually, despite the fact that we have had major improvements in terms of firefighting capacity, predicting fire behaviour, predicting weather, despite all of that, with each large wildfire event, such as the 2019-20 Black Summer fires as we know them, the number of houses destroyed continues to increase. All right, so finding better solutions for protecting houses during wildfires is I think a very important thing that we should be pursuing. And if we look at just the recent fires of 2019-20, so the Black Summer fires as some people call them, Houses alone, there are just over 3,000 houses destroyed in those fires. And in terms of other built assets, not just houses, greater than 5,000 power poles were destroyed, and a number of telecommunications and other electricity infrastructure. So around about 1,400 nodes, mobile, fixed wireless, fixed lines. And you can see 51 kilometres of copper cable were destroyed and 9 kilometres of optic fibre cable. So not only are houses being destroyed in bushfires, but also critical infrastructure that influences the resilience of communities to wildfires. So even if you're not directly impacted in a wildfire, if you don't have telecommunications during and soon after wildfires, or don't have, and I can speak from experience because we have a house at Browlee that when the electricity goes out for days and days, then it does cause a lot of problems, obviously. So these results, while they're all based on houses that I'm going to show, potentially also applicable to other infrastructure. So the question we asked in our research is that we're interested in is, what are the key land management variables associated with house losses in Australian bushfires? And the variables we're interested in are the amount of woody vegetation, so the amount of clearing or modification of that woody vegetation. We look at vegetation type and how that might influence things. We look at fire history, wildfire history and prescribed burning or hazard reduction burning. We look at land tenure, topography, slope is a key one. And of course, we look at weather as well, and weather's an important variable that we've got to control for. And we use what's called the Forest Fire Danger Index. And if you're not familiar with it, the Forest Fire Danger Index is used in Australia at the moment as the key sort of weather index for fire behaviour, and it's based on temperature, wind, relative humidity, and a thing called drought factor. All right, so in this latest study that we've done that I'm going to run through a bit with you this afternoon is this study. We've just completed this study, and an ARC, Australian Research Council funded study across 5 states in Australia, 12 wildfires over the last decade or so. Right. This study doesn't include the 2019-20 fires. All right, so what we've done is that we've sampled, randomly sampled houses from within the fire footprint of these wildfires, and we look at we randomly select those houses, and we look at we measure a range of variables proximate to the house and further from the house, and I'll talk a bit about that in a minute. And then we sample those houses blind, and then we bring in post-fire imagery, and then look at whether the house was destroyed or not. And of course this enables we do this. We randomly sample within fire footprints across the landscape. So we get this just illustrates 2 of the fire footprints that we looked at in Victoria, and this is you can see the destroyed houses in red and non-destroyed houses that are clear. We overlay the fire footprint. We can, what we do is also we can, with the weather, we predict, we use information provided by state agencies to work out what the weather is at each house at the time that the fire impacted. We have information on woody vegetation at the landscape scale. We had information on land use history, such as in this study we looked at prescribed burning. This is prescribed burning in this landscape in the last previous 5 years. And in this study we looked also at logging, the effect of logging on house losses. And so what we do is we at each house we sample. That's the wind direction. We sample what's immediately around the house in terms of vegetation, vegetation type, etc., topography, and then we also look at what upwind, what's the nearest vegetation type, and we also look at land use history in the landscape that represents the area from where the fire originated right up to where the house is. So we look basically at 3 scales: immediately around the house, what's the nearest fuels, and what the fuels look like right across the landscape, upwind from the house in the fire footprint. And interesting for this study, which is, like I said, across 12 wildfires in southern Australia over the last decade, you can see that the range of variation that we sampled. So the forest fire index ranged from 1 to 189 in the houses we sampled, which is an amazing range. And the slope ranged from flat to very steep, where houses were located, 23 degrees. We managed to sample landscapes where the percent of the landscape burnt upwind in the previous 5 years ranged from 0 to 100%. All right, so we managed to look at landscapes with very little previous burning, right up to completely burnt in the previous 5 years. And we also managed to look at houses that had previous burning right up to the house, and up to the nearest burning was 9.5 kilometres from the house. And it's interesting, the distance to mapped forest ranged from 0 to 1.3 kilometres. So, but it's interesting that if you look at all of this is burnt and unburnt houses, you can see that the distance to forest, the median was 48 metres. So in other words, houses that are impacted by bushfires in Australia really are that subset of houses that occur pretty close to forest, okay, pretty close to woody vegetation. So I think that's an important thing to realise, that it's not all houses that really are at high risk from bushfires. It's this subset of houses that occur fairly close to bushland. All right, so I'm not going to explain the methods that were used to analyse the data, but you can ask if you like afterwards. But here are the results of our analysis. This shows the relative importance of each of the key explanatory variables in our strongest models. All right, so and the first one, so these are the different variables, and that you can see the strongest. One of the strongest variables was the forest fire danger index, or the weather that was occurring at the house at the time the bushfire impacted. So let me just talk about that for a minute. So as I said, weather is important, and we measure it using the forest fire danger index. And as I said before, that's a combination of temperature, wind, humidity and drought factor. And you can see here the relationship on these charts I show you. You've got the proportion of houses destroyed on the y-axis, and on the x-axis you've got the explanatory variable, in this case the forest fire danger index. And these little lines along the x-axis indicate where houses were sampled, all right, along that range of variation. And you can see, I think the key thing from this result is that there's a strong relationship between the proportion of houses destroyed in a wildfire and the forest fire danger index. It's quite strong, it's almost linear, and it's bounded by it's pretty reliable sort of result in terms of confidence limits as well, which are given by the grey. One interesting thing from this, if you think of this in terms of climate change and house loss, it's interesting, a previous study by Clark et al. In Australia at weather stations, so this is an observational study at weather stations, found that the forest fire danger index at 5 weather stations they looked at in eastern Australia and southeast Queensland and New South Wales, the forest fire danger index at those weather stations increased by around about 10 across the highest fire danger days in the last 30 or so years, okay, 30 or 40 years. So in other words, there is empirical evidence, this is not based on modelling, there's empirical evidence that, or observational evidence that actually the forest fire danger index is increasing over time in parts of Australia. And this is a bit rough. I did it because the conference, there's an interest in the conference obviously on climate change, but other things equal, if you look at our data, we predict that if you increase the forest fire danger index by 10, this sort of in the most common upper end of forest fire danger index values you see in Australia, it increases house losses, according to our data, by about 3%. So it increases the proportion of houses destroyed by 3%. So there is a material relationship between an increase in the forest fire danger index and the proportion of houses destroyed. But that's a little simple, because that's not taking into account, you know, the area of wildfires and how that might be changing through time. And as we know from the 2019-20 fires, that the extent was unprecedented. You know, that was a incredibly wide extent that those houses burnt, and so that's an issue. And of course, the other big issue that's happened over this period of time is that, you know, since Black Friday in 1939, which was a terrible fire event for Australia, we've had the population has grown incredibly, and of course we have many more houses in that sort of high risk area that are close to bushland. So that's a big issue, that you know, we have many more houses now that get impacted from wildfire, and hence I think that's a very strong reason for this this upward relationship in terms of houses destroyed in Australia over time. Okay, the next group of variables, explanatory variables that were important, related to the amount of woody native vegetation. If you notice, a very strong variable that we've found in all of our studies to date is the cover of trees and shrubs within about 40 metres of houses, and also the distance, upwind distance to forest. Okay, so let's have a look at those. So if you look at the cover of trees and shrubs within 40 metres of houses, you can see a very strong, almost linear relationship between the proportion of houses destroyed on the y-axis and the cover of trees and shrubs within 40 metres of houses. And we measured these. We measured this variable actually manually off high resolution imagery. We've tried to automate it in different ways, but we find that manually doing it provides the best results. And you can see there's a very strong relationship. And also you can see there's a reasonable relationship also between the proportion of houses destroyed and the distance to nearest forest. Okay, so as you get closer to forest, and this is substantial blocks of forest, then the proportion of houses destroyed actually increases. All right, so they're two important risk factors that we've found. And if you look at, just to give you an illustration of the strength of this relationship, especially the amount of vegetation close to houses within 40 metres, you can see these are two predictions from the model. You can see, well, if we fix forest fire danger index at the beginning of extreme, which is 75, and we look at houses with woody vegetation, 80% cover of woody vegetation within 40 metres. So these are the houses that often nestled in remnant bushland, you know, have a lot of native vegetation around them. And if there was no burning in the last 5 years upwind, then the proportion of houses destroyed is very high, you know, 0.72. Okay, so that's quite high. And if you just if you take that amount of vegetation down to about 10%, okay, very low level, our predictions are that cuts the proportion or your risk substantially down to 0.15, the probability of your house being destroyed. So that's a remarkable result, and we found the same result actually after Black Saturday in a separate study, very similar result. So woody vegetation close to the house within about 40 metres is quite important. And there's an issue with this though, of course. You know, woody vegetation in itself is an asset, and you can see in response to our research, and not just our research, but research of others, there's many states in Australia allow a certain amount of land clearing around the houses, and the New South Wales government, after the 2019-20 fires, they recommended that actually those clearing regulations should be loosened even further. So now property owners are allowed to clear any vegetation within 25 metres of their house. Previously, it was any vegetation they could clear within 10 metres, and then they could clear any shrubs out to 50 metres. But now they can clear any vegetation out to 25 metres from their house, and any shrubs out to 50 metres. So it has resulted in a relaxation of clearing laws, and of course that's attracted some criticism. And here, after a previous study we published, and someone from in a magazine in the US asked me to write a little article about our work, and when the article came out, it was this image was attached to it. In other words, they were saying that they were having a bit of a dig at us, saying that, look, if everyone cleared, 40 metres around their houses, it's going to change the landscape substantially. And it's true, as we know, vegetation itself is an important asset, and a lot of people live in places like the Blue Mountains, which is just out of Sydney, because of the native vegetation. Native vegetation, is aesthetically pleasing, or vegetation around your house is aesthetically pleasing. It provides privacy, it provides shade, and can really help with cooling a house, and it provides wildlife close to your house, which is important for a lot of people and important for conservation. So vegetation itself is an important asset. So a lot of people, if everyone in the Blue Mountains or the south coast of New South Wales or in the hills outside Victoria or the hills outside Perth or Adelaide cleared 25 metres or 40 metres around their houses, then those places would look very different. Okay, and in actual fact, you possibly wouldn't attract people to those places anymore for the because the places would look so different. So what we did, this made us think, well, is there any way that you can sort of you can manage native vegetation around your houses and without increasing your risk of bushfires, without actually clearing? So is there any alternative to just clearing trees and shrubs around your houses? So we did a study a while ago where we looked at whether there are different ways you can manage native vegetation or vegetation around your houses to reduce your exposure to bushfires or your risk of loss during bushfires. And here we looked at three things. And the first was we looked at whether greener vegetation near houses affords them slightly more protection. Okay, so in other words, by watering your vegetation or by planting vegetation that maintains higher greenness, in inverted commas, then has higher moisture content, then does this afford some protection? So if you look at this chart, again, we've got probability of house loss on the y-axis, and then we've got on this chart we've got the percent cover of trees and shrubs within 40 metres of houses down on the x-axis. And these three panels, the first are based on NDVI, the Normalised Differential Vegetation Index, and which is a measure of greenness or photosynthetic activity of vegetation. And here we've got lower value of NDVI. I think that was about the 10th percentile, and then we have the median NDVI, and then the 90th percentile. And so what this is showing us is that as NDVI for greener vegetation, where you get higher values of NDVI, then it slightly lowers the probability of house loss at all levels of vegetation cover. So if you want to leave, a high amount of vegetation cover around your house, this translates to lower probability of house losses if that vegetation is greener. Okay, and that makes sense because there has been studies to show that vegetation with higher moisture content, all right, is more difficult to burn. It takes a bit of the energy or heat out of bushfires, and therefore bushfires tend to burn with less intensity, or in fact they don't burn that vegetation at all. So So it is true. It's not a strong result, but it does suggest that greener vegetation close to your house represents less risk. Okay, so that's one result. The other one is, how about the configuration of vegetation around your house? And so what we did is we looked at, well, if that vegetation occurs in a patchy distribution, 5 discrete patches, or 10 discrete patches, or 19 discrete patches. So as you make that vegetation around your house more patchy, okay, so you've got a clump of vegetation, then you've got very low fuels, and then another clump of vegetation. Does this afford your house additional protection? And yes, it does. You know, woody vegetation broken into discrete patches affords houses slightly more protection at higher levels of percent cover. So in other words, if you look at these higher levels of percent cover of vegetation around your houses, you can see that the probability of house loss starts to decline as that vegetation becomes more patchy. All right, so more patchy vegetation tends to represent less risk than more continuous vegetation. And again, it's because that what it's doing is that the fire can't maintain itself because it hits these areas, provided the areas between those patches have very low fuels, like mown grass. Then the fire loses, it can't preheat all the vegetation ahead of it, it loses energy, and therefore it loses intensity. Okay, and finally, how about, we also looked at whether leaving vegetation downwind of houses, you know, the direction around the house in which you leave vegetation, whether that makes a difference in terms of risk. And, you know, because it's logical that the vegetation in the upwind direction, so from which fires typically arrive, is likely to represent greater risk than vegetation retained downwind from the direction that fires typically arrive. And again, there is some evidence for this, that the vegetation that is downwind from your house, and this is the distance to the nearest large patch of vegetation, where vegetation is downwind from your house, it tends to have result in lower risk of house loss relative to vegetation very close to your house. And that's because radiant heat or direct flame contact, you know, may not be as affected by wind very close to your house, and also you know, you can also get at a fire front, you can get some convective winds which draw fire back to the house as well. So in other words, just repeating that, the vegetation retained downwind from houses represents less risk than vegetation upwind from houses, unless that vegetation is very close to the house. Okay, all right, and the third key management variable we looked at was prescribed burning, and this is one that gets a lot of attention in Australia, and it's sometimes called hazard reduction burning. And it's important that it not be confused with backburning. Backburning is a different management tool. Backburning refers to fires lit during an active fire to try to halt the spread of a fire. Okay, so prescribed burning or hazard reduction burning. And after every big wildfire event, such as these ones, then there's a push for greater prescribed burning. So we looked at what's the best way to do this, and we found the first thing you'll note is we did find that previous burning, okay, either the distance from houses to previous burning, or the proportion of the landscape burnt upwind from houses, did have an effect. They did appear in our best models, but you can see their importance relative to the other variables was pretty low. All right, so let's have a look at this. So prescribed burning is an intensely debated topic in Australia for some reason, and I just want to go through some of the arguments. So not in dispute about prescribed burning is that it reduces local severity of unplanned fire. If you burnt an area recently and another fire comes along, then the severity of that a subsequent wildfire is likely to be reduced. It reduces the area of unplanned fire in forest, okay, but not much. So studies have shown that every hectare of prescribed burning or fire within the last 5 years reduces unplanned fire by about 0.09 to 0.36 hectares. So you can see that the leverage from prescribed burning or previous fire isn't massive, but it is there. It's prescribed burning, the effect in Australian forests typically is lost after only 2 to 6 years. In other words, forests grow back, the fuels grow back and are replaced, and so the effect is fairly short-lived. And an important thing is the effect of prescribed burning diminishes as the weather becomes more adverse. Okay, so in more severe fire weather, the effect of fuels is diminished in terms of fire behaviour. So prescribed burning doesn't have as great effect in these in really hot fires, and it's those really hot fires that actually where houses are destroyed. So that's an issue. So that's not in dispute, but in dispute is that whether to protect assets such as houses, do we burn more forest at a landscape scale, or do we focus prescribed burning adjacent to houses? Okay, so that is a key area in dispute, and that's one thing we looked at in this latest study. And you'll see this was the variable, the prescribed burning variable, the previous burning variable that was in our best model. And you can see that, so what we did is we tested the relationship between house losses and the upwind distance to previous burning in the last 5 years. And we also looked at the relationship between house losses and the proportion of the landscape burnt upwind in the last 5 years. And in the best model, it was actually the distance between prescribed burning and houses that was more important. So you can see here that this is the distance, again, on the y-axis is the proportion of houses destroyed, and on the x-axis is the distance between the house and prescribed burning or previous burning, sorry, in the previous 5 years in the upwind direction. And you can see that's kilometres, and you can see that really it was only really effective previous burning if done within a kilometre upwind. Beyond a kilometre upwind, you can see that the probability of house losses remained pretty similar. Strong overlap in the confidence limits, and the last one is no prescribed burning. So you can see that prescribed burning greater than 1 kilometre upwind from houses was not significantly different from no prescribed burning at all. All right, so that was pretty interesting. We did have a model that there were two models in this statistical models that had empirical support. The second statistical model included this variable, which is the upwind proportion of the landscape previously burnt. The problem is that this is correlated with the distance between houses and upwind, the distance between houses and previous burning, and so we can't include both variables in the same model. So in other words, as fire for houses that are closer to fire, the proportion of the landscape upwind tends to be greater that has been burnt. So the two variables are correlated, so it's hard to untangle them. But you can see that when you look at this variable, the impact isn't as strong. All right, and you know, as you increase the proportion of the landscape that's been burnt, the impact on house losses isn't very strong, and also there's wide confidence limits. And let me just flesh this out a bit more. So let's look at the impact of previous burning, and if you look at predictions from our model, so this is no burning upwind from houses in the last 5 years, and holding all other variables equal, and with the forest fire danger index at 75, you get a proportion of houses lost is around 0.31. Okay, that's what we're predicting. If you burn 40% of the landscape, okay, over the previous 5 years, that's 8% per year. That's a huge amount of the landscape burnt. I think that's what West Australia aims to do, and it reduces the proportion of houses destroyed down to about 0.23 according to our model. But if you burn within 1 kilometre of houses, then it reduces the proportion of houses destroyed down to 0.13. In other words, what our results suggest is that burning close to houses has greater effect, or is more effective than burning more of the landscape upwind. All right, so now it's interesting that prescribed burning is the problem with houses is that and prescribed burning is that you know, houses occur in areas which have a lot of private land. So if you look at the percent of houses in the fire footprint with burning upwind in the past 5 years was only 22%. All right, so the majority, 80% of houses had no burning upwind in the previous 5 years. Okay, and this is partly because, you know, most prescribed burning it occurs on public land, and there are a lot of houses that are destroyed in fires that have little public land in the fire footprint. The other thing is that the mean percent of the landscape burnt upwind from houses in the previous 5 years was only 4%. So again, you know, because landscapes, you know, where houses are burnt tend to be dominated by private land, there's not much prescribed burning in private land, and you can see that only 4% of the landscape has been burnt. So very low numbers. And the percent of houses with previous burning within 1 kilometre upwind, which this is where we think prescribed burning has the greatest effect, only 5% of houses. Okay, it's very hard to burn very close to houses. You know, one, because it's not often public land, a public forest. It's risky burning close to houses. So, in other words, the amount of burning we're doing in the landscape is actually pretty low. All right, close to houses. All right. So just going back to this debate about prescribed burning close versus distant from houses. So in summary, you know, prescribed burning close to houses, there's good evidence that this reduces house loss. There's a high chance that unplanned fire will meet prescribed fire before impacting the asset. So in other words, if you do prescribed burning out in the far from houses, there's a very high chance that the fire will actually not intersect or go around that prescribed burn. You do the prescribed burn very close to the asset that you're trying to protect, and then there's a higher chance that an unplanned fire is actually going to hit that prescribed burn. You know, a prescribed burn that's done way off in the distance, it really, you know, in most cases, I wouldn't say in all cases, but it really needs to stop a fire to be effective for protecting a house. Okay, and that's hard to do. You know, most prescribed burns don't stop fires. Okay, they slow them down, but they don't stop them, particularly in bad weather. And also, look, you can do prescribed burning for other reasons. You know, in areas where fires are predicted to run, you can do prescribed burning to slow them down and buy you more time, and I acknowledge that. But I'm just making the point that a prescribed burn that's done very close to houses, if it's cutting off, if it's slowing down the number of embers that are hitting the house, then it's effective, even if that fire continues past the prescribed burn, because the number of embers, because the house is close enough to that prescribed burn to actually be immediately affected. And also, if you think about it, the urban wildland interface, so the interface between urban and peri-urban areas and forest, there's an additive effect of mechanical fuel reduction. You know, there's a lot of clearing that occurs on the edge of urban and peri-urban areas. Okay, so this is good for creating what we call defensible space. There's good access for firefighting. There's good access to water often in these places, and there is personnel often there to help protect houses. So there's a lot of added benefits, additive effect of these things that occurs close to houses. But you've got to realise that prescribed burning close to houses is expensive. It carries a higher risk. Okay, there's a lot more planning that's got to go on. If a prescribed fire gets away close to a house, then the risk is much higher. So therefore there's a smaller window for doing prescribed burning close to houses, and it's not compatible with all land uses at the peri-urban and rural interface. Okay, so it's hard to do prescribed burning where there's stock, fences, pasture and other infrastructure. Now, prescribed burning distant from houses, the effect on house loss is more uncertain, okay, and there are some challenges to study it, but really there are no studies based on observational data other than the two that we've done that have looked at the relationship between prescribed burning and house loss directly. There's a lot of modelling studies and studies that do it indirectly, but there's only two studies that have directly looked at the relationship between house loss and prescribed burning. And there's a lower chance that unplanned fire will meet prescribed fire before impacting the asset. So, in other words, like I said before, you do prescribed burning distant from houses, then there's and scattered through the landscape, there's a lower chance that a wildfire will actually will intercept that prescribed burn. Okay, that chance increases as the prescribed burn occurs closer to the asset that you're trying to protect. And of course, large area targets are difficult to meet. You can see from our results that you need to burn a large area of the landscape to have an effect that's equivalent to burning close to houses. And these have been typically difficult to meet. So after the Black Saturday fires in Victoria, a Royal Commission recommended that they triple the area of prescribed burning to about 5% per annum. And the Bushfire Monitor, the Bushfires Royal Commission Monitor, concluded several years afterwards that they could only meet half of that target. They could never meet that area target. Okay, and of course, prescribed burning distant from houses must stop unplanned fire reaching houses to be effective. Okay, yes, it can slow down. It potentially, theoretically, can slow down wildfires and therefore give people a greater opportunity to get organised to fight them. But I haven't seen any empirical data to suggest that offers effective protection of houses. And of course, but the advantage is prescribed burning distant from houses is cheaper, lower risk, and is on public tenure, so it's easier to implement. Okay. And if we look at the recommendations of the New South Wales Bushfire Inquiry regarding hazard reduction, they've taken on a number of our results. We're not the only ones that have found similar results, but they indicate that hazard reduction has increased annually since 2011. So it's not the lack of hazard reduction burning that's really at issue. And they acknowledge that there's no guarantee that hazard reduction burning will work, particularly in adverse weather. The 2019-20 fires, because they occurred under pretty extreme conditions, they acknowledge that the degree to which more hazard reduction across the landscape would have reduced the extent of those fires is not clear. And that's acknowledging that weather has a very strong effect on the efficacy of hazard reduction burning. And that they acknowledge that latest research shows that hazard reduction is most likely to provide benefit near specific things that communities want to protect, and that's partly reflecting our research. And as a consequence, they recommend more targeted hazard reduction working from perimeter of settlements outwards. Okay, and that's exactly what we're arguing here too. And they therefore acknowledge that to achieve this, there must be greater support for private landholders to do hazard reduction. Okay, so sorry for spending so long on that, but I think it's a very important issue in Australia. And finally, I just want to, you'll see that our results indicate that fuel management close to houses seems to be of greater value than fuel management further from houses. And this is backed up by theory. If we look at what we know about how houses are destroyed during fires, there's three aspects of fire that lead to the destruction of houses. The first is ember attack, And you can see that this is the approximate density or probability occurrence of embers with the distance from the fuel source. And you can see it peaks closer to the fuel source. So in other words, embers are at the greatest peak closer to the fuel source. And if you're from Australia and you've seen some of the footage from the 2019-20 fires, there's some really interesting footage to show as the fires come up to fire trucks. You can see you get this shower of embers pretty close to the fire front. You know, the fire front's getting close, you get a shower of embers and then you get the fire front. In other words, that density of embers is greatest pretty close to the fuel source. And the other thing that's important for house loss is radiant heat. And you can see that, you know, really the maximum distance that radiant heat can ignite a wooden structure is about 40 metres. So that also peaks very close to houses, and also flame contact. And that peaks even, you know, the direct contact of flames on houses and structures around houses are important, and you can see that tends to occur pretty close to houses as well. So in other words, it makes sense that fuel management close to houses is important, because the three mechanisms that destroy houses during wildfires all are at greatest severity very close to the house. Okay, so caveats in our research. There's some issues with weather data. We've got to get weather data from the nearest weather station, so that's not always equal with what's happening at the house. We didn't consider active defence of houses, which we know is important. That's in our random variation. House construction is not considered in these analyses. We didn't test how often. We've done other studies that include house construction. We didn't test how often previous burning stops fires before they reach houses. So, you know, if previous burning could be important because it stops a fire before it reaches a house, and we didn't do that. We sampled houses within the footprints of fires. And I think overall we find it's quite tricky to get some of these data. The state agencies have been really helpful for us, but it does take a lot of investment. And I submitted to the Royal Commission, the Federal Royal Commission, that we need better collection and reporting of fire information in Australia so we can learn quickly and we can combine data from different states. And so in summary, house losses in Australia are increasing from bushfires. This is partly due to climate change, but is likely to be more related to population growth. So climate change, not discounting the importance of climate change, but population growth is also very important. Fuel reduction is most effective at undertaken close to houses, with clearing vegetation very close to houses the most effective land management option. However, we've got to recognise that vegetation is an asset in its own right, and we've also got to think about, well, do we just we can't just clear all vegetation because it provides some important ecosystem services. And we've got to remember that the effectiveness of all fuel reduction options diminishes with severity of weather. All right, so that's an important thing to always remember, that as the weather gets more severe, all of these actions actually become less effective. So that means that other strategies, such as building design, early evacuation, should form part of any strategy to reduce impacts of bushfires on communities. All right, I just want to acknowledge my co-researchers, including from Australia and California. My latest study, or last two studies, were funded by the Australian Research Council. Sorry, the last study from the Australian Research Council, and we've received cooperation from many state agencies, and most of the results are provided here, not peer-reviewed yet. They're about to be submitted for publication. So that's it from me, Sissy. So I'll hand it back to you.
Thank you very much, Philip. So interesting, excellent presentation, and very educational. Actually, I had a lot of questions through your presentation, and slowly they became answered. Because I'm chairing this session, I allow myself to start with the questions, and after that we'll look whether we have some questions from somewhere on the chats. So apparently vegetation is very important. but I'm wondering how you are measuring what is the view in the vegetation around the houses. Do you have some specific procedure for this?
Yeah, it's pretty simple actually, Sissy. We just, and it could be improved a lot, but it is hard to do when you're trying to do so many houses. We can't measure them all on the ground. So what we do close to the house, we measure the cover of trees and shrubs with the high resolution imagery, and we do it. We've tried a few different things, LiDAR and other instruments, but we've actually found it's better and more consistent if we do it by eye. So we still do it just manually. So it takes a long time, but we can separate trees and shrubs with the high resolution imagery. We can also separate planted vegetation from remnant vegetation. That's reasonably easy to do. So it's pretty simple. We don't get a great measure of the vertical, and this is one limitation of the vertical structure of the vegetation, which we know is important for fire behaviour, but we can't get it. Okay, I'd love to get more information on the way gardens have been managed, you know, close to houses, how much mowing's been done and whatever. But again, we don't. It's hard to get that data, and it'd be great to have a better national data set that collates this information, because there are building impact assessment studies that are done after fires, and it'd be great to have. We've used some of these data, but it's not perfect data. There's often gaps in the data, and it'd be great to have a national consistent approach to that, and a way of accessing that data quickly. So yeah, and at the broader scale, we use existing spatial models and remote sensing products.
Yeah. Okay. Thank you very much. I see that we have quite a lot of questions. Here we have also researchers that are trying to estimate fuel on the basis of LiDAR, processing of LiDAR, or other methods. So let me see. I'll start with this question. Are there studies on native versus exotic vegetation with regard to the risk?
Yeah, so in a previous study we did, we certainly found that. So it's difficult. Thanks for that question, but it is difficult from what we do to know exactly the methods we're using, exactly what's exotic and native. But what we can pick is what is planted versus remnant. So we can't, and that's mainly exotic versus native, but we can't fully separate. But anyway, our work has found that planted native vegetation represents less risk than remnant native vegetation. So there are some advantages, and then if you remember that some of the results I presented, vegetation that's greener, as picked up by NDVI, which suggests higher moisture content, is also better. So in other words, not all exotic vegetation is better, because, you know, for instance, pines are terrible, you know, like they have a very strong vertical continuity of fuel. They can burn very fine needles. They burn a lot. So it's not all exotic vegetation that's better, but I think there's a fairly strong case that some exotic vegetation that maintains high fuel moisture content is actually quite advantageous. Yeah.
Okay, interesting.
I think there needs to be more work done there. You know, our work doesn't address that as well as it could.
And here there is another interesting question: how close the houses has to be to the bushland to be considered as fire prone? Is there some statistic or some regulations for this?
Yeah, well, to be fire prone, so there are maps of in each state. There are maps of areas of greater, you know, hazard, if you like, you know, that are higher risk, and they're based on things like slope and distance from vegetation. All right, but if we go to so there are maps available that map this. If we go to our results, it indicates that in terms of forest, you know, blocks of forest, that really, you know, if you're within say 100 metres of it's not a cut and dried threshold. The closer you are to forest, the worse it is. I should pop up. I might just share my screen just quickly, if that's all right, and I'll just show you what I mean.
Yeah, sure.
So if you look at the result that I provided, you can see the distance from forest, this is the bottom chart here, is you can see it's not, there's no sort of threshold. The closer you are, the worse it is. All right. So,
yeah.
And it sort of eases away. So, so there's no, I can't say any particular distance, but you know, one thing that's interesting is that, like I said, the majority of houses, I think, don't quote me on this, but something like, I'd have to look at my data again, but something like 75% of houses were within 100 metres of bushland that were impacted by fire, not necessarily burnt. So in other words, you've got to be pretty close to bushland. That's where the highest risk is, and the closer you are to bushland, the worse it is. But but like I said, the proximity to bushland's not quite as strong a predictor as the amount of vegetation close to your houses. So if you're close to bushland and you have a high amount of trees and shrubs close to your house, then you're very high risk. Okay, so it's the combination of the two, your proximity to bushland and the amount of vegetation close to your house that are important. So sorry, I can't give a threshold, you know,
right, yeah,
100 metres or whatever, because you can see from the chart at the bottom, which is distance to nearest forest, that it's actually not a threshold effect. So the closer you are, the worse it is.
Right, yeah. Okay, so, and do you have some statistic about property loss due to heathlands?
Heathlands?
Yeah.
No, it's interesting, you know, like, yeah, heath, we looked at this in our results, and and maybe because we didn't have, you know, we did have a number of studies, especially from Western Australia in our results, so we should have had a fair few heaths. We didn't find a significant effect, a significant difference between heath and forest in terms of risk. Okay, so so our results didn't bear it out, but it wasn't. We weren't specifically looking at that, but we did try to account for vegetation type. So all I can say is that I know that heaths are certainly a problem, and you know, represent a high risk, even though they're not a tall forest. But our results didn't find any additional sort of risk associated with heath relative to forest. Yeah.
And you spoke about that in your studies you didn't consider the house construction, but do you think that it is some important criteria?
Yeah, so we've, you know, Owen Price, who's a colleague of mine at University of Wollongong, has led a study recently where we've looked at, we've used data provided by Rural Fire Service of New South Wales, thanks to them. This is this building impact assessment data. And he found, it's interesting though, he found that, just like our study, he found that vegetation close to the house is very important. And Justin Leonard from CSIRO also, he's much more of an expert on house construction. And so it is a bit different. Look, you know, Justin's the expert on this actually, but there are a few things, you know, like obviously gaps in houses that one thing we notice in our results is that if you've had really strong winds around a house, and you can tell, you know, these are, every now and again a fire will produce these very strong convective winds. I don't know if you remember that one of the firefighters that was killed during the 2019-20 fires, his truck was overturned by winds, you know, so that shows how strong those winds can get. And we can see it in the data that when you've got a house where a lot of trees have fallen down around the house, which suggests
from the audience or not. So if there is no question, you may ask your own questions. Sure. And then the presenter will turn his camera on, or her camera on, and we will bring her live as well. So yeah, so we will just send it now live, and you can basically start. Just give me a second. I think you're live. There you go.
Okay, well, good afternoon, everyone, and welcome to this session on intelligence and recovery. So we've got 4 interesting papers this afternoon, and our first presenter, I believe, is Rikao Kong. Is that correct?
Yes.
Okay, so I'll hand over to the technology people to play the recording. Thank you.
Hello, everyone. My name is Rikao Kong. I'm from National Institute for Environmental Studies. Today, I would like to talk about the evidence for the development of energy resonance in Fukushima Prefecture after the Great East Japan earthquake. Now, let me introduce the research background. Taking the lessons from the Great East Japan earthquake, the nuclear-reliant energy policy in Fukushima has been transferred to fossil fuel and renewable energy for better resilience towards the future disaster. Combating the global warming, Fukushima Prefecture made more efforts on promotions of renewable energy than fossil fuel, feeding tariff scheme of renewable energy, renewable energy promotion vision, Fukushima Airport mega solar project, and so on. Now my questions are, how does the energy system develop after the GJE? Whether the resilience of its energy system is enough? Okay, let me introduce the study area. Fukushima Prefecture is the blue area shown on the right map. It owns the 3rd largest area in Japan and a population of 1.8 million more. As the purple dot shown on the map, the Fukushima Daiichi nuclear power station was destroyed by the tsunami, leading to huge economic and environmental impacts. In this study, we will talk about these impacts on the energy system. The workflow is shown in figure 2. At first, the facility name, capacity, and the location of these facilities were collected from a power plant database, and the capacities were updated until 2020. Then, these facilities were mapped as points by their coordinates. Finally, the capacities and gap before and after the GJE were summarized by a 1 kilometer resolution mesh. The energy system in 2010 is made as the condition before the GJE, and which in 2020 is made as that after the GJE. To clarify the condition of energy system before the GJE, we summarize the total capacity of facilities by types. As shown in the left figure, the total capacity of nuclear power in 2010 accounted for the largest proportion of 48%, fossil fuel power 40%, and renewable power 12%. As shown in the right figure, we give the distribution for the 231 power plants. The blue dot with a red star inside shown the plants with the largest capacity. And from this figure, we found most of them belong to the hydropower facilities. For the condition of energy system after the GJE is shown on the left figure. You can see that the total capacity of nuclear power went to 0, and the other 2 types of facilities were both increased. The total number of facilities were increased to 625. As shown on the right figure, we found most of them belong to the solar power facilities. To exploit the relationship between the spatial distribution of power facilities and population, we overlaid the municipal population map and the facility point map together. From there, this figure we found. These facilities are mainly concentrated in the municipalities with a higher population, and there is a high potential to develop the renewable energy in the areas with lower populations. To capture the total capacity gap before and after the GEGE, we summarize it by a 1 km resolution mesh, as shown in Figure 5. The red grids located on the eastern coastal areas show the currently constructed facilities with large capacities. In the middle areas, the number of grids are more than the eastern areas, where power facilities are with lower gap, because much more solar power facilities newly constructed there. Meanwhile, there have been almost no facilities constructed in the western areas, where belong to low population density areas. It reflects the fact that the increased capacities of facilities mainly concentrated in the population intensive areas since the GEGE. The conditions of electricity supply facilities before and after the GEGE were listed on Table 1. We could see that the facility number and total capacities of solar power increased significantly, which proved a high development of renewable energy. The capacities of biomass coal-fired power plants increased most of all, and the total facility number were increased. However, total capacity of all plants were decreased due to the shutdown of nuclear power. To exploit the evidences for the development, we summarized the total capacities of facilities certificated by the FIT scheme and gave the distribution of them by municipalities. We found the capacity of solar power certificated has increased in this period, which is consistent with the trend for solar power indicated before. The total capacity of all facilities increased from 17 million watts to 1,700 million watts, which gives the evidence for the development of renewable energy. The figure below gives evidence for a high development on the renewable energy in middle and eastern areas. To evaluate whether the resilience of its energy system is enough or not, we summarize the indicators related to the energy supply and consumption in Fukushima before and after the GEGE. The needed operating ratios for current facilities were derived based on the real total electricity supply and the total capacity of power facilities. The needed operating ratio in 2019 is lower than the mean operating ratio of solar power. Thus, it is reasonable for the current facilities to meet the demand, which demonstrated its energy resilience was enough. As reported by IEA, the energy conversion efficiency of fossil fuel power is lower than the renewable power. It means the renewable power can save more energy than fossil fuel power. Renewable energy is also endless, requires less maintenance and operating costs, and more healthy and environmental benefits. Promoting the renewable energy is critical for the urban energy resilience. Through this study, we concluded that the nuclear power with major power supplier in Fukushima, and only a few renewable energy facilities existed before the GEJE. The capacities of hydropower and biomass coal-fired facilities accounted for the high production at that time. After the GEJE, the energy system was transferred from nuclear plant type to a distributed power type. Up to now, the number and the total capacity of renewable energy facilities increased significantly comparing to that before the GEJE, especially for the solar power. The evidences showed that energy resilience in Fukushima was developed enough so as to face the risk from the future disaster and extreme climate events. The FIT stream was well promoted in Fukushima, making its energy system more resilient. Thus, this kind of energy policy should be highlighted. Okay, thank you very much for your attention. Hello, everyone. My name.
Okay, so thank you for the presentation. Now, are there any questions in the chat? I can't see any at the moment.
Can you see the part of the chat with the question mark?
I don't think I can.
Okay, there is this is the Q&A part normally, but I can just read on the question for you. Actually, there is oh, I see a second question. There's one question. It was from my son. So Rick, how do you mind turning on your camera, please? Okay, thank you. All right. So the question is the plan of the Fukushima prefecture and other part in Japan, is it their plan to give up on nuclear power in the long term?
Thank you for your question. And since the earthquake in 2011, the citizens in Fukushima Prefecture are against with the nuclear power. So the two nuclear power plants in Fukushima has been closed. And there are also some nuclear power plants exist in the other area of Japan now. I think this is a special issue in Fukushima Prefecture. The citizens are against with the nuclear power. So I think maybe in a long term, in a long period, they won't consider the nuclear power, especially in this prefecture.
And is there another question there, Abdu?
Yes, there is another question. Don't worry, I will try to fix that for you just right after this. Okay. So there is another question from Fiona. So are there any other policy measures aside from the FIT scheme that promoted renewable energy?
Yes, about this FIT stream, it's issued by the Japanese government, and the research data I used is also from the government website. So I think they have the data on the facility number new constructed, and also the facility capacity new constructed. reported for each year, and also there's the data for each month.
Okay, thank you. There is no other question.
Oh, thank you very much.
Okay, thank you very much for your presentation, Rika.
Thank you.
I think we can move on to the second paper. And I guess the second paper has some resonance in our current times because it's about infectious disease data. So over to you.
Hello everyone, thank you for the opportunity to talk with you today. My name is Ilya Kuznetsov. I'm studying currently in the 4th year at St. Petersburg State University, Russia. And today my talk is considered with web-based representation and management of infection diseases data on a city scale case study of St. Petersburg, Russia. So let me start. I am going to divide this task into 5 parts. In the project background, I would like to draw your attention to the background of this work. We have been working on our project for more than a year and a half, so we have some experience, main ideas and goals. After that, in the next article, in Accumulate Experience, I would like to introduce you to the existing experience and briefly present the method of our work. The architecture of the project in GIS, I would like to tell you the main architecture in GIS which we have right now. In the next session, operated medical statistic data, I would like to introduce you to the data what we had to work with. In the same article, I will tell you about the key reason to switch our project to the web services. Finally, in the last paragraph about prototyping, I will explain what guided the plan of WebGIS. I will tell you some analogy and show you some analogy of our work. For more than a year, our research group, formed by researchers from our university and some medical organization and institute, are working on a study of GIS application to account and model. First of all, it's a mapping the spread of social diseases in St. Petersburg. During 2018, we have done a lot of work. Some goals you can see in the picture. Initially, our goals was created a model for collecting and processing medical data, but over the time, this task have expanded. Now, the range of tasks includes data analytics, aggregation of information, and the developing thematic maps for the local governments. Main point that we don't want to make a special system for monitoring diseases in St. Petersburg. Currently, we collected data on tuberculosis for the last 5 years, covering all 18 administrative districts in St. Petersburg. In 6 out of 18 districts, a comprehensive study and mapping we concluded with attention at HIV, viruses and hepatitis, and estimates of the work quality of local hospital and clinics. However, despite the advantages, GIS cannot be a good for the medical specialist. GIS tools are operated easily by GIS domain specialists, but it's very difficult for medical professionals. One of the promising directions for us is incorporate of WebGIS facilities in the development toolkit. Of course, during this time, our project has a special architecture, which includes patient data sets for each district and for the city as a whole. All patient information, is very important, is depersonalized and completes with a Russian law number 100 to 1000 personal data. We have included geographic information layers in a shape format, geographic information project for cookie system, and developed model for geocoding data. We call it Geomedical. This model has deployed by us has an alternative to the GIS model. It's a simple model to geocode our address with patient to our project. Based on this, we have accumulated a huge number of geographic information layers. Their transmission and processing is very difficult. Migration development to the web should help solve a large number of our problems. You can see the reason for migration GIS to web in your page. First of all, it's the decentralization of healthcare organization. The Russian care system is represented by several levels of medical organization. At the first level is district dispensaries in districts of the large city. Dispensaries at the district level collect information about patient and heal them. After that, they aggregate the information and give to the main central dispensary of the city or subject. But you can see some difference between information in dispensaries and information in the central hospital. Here you can see information from dispensaries in the first level, but here you can see information from the central hospital. Web structure, we can solve these problems once and for all. Next reason is amount of information received. Of course, the volume of our database is small. However, storing them on a personal computer and using them in personal GISs is really difficult. Because of this, we have to regularly update our PC version in some different organizations, so it's really hard. Informing population and local governments. According to the federal law of state secrets, we can't give a secret for information about public health. In addition, local authorities are required to inform a population in their territory. Next reason and low level of GIS competence of the medical specialist. The low level of competition of medical specialists does not allow using the developers GIS at the organization levels. So web GIS should save their time and solve this problem. The last problem is economic feasibility. Maintaining a non-core GIS specialist as a medical facility costs a lot of money in the long run. So we think that web GIS can solve this problem. Web interface can become popular for recent years for publication of geospatial data and delivery to consumer and users. Coronavirus epidemic of this year have pushed application of dashboard solutions into research and development trends when visualizing medical geospatial data. Example in this case the Johns Hopkins University COVID dashboard. So, maximum flexibility in web GIS interface development can be ensured when you're using PHP and JavaScript web development. But in our way, we haven't so much time to learn Java and PHP. And we choose Python language and Python Django library. You can see the reason why we choose that. First of all, with experience in Python. Python is used in most GIS systems, and Python is one of the fastest growing programming languages. We are currently working on the architecture of our future project. First must-have building block is the map visualization tools. NextGIS is a Russian commercial company that built a business in the geospatial domain around open source. For example, they work with the QGIS. We have a pilot web mapping project called FabrisGIS. We use data which collected in Moskovsky administrative district of St. Petersburg. But another example is Geocinematica, a web platform for the spatial data publication. For example, a developer can add a timeline to the map to open it time development data that is extremely important for our study. In conclusion, I want to say web publication of generic medical statistics was supposed at the early beginning stage of our study. Thank you for your attention. Hello everyone, thank you for the opportunity to talk with you today. My name is Gi4DM. I'm studying currently in the fourth.
Okay, Ilya, thank you for your presentation. I can see the Q&A. There are no questions there that I can see, but I have a question for you. In Australia, it's difficult to get access to the sort of medical records that you used in your example. Is it the same in Russia? Is it more difficult or easier to get access to that sort of information?
You mean difficult to make some information from dispensaries in cities?
More about the confidentiality of the information. Medical records are kept confidential, and it's very difficult to get detailed information about patient records for something like a GIS study.
So what I can say about information, how it's work, because we work with some medical organization in the city. They have this information, of course, and when we take some information about patient, of course, we know their names, their passport or something like that, but in Russia we have a federal law number 152, if I remember, that we should clean all this data about names, date of birth, passport data. So we work only with addresses when somebody leaves. So in Russian law, it's clean when you work with the addresses, so it's no problem with that. But one very important point that you must work with a medical organization. That's all.
Okay. Now there are some other questions in the chat, so I'll read them out. So one question is about the target for your development. Who is the target for your GIS development? Is it the public or is it government agencies?
Oh, thank you. It's a really good and interesting question. I think that the main target of our development, of course, it's a public, because we try to show for the people what the problems with the health near with them. So when we work, we can show the houses when we have some problems, and of course, it can help simple people to say the local governments, so look, we have problem in these houses or in this district, and local governments of course must work with that. So we think that is a good like a bridge between public and government structures, so I think it's a good idea.
Okay, thank you. And look, there's another question about the accuracy level of the patient address data. So is that down to specific households or is it more general?
What about accuracy? I understand, and we understand that in some parts, usually, for example, patient can write the address for the data set, for example, I don't know, somewhere in the city, but doesn't live here in this address. So we understand it, but in Russian statistic, when so I said that we have a lot of levels of dispensary, for example, the lowest level is in the district of the city, when the doctor is writing your address, and when it's rewriting in the next level, it can be changed. So we understand that now it's a really big problem when patients say another address, or doctors write not right address, which not in the city, for example. So I can say that the most of them is right, but we know that we have a problem with that, and we don't know how to solve it, because it's must to change all medical system. I think it's impossible in real situation, because we have a lot of another problems.
Right. Okay, thank you.
Thank you so much. Thank you.
Yeah, I think there are no other questions, so we might move on to the next presentation.
Everyone, I would like to begin by acknowledging the traditional custodian of the land on which we are tuning in today. For me, I'm on the land of the Wurundjeri people of the Kulin Nation. My name is Sulin Choi. This presentation will provide an overview of the Australia-Japan Quasi-Zenith Satellite System, or QZSS, Emergency Warning Service Trail Project, which took place this year in 2020 in Australia. I would like to acknowledge my co-authors on this paper, who are listed on this page. There are 5 parts to my presentation. I will begin by providing an overview of the trial project, including previous work and the project objective, followed by a description of the technology behind the Japanese Quasi-Zenith Satellite System, or QZSS Emergency Warning Service. Then I'll do a quick rundown on the methodology adopted by the project team, including a summary of the finding and lesson learned, and I will conclude with a few note points on opportunities and recommendations for next step. As the title suggests, this project is a joint collaboration set up this year in 2020 between the Australian and Japanese governments. The aim of the project is to test the use of the Japanese navigation satellite system, called QZSS, and its emergency warning service for disaster management and alerting in Australia. This slide shows the project consortium led by Japan Cabinet Office, Geoscience Australia, and Austrade. The National Space Policy Secretariat of Japan Cabinet Office provided Australia with access to the QZSS satellite signal for testing, and SoftBank provided the GNSS receiver for use in the project. Frontier SI, the University of New South Wales, and RMIT University provided the research and technical support during the trial. Emergency Management Australia, together with New South Wales Spatial Services Group, the State Emergency Services and Rural Fire Authority, were engaged as stakeholders and offered their support for the field test. The QZSS EWS service provision concept is a satellite-based emergency warning service. On the left, a disaster or emergency is observed, monitored, and information collected by a relevant emergency agency. The control center identifies the appropriate information, including details and location of the disaster. A warning message is prepared by the control center for transmission through a satellite broadcast. In this case, using the Japanese QZSS emergency warning system or service for satellite broadcast to users on ground who are in the affected area. QZSS, or Quasi-Zenith Satellite System, is the Japanese version of GPS navigation satellite technology. At present, QZSS is a 4-satellite constellation with plan for expansion to 7 satellites. Besides positioning, navigation, and timing capability to complement GPS, QCSS also offers augmentation services to improve the positioning accuracy of GPS, as well as an emergency messaging service for disaster alerting and management. The service coverage of QCSS include the Asia and Pacific region, as shown in the figure on the right-hand side, with the satellite ground track of a figure 8. There are currently ongoing investigation on the extension of the QCSS emergency warning service and augmentation services outside of Japan into the Asia-Pacific region. Prior to this project, the first investigative study on the use of QCSS EWS in Australia was conducted in 2014 to 2015. The aim of the initial study was to evaluate the potential utilization of the technology in Australia, in which the project team identified bushfire and flood alerting as potential utilization cases. Subsequently, in 2018, Australia participated in the European Galileo-based Reliable Automatic and Low Latency Emergency project called GREL Warning Service Project. A series of field tests were conducted with the QCSS system in Victoria, in which the project team confirmed reception of the emergency warning service signal. In early 2020, following the disastrous 2019 and 2020 Australian bushfire season, the National Space Policy Secretariat of Japan Cabinet Office set up a joint project with the Australian government through Geoscience Australia to undertake a feasibility test and capacity building project on the use of GNSS EWS technology in Australia. It is to note that Japan and the European Union are collaborating towards a common message format for their emergency warning services, in which the definition of the common message format will be published through the Navigation System Interface Control Document, or ICD. The EWS signal by QCSS will be broadcasted on the L1S signal using message type 44, while the European Galileo system will broadcast the alert messages on their E1B and E5B signal using the INAV navigation message. It is also worth mentioning that the EWS message format is aligned to the Common Alert Protocol, whereby the emergency warning service provider worldwide can encode their alert messages and send to QCSS and or Galileo satellite for broadcasting. Ultimately, standardization and common message definition will enable and enhance service adoption at the end user level, irrespective of the satellite, whether it's QCSS or Galileo or both. The QCSS emergency warning message contains standardized information of 21 items, as shown on this slide. In the trial project this year, 2 emergency messages were being trialed, namely for tsunami and bushfire alert. The emergency messages were decoded and transmitted as hexadecimal messages. Examples of the tsunami and bushfire messages are shown on this slide. A series of tests were conducted in Q3 of 2020 in Sydney and Melbourne using the GNSS receivers provided by SoftBank. Bench tests were first conducted to ensure that the Australian tailored and created messages were correctly transmitted through the QCSS satellite and received on ground by the SoftBank receivers. An Android mobile application was developed by the project team in a fairly short period of time to mainly do three things. One, to import the raw data from the SoftBank GNSS receiver. Two, to decode and display the emergency warning messages using geofencing method, meaning that the warning message will be displayed to the user only if the users are within the affected area. And thirdly, the mobile application will store the log file on the mobile device. Field tests were also conducted from the 12th to 13th of August this year to engage with stakeholders such as the New South Wales RFS and SES and to obtain feedback from them about potential utilization of this technology. From this trial project, the Australian tailored warning messages could be transmitted through the QZSS satellite for broadcast and received at any location outdoor in Australia. The messages embedded in the QZSS early warning service signal can be decoded with a suitably designed mobile application. There were, of course, technical challenges due to the mobile application in alpha stage of the development and the usage of the SoftBank receiver. But with time constraint in this presentation, I won't go into the details of those challenges as they were already described in details in the paper. The project team has also learned that the satellite-based GNSS emergency warning service technology could offer wide area service coverage in Australia, and the service is independent of ground communication network. More importantly, this service can be scaled easily due to the nature of satellite broadcast, which means that the service is able to support high volume user in the event of a national emergency. Last but not least, the 2020 trial project is just the first step in building capacity by the Australian consortium to create, transmit, and decode Australian tailored warning messages for satellite broadcasts. There are opportunities for stakeholder engagement and consultation with aim to establish strategic and operational plan for GNSS-based emergency warning service implementation in Australia. Support and investment is also required to further develop the mobile application using next generation space and spatial innovation. The application should be well advanced to integrate information from various sources, and is well designed, fit for purpose, for use in emergency response and management. To end, I would like to once again acknowledge the support and contribution provided from this organization to the 2020 QZSS EWS trial project. Thank you for listening.
Okay, so Sulin can't be with us today, but one of her co-authors, Abdu, is very welcome for this session, as well as, I think, prepared to answer some questions.
Yes,
so,
indeed.
We have a question from Fiona, which is about the existing New South Wales Emergency Plus app, and can this be used for the messages from this satellite system?
Yes, thank you, Fiona, for your question. Right now it was in a trial phase, this whole project. We were just trying to see if effectively we are receiving the signals from the satellite and if we could associate with it some spatial analysis, and that's why we made this app and put the information on the map and be able to visualize it and transmit the information in some different ways. In the later stage of this project, the idea is exactly to integrate this information in the already existing apps from the emergency services. But obviously it requires a lot of studies before. So first of all, if the way we are answering, or if the way we are communicating the information is relevant or suitable to their systems, because depending on the type of hazard, not the same services are contacted. So there are still a lot of steps to do there, and this is one of the main goals of the next stage of this project, is understanding the type of messages or the type of communication that the people on site will require. And hopefully at a later stage, it will be some kind of features directly integrated to the existing apps.
Thanks, Adu. Look, I have a question myself, which is, I think, perhaps slightly related. Is there a limit to the message length or the string length that you can have in this system in terms of the satellite process? Do they have any limitations on the length of the message string?
Yes, so indeed there is a limit. So it was, if I'm not sure, it was I forgot the exact number, but the message was very limited. So that's why it was encoded in the hexadecimal, and then you have to decode it behind. And so there is a table with correspondence depending on the type of hazard. So all the app that we develop is exactly doing that work, which is the whole decoding part. And once it's decoded, yeah, it can be communicated way differently, because then you have a better understanding of everything. And this is exactly why we are studying if using a map, for example, with some alerts, just some logos, etc., will be a more efficient way of communicating this. And obviously, the more technical information are still embedded. So you have the locations, you have the type of signals, you have the type of hazard, so the level of severity, etc. So it's pretty comprehensive, but everything is compressed from the satellite. So yeah, so decoding and then let's say translating to something readable.
Okay, so a lot of these emergency services apps that currently exist often have quite detailed strings, quite detailed instructions in terms of what they're trying to communicate to the population. So
yes.
For the case of this satellite signal providing, if you like, triggers for particular types of messages to be published to the users.
Yes. So because right now we are not, I mean, we are mostly trying to use this for the first responders. So yeah, so we need to understand better their protocols and speak their own language, basically. But the good thing with having the core information is exactly you can translate it into several aspects. Maybe if you want to communicate to people on site, if there is a bushfire, you want to send a message to people traveling in near those areas, then of course you have to adapt the message differently. So we are exactly looking at this kind of platform, which is intermediate between the pure message and all the services around, and eventually the end users or the people on the field who just may need to be prevented that something is about to happen.
Great. Well, thank you. There are no other questions in the Q&A. So
I see just one quickly from, I think it just arrived from Kay.
Okay.
Asking what was the feedback from New South Wales RFS and SES? Yes, so yeah, I just answered that because I could see it just right now. So yeah, so they are pretty positive with this whole project. So they are very supportive for the next phases of the project, and we are actively discussing with them and exactly about understanding how they could take the best value out of this development. So we are still communicating with them for the next phases of the project.
Okay, and there's another comment that just popped up in the chat from Sissy saying that the message length is 254 plus 2 bits.
Right. So
56 bits altogether.
256, exactly. Okay, so yeah. Thank you, Sissy. I didn't want to say a wrong digit.
All right, so we might move on to the next presentation, which is from Fiona Lord. So I'll hand over to the video.
Good afternoon, my name is Fiona Lord and I'm a researcher at the Institute for Sustainable Futures at UTS. My presentation today is from my doctoral research on the topic of urban transformations to sustainable and resilient futures in Southeast Asia. Today I'm going to provide an overview of the trends and emerging challenges associated with sustainability and resilience in Southeast Asia. I will make the case that these challenges associated with rapid urbanization in Southeast Asia require urgent attention. I will provide an overview of Southeast Asian policy and strategy responses to address these urbanization challenges. And then I'll provide a research agenda for harnessing the potential of transdisciplinary research to assess and support the urban transformation process to accelerate sustainability and resilience policies and strategies and their implementation. I will now start the first part of this presentation and discuss the urbanization trends and sustainability and resilience challenges in Southeast Asia. The first trend to highlight in urbanization in Southeast Asia is the rapid and uncontrolled development that has occurred since the 1990s. Like many other parts of the developing world, urbanization has not been carefully planned or managed in many cities of Southeast Asia. Urban development has been primarily market-led and fueled by land speculation. Long-term urban plans have in many cases failed in Southeast Asia, even if they have been aided by planning tools or zoning codes, because they have not sufficiently responded to the dynamic political economy and social cultural practices that determine city growth. The OECD has found that most city-level spatial development plans in Southeast Asia are not formally adopted as legally binding and mainly regarded as indicative guidelines. As a result, urban landscapes have been rapidly reshaped by private development projects. The urban real estate boom in Southeast Asia is not slowing down due to the COVID-19 pandemic. The second major trend is the rising public infrastructure deficits in Southeast Asian cities. Investment in urban infrastructure has not kept pace with the demand and population growth in Southeast Asian cities. The challenges associated with infrastructure are chronic. These include the increasing costs of service provision, inadequate, outdated, or poorly maintained infrastructure, poorly performing institutions, and in particular, congested roads and the prioritization of cars over public transportation. In both Cambodia and Vietnam, the two case studies of my research, investment in urban transportation, urban sanitation, drainage, and water supply has not kept pace with urban growth. For example, in Phnom Penh, where you can see the photo on the top right-hand side of this slide, there is no wastewater treatment infrastructure in a city of more than 2 million people. Also, major transportation projects have been stalled in major cities of Vietnam and Cambodia due to insufficient funds or technical problems. And as highlighted on this slide, these have been further stalled because of the pandemic. Furthermore, with insufficient investment in solid waste management, infrastructure and services, up to 30% of solid waste is not being collected regularly in Southeast Asian cities. The third major trend is the increasing resources consumption levels and contribution of Southeast Asia's cities to climate change. The number of middle-class people in the region is rapidly increasing as the urban population's desire for a higher quality of life increases. There is a growing level of resources consumption. Industrial development linked to global supply chains is a major contributor to growing energy and water consumption in Southeast Asian cities. Resource efficiency is needed in a range of urban systems, including industry, buildings, and transportation, as well as for the metropolitan area as a whole. While both Cambodia and Vietnam have low levels of carbon emissions currently on a per capita basis, their emissions are growing exponentially with economic growth and urbanization. The fourth major trend is the declining livability of cities and their increased exposure to environmental contaminants in Southeast Asia. Urban populations have become increasingly exposed to air pollution and environmental contaminants. Without sufficient drainage infrastructure, communities are increasingly exposed to floodwaters, particularly in peri-urban areas. There's illegal dumping of waste and septic tanks being discharged illegally into rivers and waterways. Industrial emissions are increasing significantly from the manufacturing sectors in particular, and overall urban livability is declining with traffic congestion, air pollution, and shrinking urban green spaces in cities. The fifth major trend is the increase in vulnerability of urban residents to climate change and disaster events, particularly the urban poor. The risk of urban flooding and storm surge is increasing due to increased intensity of monsoon rains and expanded urban development in hazardous locations, particularly in coastal cities. On the map on the right-hand side of this slide, you can see the extent of the recent flash flooding event in Cambodia in October, which affected around 176,000 households, particularly in urban areas. Because of the rapid urbanization processes, natural ecosystems are becoming more and more vulnerable to floods, the clogging of rivers, and the infilling of urban lakes, and the destruction of mangrove forests and wetlands. As seen on the graphic on the left-hand side of this slide, the urban heat island effect is also impacting lives in Southeast Asian cities. So in Ho Chi Minh City, where this research was undertaken, temperatures are expected to increase by 1.2 to 1.7 degrees Celsius, in addition to existing climate projections because of this urban heat island effect. So overall, these trends have resulted in a breakdown of economic, social, and environmental infrastructure in urban areas. While urbanization has had a transformative role in Southeast Asia's economic growth story, the urban transition is currently described by a range of scholars as currently incomplete and fundamentally unsustainable in Southeast Asia. I will now move to provide an overview of Southeast Asian policy and strategy responses at regional, national, and subnational levels, focusing on Cambodia and Vietnam as two case studies. At the regional level, the Association of Southeast Asian Nations has established a number of initiatives to support urban resilience and sustainability. ASEAN established its Framework for Sustainable Urbanization in 2018, and under this framework, sustainable urbanization is supported through a range of pilot initiatives and technical cooperation. This is also supported by the ASEAN Smart Cities Network and the ASEAN Initiative on Environmentally Sustainable Cities. In this slide, you see the strategic focus areas of the ASEAN Sustainable Urbanization Framework, which include civic and social, health and well-being, security, industry and innovation, the built infrastructure environment, and the quality natural environment. Cambodia has provided national and subnational policy guidance to its cities on urban green growth and sustainable development. Cambodia has endorsed a national policy for green growth and has established a guide on the urban development process called the Green City Strategic Planning Methodology. Cambodia's capital city has established its Phnom Penh Sustainable City Plan, which goes to 2030, and sets a vision that by 2030, Phnom Penh will become a clean, green, and competitive city, offering a safe and quality lifestyle to its residents. Vietnam has also provided national guidance on urban green growth and climate change action planning to its cities. So the Green Growth Vietnam Urban Development Plan to 2030 was established in 2018, which you can see on the left-hand side of this slide. And this has been used by a range of cities to develop green growth and climate change action plans. I'll now move to the opportunity to harness the potential to accelerate urban transformations through transdisciplinary research. Sustainability transformations theory has emerged in global political discourse and scholarship over the last 10 years or so, focusing on the depth and the breadth of the changes that are needed to address global sustainability problems. Transdisciplinary research involves multiple forms of expertise and more explicitly links academic research to practical forms of knowledge. As seen in this slide, transformation involves moving from niche innovations towards social technical regime changes and then landscape changes as markets, industry, policy, culture, science, and technology all support these wide and deep transformational changes. Urban transformative capacities are needed to initiate and sustain urban changes towards sustainability. So as seen in this framework developed by the scholar Wolfram, there are multiple transformative capacities that can lead to transformational change in cities. These include leadership, communities of practice, systems awareness, and inclusive and multiform governance. Using this framework in my doctoral research, I am planning to investigate case studies of rapidly urbanizing cities in Cambodia and Vietnam and analyze the strengths and weaknesses of their capacities and their potential transformational changes that could come through increased transformational capacity development in these cities. I will be holding participatory design workshops involving a range of urban stakeholders in each city to analyze the institutional arrangements and the potential governance improvements to achieve sustainability transformations. This will take a cross-sectoral approach, looking at a range of urban systems and sectors and drawing on nexus and systems level thinking. Ultimately, this research will support identifying the constraints to urban governance and what are the potential sustainability reforms. It will help to promote existing governance nodes, leadership support systems, experiments and innovations that are contributing to urban sustainability transformations. And it will empower participation and co-design processes to strengthen networks of urban transformation. Please get in touch if you are interested in collaborating on this research agenda on sustainable urban transformations in Southeast Asia. Thanks for the opportunity to present at this conference today.
Okay, thank you, Fiona. And your camera is on. Can we get Fiona up on the screen?
There you go. Can you see me?
Yes, thank you.
Great.
So there is a question in the Q&A, Fiona, about sustainability. And do you think sustainability can be reasonably expected or reached in a fast-paced urbanisation context?
Yeah, thanks. That's a great question. You look at the rapid housing and construction that's happening in these cities, how quickly these buildings are being constructed. In terms of sustainability, the opportunity is there for those buildings to be designed in a more sustainable way. So if these cities put in place incentives or policy measures to support urban construction that is more energy efficient or water efficient, those buildings can become more sustainable. It becomes, very challenging when a lot of the construction is in the informal sector. So if construction is happening in slums or informal settlements, but as the cities grow economically, there's a lot of real estate that is formalised, and that's where the real opportunity is there for that construction to be more carefully planned. And for example, in the condominiums and the larger building sites that are being built, they can align to green building codes or sustainability standards that might exist elsewhere in the world, as an example.
Okay, thank you. And look, I have a question which is, I think, a little related to that, and it's around the impact of these changes and developments on the energy demands within these countries, because often this seems to be a trend of relatively low energy footprints, if you like, to much higher energy footprints. And how is that sort of dealt with in this sustainable framework?
Yeah, so energy is a really important aspect of urban sustainability, both for consumption and the source of the energy. So, for example, in Cambodia, they've put in place a national energy efficiency policy framework, but there's still a lot of capacity development needed to implement that policy framework. So that's where it goes through to the industrial activities and the building construction. How do you make sure the private sector is involved in implementation of that energy efficiency policy and strategy, and have the right incentives in place to support private sector participation in energy efficiency investments? On the other hand, in terms of the source of energy, there's also opportunity for solar power, of course, and other renewable sources. So it's really important then that policy measures are put in place and incentive programs so that as these cities grow and their demand for energy grows, renewable sources of energy can become the main source of power for those cities.
Okay. There's no other questions in the Q&A at the moment, so I might keep going if that's all right.
Yeah,
and ask a question. You mentioned a few times about the government's providing national guidance for city developments and things like that. And the governance structures in these countries, I suppose, is a little different to some of the structures that we're used to here. But one aspect of that sort of guidance and policy framework is also enforcement. And how does that work in these countries?
Yeah, that's a really interesting question, and it's one that I'm hoping to focus on in my doctoral studies over the next few years. So enforcement as well as incentivization. So one opportunity is to look at how are national funds used to incentivize better planning and implementation of these sustainability plans. And on the other hand, what sort of capacity is needed to ensure there's enforcement of pollution control measures. So while some of these countries, including Cambodia and Vietnam, do already have environmental protection legislation and pollution controls, at the moment there's often insufficient capacity for enforcement and maintaining quality standards, particularly in manufacturing, but also in other sectors. So that surveillance and enforcement capacity really needs to be built up as well, is what I'm expecting to see. But I'm planning to implement this research over the next 2 years.
Okay, thank you.
Thank you.
So there doesn't seem to be any other questions in the Q&A that I can see.
Okay, thank you very much for the opportunity to present today.
Thank you, Fiona. And look, thank you to all of our presenters today. It's been an interesting session. We're a bit ahead of time, but I guess that's what happens sometimes with these virtual type events. But thank you to the audience who've attended. I hope you got something useful out of it. And that might bring us to the end of the session. And just by the way, my name's Chris Bellman. Sorry I wasn't online earlier. There was just a bit of a problem connecting up, but we got there in the finish. And thank you to the conference organisers. I know that putting together these sort of virtual events is pretty tricky, and I think you've done a pretty good job. So thank you.
Thank you, Chris.
Thank you, Chris.
Thank you so much.
Thank you, Chris. Thank you, everyone.
Okay, well, we might close the session at that point. Thank you all.
No, not.
Jack, how are you, mate?
Good day, Nathan. How are you going?
Good.
That's
All
good.
set up and ready to go?
Yes, we're like a powerhouse here. Even though we've had a lot of tech issues, we're knocking them down one by one. So,
It wouldn't be a conference if there wasn't some tech issues.
not at all. That's it. You know, yeah, it's like the spice in the food. You know, you need to have that certain level of irritation to retain the information optimally, I think. You know. But yeah, no, it's been going well actually. Yeah, you're welcome to join in for any of the other sessions if you want, or you've got access to all the recordings and that as a VIP panelist. So.
Yeah, I've actually there's one this afternoon, that the keynote that I might join in on. I think that's at 4 p.m. my time. So.
Yes, excellent, great.
Are you getting good numbers?
No, it's very small. We're getting about 15 people watching the feeds directly, which is okay. You know, I mean that's. You know, apparently it's, a bit of a rule of thumb, like you get about half the registrants, and that's, we've had about 30 people each day. Of that, we've had, 40, we've got 36 authors. So, look, it's all right. I mean, it's a pretty sort of tight little community, and also at the end of the year, also a paid conference, in retrospect, I think, certainly, it would have been a lot easier just to, we've had a lot of access issues and, people getting in, better, just to make it free and open, I think, for the next one. But, yeah. Robert, how are you? How you going, Robert?
Oh, good, thanks. So my earphones were playing up on me.
No worries. They're working right now. So,
unfortunately, yes. No, it's good. It's good.
Yeah. How are you, Rob? Are you from Aerometrics, Rob?
Yeah, I am, mate. I am, yes.
Nice one. How long have you been there for, mate?
A year and a bit now.
Nice one.
But I
based in Adelaide?
Yeah, based in Adelaide. I used to run the Spookfish, which became Airgoview. I ran their sales team nationally.
That's right. That's right. I remember you.
And then prior to that, a lot of work with software and IT companies and healthcare and logistics and around the traps. It's been good.
Are you keeping Todd and Dave in check, mate? It'd be a hard group to manage, I would have thought.
Yeah, I don't manage them, and I don't know who does, actually. I don't think anyone does, do they? Dave is Dave's Chief Operating Officer now, and Todd's doing very well indeed. So, yeah, they're all going very well, very busy.
Good, yeah, mate.
Jack, we caught up, didn't we, last week?
Yes, on it would have been online with a group. If Sissy was there, I would have been there. Yeah,
it was the Voxel team. And
that's the one.
We had Sam and Fab presenting our data.
That's it. Yes. Yep. We're very keen on our voxels at Grid.
No, and it's what's going to come out today. Is there's a place for everything.
Yeah,
absolutely no one solution that fits every box, unfortunately, for the corporate and government.
Well, yeah, I mean, even at that level of raster versus vector, voxels are a very good, halfway ground. They have benefits that either don't really can't really exploit, by themselves.
That's right.
Yeah,
exactly.
Yeah, you guys are getting a lot of. I'm seeing you guys around all the time now. You're publicising well, and
we're like a rash. We're everywhere.
Yeah. Yeah. Got a friend in the film industry who excitedly sent me a few links and going, "Oh, have you seen these guys?" And I'm like, "Yeah."
Yeah, that's our 3D guys. We can actually take our data we do for 3D now and put it straight into a gaming engine. So when people actually want to say, well, let's do a proper video game around Sydney or Melbourne or Brisbane or somewhere, we can go and capture it live as it really is and put it straight into the system for them.
Yeah, brilliant. That's yeah, something we could only dream about a few years ago, really. Yeah.
I used to work for a simulation company, and that was the holy grail. And I end up at site at Aerometrics and go, oh, found the holy grail for simulation training, if nothing else.
Yeah, sure. Yeah, I mean, I used to sort of scoff at the idea of digital twins, with all the data sharing issues and having multiple people, collaborate around certain standards and things. I said, oh look, I'll believe it when I see it. But right now, well, really, the technology's made it all possible. It's any barriers are just not really technology based. Now I think. So.
And if you look at what New South Wales have done with the digital twin, that's actually our data, and that's not our best stuff. Right. So we're actually chatting about saying, okay, you've used our base level. Do you want to use some good stuff?
And how's that business model working? That's all.
Yeah, for us, that was a way of getting 3D out there into the market and breaking. Sure. The big problem with 3D has been breaking the market perception that it's only useful in a little tiny small area. Yes. By working with Spatial Services New South Wales and going digital twin over an entire region of the city, they've been able to make the market sit up and say, well, actually, there's much better benefit here. So you can start to tie in Internet of Thing type data acquisition points, and where the world will be in 5 years is going to be a totally different virtual space, I think.
Oh, absolutely. It's well, I mean, if anything, it would be a real triumph for it to be a very just a simply boring day-to-day administrative space. I think the work that look, it's not often I pat the government on the back, but Service New South Wales has been a great website and web presence. I think I think they've really done a good job there, and I've heard it's got a few awards, and I agree with that. And I can really see the digital twin stuff just becoming, we'd wonder how we got by without it, with the what the Spatial Services are doing, tying it all to the land titles and strata, I mean, all these huge hurdles we've had in terms of land administration.
I think the one thing that the digital twin's showing is where there's a distinct lack of data.
That too. I mean, that's
likely what's going to come up first of all. Is there are some very, very large voids out there.
Yep.
And the voids need to be filled as economically but as efficiently as possible.
Yeah, sure. Yeah. Let me just sort of do a bit of housekeeping. I'll just see how all our other panelists are going. Yeah.
So how do you know the guys here, Nathan?
Been mates for a long time. So I've been in the industry for, show my age, but 20 years.
and close.
Any second now. Okay, guys. Let's start in 10 seconds.
Okay, I think it's time to start. Welcome everybody to today's session on emergency management. I'd like to start off by acknowledging the traditional custodians of the land on which we meet today and pay my respects to their elders past and present. I extend that respect to Aboriginal and Torres Strait Islander peoples on the call today. Today we've got some three really experienced remote sensing and emergency management luminaries from our industry. I've worked with them all previously, and I'd like to just introduce them if I can. Raphael, are you online?
Yes, I am. Hi.
Excellent. Raphael is an extensive background in satellite and Earth observation, building remote sensing applications and data management tools, especially in the areas of risk mitigation and disaster recovery. He has been involved in many international initiatives to improve humanitarian action and disaster response. Robert, I think I can see you. Robert, are you?
Yeah.
Your arm?
Afternoon, everyone.
Robert, currently strategic business development at Aerometrics. Previous roles in consulting to several large agencies and corporations relating to strategy, situational appraisal, problem solving, technology migration. He's had his experiences across healthcare, logistics, software development, and technology systems. His background covers sales, strategy, development, business management, data analytics, and he's currently completing a master's in data science. He wouldn't consider himself a trained GIS expert, but he's been focusing on selected the right tools and technologies to answer questions and problems. He sees it all about the problems. Now, Nathan, coming from the West Coast, Nathan is an executive director of NGIS Australia. Since commencing operations over 27 years ago, NGIS has grown to become a leading geospatial consultancy in the Asia-Pacific region and partners with global leading technology companies such as Google and Planet. Nathan has 20 years' experience in the geospatial industry, servicing clients across a wide range of sectors, including resources, agriculture, utilities, government and transport. More recently, Nathan has worked on a range of international projects focused on sustainability development goals, including climate change, biodiversity, sustainable resourcing and disaster risk reduction. And my experience with Nathan was we actually won a couple of awards together for addressing Tropical Cyclone Pam a few years ago. So what I'd like to do today, because we've got quite a limited amount of time to actually complete this panel session, is to actually do a scenario. And so the scenario is based on a real hurricane that hit the east coast of the US in 2019. And in one of the words that is used more often than not when we're watching the news today, it was unprecedented. And unprecedented means that it actually formed in the off the Bahamas and then basically went from the Atlantic Ocean up the east coast. The interesting thing for me as I observed this hurricane is that it actually travelled such a long way from Florida. So when we consider looking at other countries, we sometimes lose sight of where latitudes are in relation to Australia. So this particular hurricane followed from Florida, Georgia, South Carolina, North Carolina, and Virginia. And it intensified to a Category 5 storm at around 30 degrees north. So if we go and align that with the Australian coastline, basically it hit the coast at Brisbane as a Category 4, and by the time it got to Sydney, it was a Category 5, and as it went on its merry way, it didn't start dropping below a Category 4 until it left Melbourne. So when we think of that in the context of Australia, these storms are real and they are happening around the world now. And surely we should be able to have an open discussion about the what if it happened in Australia. So I'd like to, first of all, have invite Raphael to be the first, and we'll say that we've got a cyclone that's been predicted to hit the Australian coastline. Raphael, what are the kind of things that you would need to do to prepare for this for the cyclone coming?
Thank you, Peter. I think the first thing that comes to mind. And you'd be surprised how often, there is a complete lack of, baselining. So basically establishing the baseline of the current infrastructure. I've been working a lot with several cyclones and hurricanes across Pacific Islands and Southeast Asia, and very often, being contacted by the emergency services, turns up that, there's absolutely no infrastructure baselining. There's a lot of talk everywhere about the digital twin, but very, very few organizations actually are ready for this type of assessment. So obviously, you have a different imagery sources, you have a different geospatial data that goes into that, but that database, that digital twin, whatever you call it, the foundation of the baseline information is absolutely number one thing that needs to be in place and needs to be up to date, because especially post assessment, afterwards, you're trying to estimate the extent of damage, and you cannot really do that if you don't know what was happening there in the first place.
Excellent. So what sort of sensors would make a difference? What sort of data outcomes are you wanting, and what sort of sensors would you actually use for that sort of collection?
So there's obviously, you have to start somewhere. There's lots of data available, in the national emergency management organizations. GIS data. The challenge that I see is, those data sets are sitting in different silos, and, very often, like a fire emergency doesn't talk, to other organizations and so on. So it's critical to have, the consolidation of those different data sets. When it comes to sensors, you can utilize, the existing aerial imagery that federal governments and state governments have at their disposals, which are complemented by satellite imagery and by other sensors. You have a lot of investigations going on through a number of UAVs and others. I think one other thing I wanted to add on that point, Peter, as well, is that the weather data, because that's maybe on the top of the GIS. Nobody's really looking on the weather data, so you really need to have like US has really nailed it. They have a really good weather forecasting systems. That will be also something that is critical to have.
Excellent. Okay, that's fantastic. Now, I'd like to sort of suggest that now the cyclone has hit Brisbane, and just like Dorian, we're expecting a storm surge of about 5 metres. It's probably a little bit unfair, Nathan, because you're from Perth, but what are the kind of things that you would, what would you do? What would you instigate in this event? We've now got the cyclone hitting Brisbane.
Yeah, and following on from Raphael's comments, the first thing for the first pass assessment for first responders is really those early models of likely impact. And as Raphael mentioned before, that really relies on having a lot of that infrastructure and population information available. And that's the key first data product to try and identify where the likely impact is going to be to coordinate response efforts. And that will evolve. So as you mentioned before, Pete, as you come across Brisbane, go down to Sydney and then to Melbourne, that information evolves all the time. And it's important to keep those models up to date for first responders. And then as the events progress, you move from doing those models into actually what's happened on ground. And that's really the great opportunity for remote sensing data to provide intelligence. So then we're looking at impact and damage assessments. So if we're looking at a 5-metre storm surge, as you mentioned, Pete, you're looking at infrastructure and population really combined with the event coverage and severity to try and identify where response is required. And more so what we saw with the work we did in the Pacific, Pete, was the need for real-time or near real-time communication of activities. Once you get different organisations involved, and in some situations different languages, the use of map-based communication is such a really effective way of communicating current state. So you've got those type of processes required and the need to access centralised information. But what we tend to see here is an inundation of data. So it won't be just UAV, it won't be fixed wing, it won't just be satellite, it'll be all of the above. And it will really depend on the extent of the event. So the challenge then becomes how to use that information effectively, and not just for visual display, but also how do you actually use it to get the analytics required, which we see is the most significant challenge for disaster response at the moment is really that end-to-end supply chain and use of that data to give you the analytics and information you require. And that happened, so going off target a little bit, but with the bushfires in Australia earlier this year, is the inundation of data that was available from a number of different vendors and the need to be able to consolidate those workflows to get the most out of that data.
Sure. Okay, so the next one is we've got the cyclone now moving down the coast. And Robert, it's about to hit Sydney, and it's probably the most challenging thing to go and consider Sydney, because I think it's bad enough when it hits Brisbane, but I'm actually from Brisbane, and we actually have our housing and our infrastructure has a cyclone rating. But if you have something like that hitting Sydney, there's a whole bunch of different things, I imagine. What do you expect? The storm surge for Dorian was 7.4 metres at this stage. So what do you expect to have to do, and what actions?
Yeah, it's really comes down, if you look at what Raphael said with the baselining, is you really want to be pulling a lot of the original data that you've acquired, be it 1 year old, 1 month old, even 10-year-old data is going to have some value depending on, obviously, on the type of data. Unfortunately for Sydney, it's not cyclone rated, so number one is there's going to be a hell of a lot of debris flying around. But realistically, you're going to have a combination of flooding. You're going to have a combination of inundation with water. You're going to have a tremendous amount of rainfall, I would suspect, hitting to the east of the Blue Mountains, because the rain's going to hit that and just sort of bounce back. You're probably going to have to rely a lot on the Bureau of Meteorology and obviously things like the weather company from IBM with their analysis and saying, right, show us what water levels we're getting in. Then you're going to have to really have an underlying understanding of, I'd probably say a DTM, or just a basic terrain understanding, so you can work out where the water's going to go. You're going to need to know river speeds, river flow patterns, what the tide level is going to be. All of that's going to impact it. And at the same time, since we've probably had a day to 2 days, probably 2 days warning, because Brisbane's gone to hell in a handbasket and we're sort of able to sit there going, ha, look at them, and it's coming down towards us, you're probably going to be able to be a little bit more prepared in what I'd call the recovery process. Even though it won't take effect, you'll be able to begin to stockpile resources and basic requirements that can actually sit back on high ground in safe areas. And then it's really about saying, right, what do we have to do first? What do we need to get up and running first? You've probably at this point, a day out from it hitting Sydney, you've probably, hopefully, the government's done a test on the radio network, because, run every radio at once, because usually the radios all go down together because of overuse. So it's probably a good idea that you've got 24 hours ahead of time to run some very, very quick scenarios for yourself. You're probably going to lose at 7.5 metres. You're going to lose a lot of the eastern coast of the North Shore of Sydney. Those $1 million holiday homes will be $500,000 sand piles, I think, by the end of the storm surge. But you're going to start to lose a lot of road infrastructure, power infrastructure. So that's probably what you've bulk stacked back up, further back up the hills above Sydney, ready to roll out. Generators, everything else, just to get power down there so you can start to do the recovery process. Although it might be a bit more difficult with satellite because of the cloud, you would have the planes like we have at Aerometrics. You'd have the drones ready to go. And you basically have those people up doing captures. Doesn't have to be extremely accurate. Bosses might get me not to be saying that, The aim is to get as much data as quickly as possible, and then you start to finesse that data on day 2, day 3, day 4. You'd be looking to generate a lot of knowledge from, I would say at this stage, the artificial intelligence organisation, the universities, what you can achieve in the US. IAG, Suncorp, the major insurance players already have a lot of that data there. They can start to then sit down and say, right, let's assess what's changed, run some change detection, get that data to the emergency services team as quickly as possible, so they know we can't go through, Narrabeen, we've got to go up around via St Ives and come down through, the Waitrose Parkway or somewhere else to get to some areas, because there will be heavily isolated areas. Roads will be gone, people will be panicking. It really will be, I think, would say the first 24 hours will be just control of emotion, and then let's start to roll it out. Because there's not a lot you're going to be able to do for that first 12 to 24 hours. Ride out the storm, have everything ready to go, and literally follow the storm down the coast. You'd probably start even above Sydney, Gosford. Gosford would be a good indication of what's going to happen to a lot of Sydney. That's about 20, 30 or 50 k's north, depending if you go by road or as the crow flies. So you could start to roll out those solutions coming down the coast as the storm slowly moves south. But there's a lot of rivers. There's going to be a lot of water. Places like Narrabeen Lakes are just going to go. They're, at 7.5 metre storm surge, it's tidal. You get there's going to be a lot of flooding back there, so the roads will be gone. It's going to require getting all the sensors together, all the data together. I think the government would probably be, first off, probably 2 days out, they'd be going to a lot of the data suppliers saying, we're going to buy the data, here's the open source contract, deliver it, get it to us. And they're going to have to probably set up redundant data centres because they would not have experienced this. So they're going to literally have to have 2 centres ready to go and be able to move team between it. And once the storm goes, you've probably got about 24 hours after the storm's gone is when you can start to bring up the satellite. And that's going to give you a much, a coarser view of what's there, but it's going to give you a much wider view of any potential damage. And then you can start to send the planes, the drones and everything in to really start to pinpoint where we got urgent need and start to prioritise the work from there.
Okay, so I guess I'll just ask the team. We're looking for data now to assist with where we put emergency response people, and we've discussed mainly optical satellites. Raphael or anybody, is there just optical available to us, or is there other options or opportunities for sensors that we might be able to use?
You can use some radar sensors as well. They are helpful, especially during the storm events. And cloud cover, because you can see through the clouds. Although it's just only certain type of objects that can be detected using radar type of satellites. But I think very important. Except of the optical, and there's a next generation of satellites coming, hopefully soon, hyperspectral ones. That will be a complete game changers as well for this type of recovery services. But really, I think the critical part here is there's a whole bunch of meteorological satellites available. And very few people are actually looking into combining those different data sets into one powerful database of information. Usually, like you mentioned, BOM sits on their own data sets. They do their weather modeling, but it has no interpolation into traditional models built on the infrastructure side, where the biggest impacts. So that's something that is quite important. But looking forward for the future for those new generation of satellites to come up. In the meantime, I think best we can do is just utilizing existing technologies and all the available agencies.
Okay, so thank you very much, everybody, for your responses there. But I just want to move on now. The cyclone has passed. We've got obviously a huge humanitarian crisis right up and down the coast of Australia, where 90% of us live. And we have a next problem, which is the recovery. Who's involved in the recovery? What sort of agencies? What sort of companies? And where, who's going to need data and what are their needs? Maybe I'll throw this over to Nathan to start with.
Yeah, thanks, Pete. So the recovery effort will largely be concentrated in government agencies. And in terms of what they need, so depending on the size of the event, in this type of event, you'd expect that the International Charter on Space and Major Disasters to be mobilised, which will actually provide a mountain of information from satellite vendors to actually help with recovery efforts. But then it's all around still understanding those impact areas so they can coordinate some of those response activities. And where we've seen a significant challenge is consolidating a lot of the information products. So in this particular example, we're looking at flood extents. So being very consistent in how you can integrate, and I think Rob mentioned this point as well, how to integrate multiple data sources to get consistent data products that are then used for the emergency response activities by government agencies. And whilst that's quite a challenge, it's the opportunity to use, say, cloud technology to really operationalise some of these outputs at scale. I think that's the key activity, to be able to coordinate all of the government agencies. So you're looking at a centralised point of truth and centralised data products that are consistently used. And then the other side to that equation is, yes, you've got the response and recovery efforts by government agencies, but then it's how you communicate that to the public as well, and being able to put some of these data products on extent into mediums that make sense for the everyday user. Because really that's where the value is trying to get this information in the hands of the people that need it in the best way possible.
Okay. Robert, you've talked a lot about aggregating these data sets and doing the analysis. But for the general person, as Nathan was getting to, they need it into a more consumable or a transparent environment. What sort of information would somebody who's been affected by the flood, from a remote sensing kind of environment, that we can provide them to improve their recovery from this event?
Okay, so they're going to go through a few phases. They're going to, obviously, the first couple of days, it's going to be, where am I, what have I got, where can I go, what information can I acquire? So the government at that point, probably in conjunction with the insurance companies, because they do get access to very quick data, they would probably be sitting down and saying, right, how do we get the main requirements out to the consumer? You're probably going to have to make sure that the telcos are behind this sort of support, because the customer's going to usually access this through their mobile phone. I doubt they're going to be using their laptops, because they may well have left those in their homes or in their cars that are 6 feet underwater. So you're going to have to make sure that everything is made available simply. There's tools you can get now where you can actually go down and identify your home and what's the bushfire risk. So you can potentially go, what's the flood risk for my home? I can sit there and look at it and say, right, I'm safe. We've got a stream coming. I've got 14 hours, and I've got an alert has come out to me saying I've got 14 hours to clear out my house, or to move area to high ground, and it's projected I've got to get to a certain height level. For the people that are on the coast that have probably lost their homes, they're more likely to see, where am I going to stay? I'm in the centre. I'm at a rescue or a safe location. How long am I going to be there for? When can I get back and at least assess and grieve the loss of my location, but then recover what I can, and then slowly get to build to move on. So a lot of that data that's going to come in will be required for insurance, for government, for inspectors and for assessors. But out of that, you'll start to draw some key defining components that are going to be critical for comfort is probably the key word that's going to need to go to the residents. Is they're going to need reassurance and comfort that this time will pass, what the problems they've got are being assessed properly, adequately, and at a speed that they're happy with. Not everyone's going to be happy, but the majority will be happy. And so you're going to have to be quite selective in that data, and you're probably not going to know the right data set till probably the second or third day, because you're going to get it wrong at times. So you start to pick and choose what are the data sets, and the data sets for the people up in Penrith or Parramatta that are dealing with the flooding is going to be different for the data sets for people down in Manly and Cronulla and everywhere else that are experiencing the coastal damage. And so those realistically, the people will probably be able to have a list of what they can pick from, and the data will be flowing in from the government and the organisations that are there to help, to say, right, here's what we would do. The Red Cross would have something in there. So if I've lost my home, but it's only through flooding, not destruction, you might go to Red Cross and get a certain access point. So a lot of the not-for-profits are going to play a key role in that first day or two of engaging with the people with the data, and they're more likely to know from their experience what's the information that people will want. So what the government and industry is going to need to be able to do is to say, once we supply the data to those emergency sectors inside government or not-for-profit, you'd probably say that, we would have people in there saying, right, you want me to pull an algorithm out to give that piece of data, bang, I'll pull it out and I'll present it to those people in this format. But more than likely it'll be through mobile phone. I mean, you've even got the case of identifying people, birth, deaths, marriages. That's gone. You'll assume that's gone. It's been flooded out. So that's going to have to be able to be handled by people on mobile phones. So
yeah, a lot of people, like COVID, everybody be working from almost home. Yeah. Okay. Okay. So look, we're going to open it up for some questions now. What the questions being managed through the chat feature. So if you have a question, please type it into the chat feature now, and we'll get it to the panel. And while we're doing that, I'd just like to ask the panelists while we're waiting for the first question to come up. We've got a couple of indication that there's going to be a kind of a mobile workforce, an app or whatever, and you're now 2 years after the tropical cyclone Dorian hits, and you're standing in front of a property that's on the beach of the northern coast of Sydney, and you know that during this cyclone event, it didn't used to be beachfront. Something else was beachfront, and this was the house behind it. How do you cope with what are the information sources that I'm going to get from an insurance company? There's already insurance companies that don't actually insure Northern Australia. They won't insure houses north of Rockhampton. They are de-risking their profiles, and we haven't mentioned the term yet, but there's obviously a switch here that is based on climate change, which is causing these the frequency and intensity of these events. The insurance companies have turned this into a financial question, which is, am I going to wear that risk, or how do I deal with that risk? How do you see that sort of information from an insurance and a person who's insuring their property point of view, translating into an app or a search for a house or something like that? So I'm now, after the event, I'm now looking for a house. I love the idea of a beach view. This house is in my property, but I now want to go and have a look at, what data sets am I looking for and how do I get that information? Do you want to have a go at that, Raphael? Just quickly, because we only got a couple of minutes.
No worries. Yeah, I think this goes back to this databasing and baselining, this digital twin. So to answer your question here, to answer the audience question, insurance companies are only starting looking into the geospatial data sets. They haven't done it very well up until now, but there's definitely a movement and trend in trying, to categorizing, the risk zones and following up, the discussions with the different councils and state governments into for the average Joe to be able, okay, so I can look here on the map that is published, by the state government and see, okay, am I buying a house, in the risk zone or not? And, will I be able to insure it? And just, as a coincidence, just only yesterday here in New Zealand, insurance companies has announced that, all the 450,000 houses alongside, the cost of New Zealand, the insurance premium will either go up or half of them will not be able to insure at all because they don't want to risk themselves.
So we've got about 2 minutes left. Have you got any closing remarks, Robert?
Yeah, I think it's more about I think what you'll find is change will take time. Change will take time from the data we get, and change will take time for the climate it'll get worse, but it'll fluctuate. I think what's more important than anything else is that there is that need to establish a solid baseline now, be it for bushfire, be it for disaster management, be it for anything realistically. And I think that's where some of the digital twin work is probably going to play a key role in driving that. And it's really about sort of identifying scenarios where, if you think about it, councils that are along the coastline are going to run out of money eventually because houses will be worth nothing and they'll have no money. So there's a lot of change that's coming, and the only way to judge that change is from a baseline. So as Raphael said, probably the most important thing from today is we need to establish a solid baseline of all facets of the environment.
Thank you. And Nathan, closing remarks from yourself?
Yeah, following on from Rob, it is that baseline information, and we've seen previous issues with hurricanes in Puerto Rico where they identified the key challenge was the lack of that information to be able to coordinate disaster response activities. So that's crucial for us. The key challenge we're seeing, as I mentioned before, is really the use of all of the different information products and to be able to streamline those processes to deliver the outputs required. I think that's the real opportunity, particularly for government currently, to take advantage of that.
Excellent. Okay, so I think we're right on the hour now. I think that's where we're sitting.
So apparently Boris Wagner may connect instead of Sebastian. Hi, Boris.
Okay. Yes, Boris is here.
Hi,
Hi, Boris.
Good morning from
here?
Germany. Yeah, I'm here for Sebastian, my colleague.
Okay,
is not available.
Perfect. Okay, so I think we can already start the session, if not all done.
Okay.
Is it live? Wait.
Yeah. Yes, I already started the send it to live now.
Okay, perfect. So we can go ahead, Graciela, please.
Okay. Well, good afternoon from Sydney, Australia, or good morning for those of you that are in Europe, and good night for those following us from the USA. I'm Professor Graciela Metternich from the Faculty of Science in the University of New South Wales, and I'm chairing this session number 9 on managing disaster and change. We have, as with the other sessions of this online conference, we have four pre-recorded videos, and the dynamics is that the presentations will be through the pre-recorded videos, and the authors will be then available to answer your questions. As usual, any of your questions, for those of you following us from YouTube live stream or from Microsoft Teams, you have the chat box to write any of your questions that then the authors, if they are here online, will be responding. So welcome everybody. We have a range of papers from augmented reality applications to the use of ALOS, radar and Landsat for post-fire hazard mapping, to the assessment of Sentinel-5P for assessing groundwater quality, ground level air quality. And then our last paper is on geospatial analysis of impervious surfaces and what is their effect on surface temperature intensity. So you will see that it's quite a variety of papers and all related to disaster management and how technology and how these sensors or augmented reality could be applied. So welcome, and then let's start presentation. The lead author is Sebastian Meyer and is on outdoor augmented reality application for the digital map table. Thank you.
Hello, my name is Sebastian Meyer. I work for the Fraunhofer Institute of Optronics, System Technologies and Image Exploitation in Karlsruhe, Germany. The topic of my talk is outdoor AR application for the digital map table. Here's a short outline of the slides. First, I want to present the digital map table, its purpose and functions. After that, I have some slides about the basics of augmented reality, GPS, and some example applications that already combine those two technologies. Next, I will talk how we created the application and how markers can be placed in augmented reality and the resulting challenges. After that, I will present you our evaluation and results, followed by a conclusion. The digital map table is, other than the title may suggest, not only a table, but a whole software family. The abbreviation DIGLT is short for the German Digitaler Lagetisch. The digital map table is a software system for shared situation visualization and analysis. Any number of users can work independently of each other on the same situation using personal computers and tablets alongside shared digital tables, that's where the name came from, or large screens. The latest edition is DIGLT VR, a virtual environment where people at different locations can work together in a virtual environment. The underlying software is modular and can easily be custom tailored towards specific needs and extended depending on the requirements. Its uses range from educational use to mission preparation, mission execution, and review. A diverse range of data sources and geodata can be integrated to provide the right information for each use case. This provides the basis to correctly judge the situation and make the right decisions. To further support users on their mobile devices in the field, we wanted to show information not only on the map, but utilize augmented reality to overlay information directly in the view of the user. We all knew that the technology exists and how accurate it should be. We all use navigation systems in our cars, but how good it would work for our use case, we had to find out. First, some words about augmented reality, or short AR. AR is defined as the combination of the real world with the virtual world. The interaction has to be in real time and the environment has to be registered in 3D. On the lower right, you see how that works. Small reference points are detected and tracked in the camera video. This can also be a depth image, for example, in the later iPhones. An algorithm then tries to detect planes in the tracked points and tries to detect walls and floors. This works best if a lot of points are detected. The shown brick wall works perfect. A white shadowless office wall, not so much. These walls are placed in a coordinate system, and then you can render arbitrary objects in the scene like the little rocket on the table. Luckily for us, the algorithms are already implemented and work very well. There's ARKit from Apple for all Apple devices like iPhone and iPad, AR Core from Google for all Android devices, and even third-party implementations like Gi4DM. The next technology we use is the Global Navigation Satellite System, short GNSS. GNSS consists of the systems Navstar from the US, GLONASS, the Russian system, Galileo, the European system, and Baidu, the Chinese system. I don't know about other countries, but in Germany, no one uses the term GNSS. We all just say GPS. With all systems, there are over 100 satellites in orbit, and you need to receive signals from 4 to calculate the position on Earth. Based on the used frequency, we can expect the accuracy of about 3 meters under optimal conditions. There are several possible errors that can occur. There is the multipath error, where the signal bounces off of nearby surfaces, and the delay, where the signal travels through the ionosphere and the troposphere. These errors can be countered by different technologies. Dual frequency GNSS receivers can help to reduce the multipath error by using multiple frequencies at once. The changing ionospheric and tropospheric delay can be compensated by using external correction data. There is no native implementation on smartphones to use this correction data, but there is the Flamingo SDK, which provides such an API, but it's not yet released. There are many examples of apps that combine AR and GNSS. The most popular is probably Pokemon Go, you see on the left, where you can hunt virtual monsters in the real world. The apps in the middle and on the right are very similar applications. In the middle is AR GIS lens, and on the right is VGIS. They are used to overlay pipes and electrical wiring into the real world. Creating our own application was straightforward. The Gi4DM is already a very capable web application we wanted to utilize. We decided to use Unity on Android to write a simple application. The in-app web browser asset is used to display the web interface. It provides a JavaScript interface that allows us to transfer data between Unity and the web app. The GPS implementation of Unity was not precise enough, so we needed our own GPS plugin to get exact data. For the AR part, we use the AR plus GPS location asset, which is using Android's AR core. On the right, you see that the magnetic compass is used by AR plus GPS location plugin. This will be important later on. On the left, you see a screenshot of the map with a placed marker, and on the right, you see the AR view with the placed object. You see here a view from the top, where the rectangle represents the smartphone and the dotted lines are the possible field of view of the camera. To make it easy to place markers in AR, we implemented a simple interaction, where you tap on the smartphone, a ray is shot through the center, and where it hits the detected ground, a marker is placed. Now, if your GPS location is not very precise, the placed marker will have the same offset as a smartphone at the time the marker was created. This offset is along the north-south and east-west axis. And here we see the problem with the magnetic compass. The compass is required to orient the virtual coordinate system correctly. If the compass is off only by a few degrees, it will result in a large error. The compass is very sensitive and reacts to the magnetic field of internal components and the magnetic field of the Earth that depends on your location. That's why you need to calibrate the compass each time you are using it. Now to our evaluation. We wanted to find out how accurately and precisely a marker can be placed. We had 3 different locations. One was an open field with an official GPS location marker. The second was between buildings, also with an official marker on the ground. And the third was a crossroad in the woods with a self-defined position. We measured 3 distances from 2 directions and on 2 different days to have different weather conditions. As the GPS location gets better over time, we took measurements for 2 minutes. We used 2 different devices, a Samsung S10e and a Xiaomi Mi 8. The Xiaomi has a dual channel receiver. As references for the compass, we used the good old analog compass. As reference for the direction, the marker on the ground was used. On the upper right, you see our test setup. We needed to create our own holder from wood and rubber bands. The first metallic prototype interfered with the compass of both smartphones. The compass was calibrated before each measurement. We measured the distance between a marker placed on the coordinates and the reference point. To see how the compass influences the results, the exact direction from the analog compass was entered as correction value. The reference marker was created by directly standing above the real marker on the ground, creating the virtual marker and then moving back to the measurement position. The virtual marker stayed stable on that position. And here are the results. This was taken at the open field on site 1 from a distance of 10 meters. The figure shows the distribution of the measuring points around the reference, which is located in the origin. The green dots, which represent the deviation without the influence of the compass, show a relatively small drift of about half a meter along both axes. The distribution can be explained by the drift in positioning by the GNSS. For the black dots, which represent the uncorrected positions of the marker, we see a circular deviation. This compass can be explained by the compass, which makes the capsule rotate around the position of the smartphone. With the black dots, the drift by GNSS is much more difficult to detect, because they are additionally more scattered due to the jitter of the compass. This diagram shows the results at location 3 in the woods. You can see a drift of about 12 meters along the north-south axis and about 7 meters along the east-west axis. This strong drift could be explained by the multipath error, which is potentially amplified by the surrounding trees at the location. In this measurement, the green dots, which represent the deviation without the influence of the compass, are so closely grouped that they can hardly be identified as single measurements. The black points, which represent the deviation with the influence of the compass, are clearly divided into 3 groups, which represent the single measurements in the different distances. Due to higher angular error in these measurements, the circular path on which the black dots move can be seen very clearly. This behavior is due to jittering of the compass and the fact that the capsule is moved further with constant angular error but increasing distance. The deviation of GPS coordinates was in 82% of the measurements below the specified 3 meters. The Xiaomi has slightly better results as we expected with the dual channel GPS. The big problem was the integrated compass. While we have a mean deviation of 3.3 to 6 degrees, which is still not good, the standard deviation of about 45 degrees means that you cannot rely on the compass at all. I have to remind you that these values are all measured with an already calibrated compass. In conclusion, we can say that the GNSS position was inside expected parameters. The dual channel GPS had no usable effect in our tests for our application. The accuracy of the compass could not be measured on the smartphones directly and is the main problem that is even bigger for markers in the distance. We really did not expect this, and it makes markers in the distance very unreliable. Augmented reality with AR Core worked very well with some rare exceptions. To compensate the bad compass, we would like to implement a dynamic compass that is based on the GNSS position to determine the direction. This would require the user to move to get different GNSS locations. This concludes my presentation. Thank you for your attention. If you have any questions, feel free to write me an email. Thank you and goodbye.
Thank you very much, Sebastian, and welcome, Boris.
International Fund for Agriculture Development, while my co-author, Dr. Ling Chang, is from.
So yes. we would have now Boris as the person that will answer questions that the participants might have. Boris, I think there is one question here. If you could read it on the chat and answer that one.
Yeah, I can read it on the chat, but sorry, I can't answer that. As I already said, it was my colleague who have done this test with a student. I'm sorry for that. I will forward that to Sebastian and come back to you. Maybe you can post your email in the chat, or I don't know, was it available in the mailing list from this meeting?
Yes, electronic. All the authors have specified their email, so we will keep this one as one to be answered. I posted one, and I wonder whether you could tell us something about the compass and what would be right, and examples of right conditions and wrong on the worst environment that the paper mentions for this new device to be within the accuracy that was reported.
Yes, sorry, I don't get the question.
In the conclusions, it says that there is a displacement of 3 to 4 meters under the right conditions. So the question is, what would be examples of the right conditions? What kind of environment would that be? A town? Would be that on the open? And then what would be an example of the worst environment? I'm trying just to direct this question as to how this could work under different built-up environments, or whether it's out in the open would have a better performance.
Yeah, absolutely. So for the GNSS, the optimal environment would be yeah, would be on the open sea, on an elevated place. So everything which deflects or blocks the signals from the GNSS is not good. So the worst case would be on the streets in a village, in a city with huge houses. You have multipath signals. The GNSS, the receiver, should have to decide which is the right signal, which is the multipath signal. This is very difficult, and therefore within a city street with high houses around is the worst environment. So an optimal or good environment would also be an open field where we have good visual contact to the different GNSS systems, the satellites. This could also depend on time of day, because the GNSS satellites are not stationary, but they move over time, and you have a better and not so good time of the day where more or less satellites are visible. But nowadays, with now 4 GNSS systems from different countries, this problem with the satellite, it's not so huge as it was at the beginning of the GNSS system, where only the US NavStar system was available.
Okay, thank you. Is there any? I don't see, so I will keep asking. I had another question. Also in the conclusion of the paper, there is mentioned that your team would like to develop new methods to integrate the precision and stability of the integrated compass. Is there something that you could share with us in terms of your ideas as to what those new developments would be?
Yeah, so the first idea is not a new development. It is just an idea that we want to use in this web application, that you don't use the integrated compass, but you use your movement over the surface of the Earth to measure the direction of your movement. This is also used in every standard car navigation system, but there's the problem that you have to move to achieve a sense of direction. But then this is very accurate.
Okay, and Boris, my last question would be, because this session is about disaster management. So how would you see the development of your team that be of help in the event of a disaster, say hurricane or say an earthquake, where we need rapid mapping just to know positions, and how do you see this could help?
Yeah, so the digital light table itself, the situation table, we've already developed for several years for disaster managed situation awareness, where you can visualize different sources from any kind of type, video streams, satellite images, aerial photographs from, for example, tiny drones, and so on. The AR part especially is for the user in the field. For example, there was an earthquake, the roads are not drivable, usable anymore, that he gets navigation aid where to go. He gets an aid where maybe someone was detected in an aerial photo, that there could be persons he has to rescue, that he get a visual aid on his smartphone, or in the future on his head-mounted device with an AR display in front of him, that he get this information geolocated within his real-world view.
Perfect, excellent. I can't see any other question on the chat, and therefore I like to thank you and the lead authors of the papers for the video and for this interesting presentation. And I hope you can remain on in the rest of the session. And I would like now to invite to move to the next session, to the next paper of this session, which is on post-fire hazard detection using ALOS radar and Landsat optical imagery. Thank you.
Work with the International Fund for Agriculture Development, while my co-author Dr. Ling Chang is from the University of Twente and ITC in Netherlands. Our research paper entitled Post-Fire Hazard Detection using ALOS-2 radar and Landsat optical imagery. Our analysis will mainly focus on background, objective, methods, results, discussion, and conclusion. I'll go straight to the background. The effects of wildfire has attracted a lot of recognition both globally and locally, and this has been because of especially the increased fire in Australia over the years. And there has been a lot of studies that have been done in Australia focusing on the factors that are influencing the spread of wildfires and also how to mitigate the wildfires. However, few have gotten into the understanding of analysis in affecting how variation in geographical aspect of an area and the type of tree structure influence fire severity estimation. Our main objectives is to analyze the use of satellite data and comparison to the optical imagery in identification of both burnt and unburnt forest fires patches. Our specific objectives will only be three. One, to develop a forest fire burn severity map. This will explain the levels of fire that are existing. Number two, we'll explore the sensitivity of radar that mainly includes polarimetric decomposition and backscatter intensity in identification of both burnt and unburnt areas. And last but not least, we'll compare the degree of spectral contrast, both looking at spectral sensitivity and polarimetric sensitivity between both the burnt and the unburnt areas. Our methodology mainly had 4 steps. One was the pre-processing steps in both radar and optical. For radar, we looked at radiometric calibration, terrain, geocoding, and speckle filter. However, for optical data, we looked at radiometric correction and geometric correction. When we looked at the band sensitive spectral composite, that was the second one, it mainly focused on vegetation indices, that's the normalized band ratio indices. Then we looked at the support vector machine, that was the contextual classifier that was used, the machine learning algorithm that was used in our analysis. And second last, we looked at the training data process, and here we looked at the methods that we used to obtain both our training set and our validation set. And last but not least was to validate our training sets by using our accuracy assessment and validation data set. When you go to our methods that we used, first in terms of optical based spectral indices, we used the normalized band ratio indices, and here we mainly looked at this. We looked at pre-fire and post-fire images, and we subtracted the two. And how we also used the United States Geological Survey, that's the global index for the vegetation indices of normalized band ratio, and we calculated ours into 4 classes, mainly unburnt, low burnt, moderate burnt, and highly burnt. And later we went to reclassify them into only 2 classes. So for the unburnt class, it remained unburnt. However, for the low, moderate, and high classes, remained as burnt severe, high, like burnt patches. Secondly, in one of our methods, we use support vector machine. Why did we choose to use the support vector machine? This is because it enables us to find an optimal hyperplane that maximizes the margin between 2 defined classes. Looking at our 2 classes that were mainly burnt and unburnt classes, it was difficult, especially at the edges of the boundary of our polygons, to differentiate which pixels were burnt and unburnt. And so the support vector machine acted as our very best, and because it utilizes very few training samples. We also used, because it has 3 kernels, the radial, the polynomial, and the polynomial kernels, we did a random test of values, and also using the parameter C, and so which is the regularization parameter, and we are able to settle for the radial basis function, that's the RBF, as our main kernel in support vector machine. And then when you move to our next slide, that is our validation. Our sampling sets for training were obtained through visual interpretation of images, that is before and after the fire, and also the use of the polygon vector shapers provided by the Victoria database was also acting as our training samples. Then our training and testers were separated through random sampling procedure, whereby 2/3 of the total area were classified as training samples and a third were classified as test samples. Then when we go to describe our study area was a part of Victoria, Australia. We looked at a part that has the main reason was why we chose this particular area in Victoria, Australia was because of 4 main reasons. One is because it recently experienced a fire, that is a bushfire, and that had highly intense fire. Number 2 is because of presence of the images available for both radar and optical that were having the same timeline dates. Number 3 is because the area has over time experienced intense fire over time consistently, and that became a suitable study. And number 4, because of its varying geographical phenomena that will be suitable for study analysis. And then the images that we used, the images or the data sets that we used are defined in this slide data description, whereby our images for the pre-fire were collected both around October, around July, that is for pre-fire data set for both Landsat and ALOS, and then post-fire data set was that one for October. That was for both ALOS and Landsat images, and that was good. For Landsat, it has a resolution of 30 by 30, and for ALOS, it had a spatial resolution of 10 by 10. And then for our ALOS, it was collected in ascending order. And then when we go directly into comparing the pre and the post fire, that is go directly into our results. When you look just at the raw images of pre and post fire of ALOS, it's difficult to see physically the differences between both images. However, when you look at the images, in terms of their backscatter values, you'll realize that the images before the fire had a high backscatter value of 63.01, that's a volume scatter. However, after the fire, it had a value of 47.13. So there was a reduction in the scattering, and that could tell you increase that particular area had experienced fire, and there was elimination of leaves at that particular area. And then as you continue, we also did a comparison of raw images between before and after the fire of both Landsat 8, putting a band combination of RGB 752, and one could clearly see there was a difference, especially in that particular area of both before the fire and after the fire. When we go to comparison after we performed our normalized band ratio index, we found that our area had, when you compare the size and the extent of changes between the fire before and after the images, we compared and we saw that our area had four classified classes that were unburnt, low severity, moderate to high, and high severity. And so these classes were very key for us as they were able to form training samples between burnt and unburnt areas. The unburnt areas remained unburnt. However, for the other 4 classes, that's low, moderate to high, and high severity, were classified as burnt patches. Then when we go to classified, when we did classification or SVM classification of optical and radar satellite, one could clearly see there was a difference in between. If you look at the optical data, it could tell that most of the fires, most of the patches within our vector shape file were burnt. However, this is because of spectral classification, and thus it only takes the vegetation crown fill. However, when you look at SAR data, you could see there was a difference in between, and you could see there was a difference in between, as much of it was not really burnt, and that highly could tell this is because it utilizes the removal of crown leaves and branches, while for this one it just looks at vegetation fill, that's crown closure for the optical data. That's the difference. Another second difference that we also notified was that the areas that appeared as unburnt, lowly burnt in optical data were burnt in SAR data, and that was also another difference that we noticed. And this could also be because of the same effect that optical data utilizes crown closure, while radar data utilizes the removal of crown leaves and branches. Then when you go to the classification results, it was also key for us as it assured us that in both radar and optical, it utilizes the ability to classify both burnt and unburnt patches in forest fire mapping. As accuracy assessment, they showed high values were obtained both for burnt and unburnt, looking at both the producer accuracy and accuser accuracy of Landsat 8 and ALOS 2. The kappa coefficient for Landsat 8 was 0.8 and for ALOS was 0.89. So for ALOS was a bit higher compared to Landsat 8. And this was very accurate and key for us because it showed the ability for both images to classify burnt and unburnt. However, just a pardon that we could not be able to fully rely on this. This is because we noticed that areas that were classified as unburnt, areas that were classified as burnt in Landsat 8, when you look at the images, especially those areas that are outside the fire perimeter zone, some of them are buildings and they are classified as burnt. This is because of maybe the coloring of the rooftops. And so those are the things one should consider. And an alternative way we could advise is use of raw images or use of other types of field data to confirm your analysis. And then as we conclude, in our conclusion is that we successfully obtained good results for identification of burnt and unburnt scars using both satellite data and optical. The use of L-band, which is ALOS 2 in analysis of identification of burnt and unburnt, was clear and was wonderful. And also we looked at the sensitivity and we realized that when we used radar data, one of the things we cannot fully rely on our results is because some of the areas that were hilly in radar data, the backscatter intensity was difficult to identify because there were shadows appearing, and thus we could not fully rely whether they are burnt or unburnt. Another critical factor was when you look at the polygon around our burnt areas is that it was not really matching the fire perimeter zone, and that was because it was collected at the initial stages of the fire. But however, looking at our fire zones, it was based on post-fire analysis. So that's also another critical thing that one should look at. However, when you look at the critical factors, another thing that was quite critical in correcting was the local incidence angle and acquisition geometry, and that would also affect the type of backscatter intensity, especially when you're doing classification with radar data. However, looking at all of those factors and looking at the post-fire analysis, the timing of the data sets and digitization of the fire perimeter are very, very key in the study, and that's another thing that really should be looked into. However, in one of our conclusions, we looked at that another possible thing that we have looked at is that both radar and optical can be utilized in post-fire hazard detection. Last but not least, our next immediate steps would like to incorporate in our study is maybe merge both optical and SAR to improve our timeliness and accuracy of burnt areas. Also, because we use stage alpha decomposition in our classification, we'd like to test more composition like cloud and Portier decomposition theorem. Last but not least, we'd like to look at ways of improving correction of local incidence angle, especially using SNAP, and this will for ALOS 2, and this will greatly improve our analysis. Thank you. Your questions are welcomed.
Thank you very much, Stella and the team from the Netherlands for a very interesting presentation. Good morning, and thank you for joining us for the on-live questions. Are there any questions on the chat? I can't see any, so I'm going to start with questions myself, and thank you for choosing Australia as one of the study areas. Is very interesting. Stella, you mentioned the difference in spatial resolution from the Landsat and the ALOS data set. Did you do any kind of resampling to have both data sets at the same spatial resolution?
We only did resampling for Landsat 8, but we did not do it for ALOS 2. However, it is one of the things that when I said in one of our conclusions in combining of both Landsat and optical, or Landsat and Sentinel and ALOS 2, is we can consider resampling of both to be on the same spatial resolution if we are going to combine both. But it's one of the things that we would like to consider in our next juncture.
Okay, so in this case, you kept both data sets at their original resolution. And
exactly.
in the area you were showing in your results, the image of the results and the burnt and unburnt area. Are there any any of the results or the errors that were reported that you think are related to the topography of the area? Because you mentioned some spectral similarity with buildings, but looking into some of the images as well, I was wondering if there is some error there in terms of missing or overestimating burnt areas due to the topography of the area.
Yes, that's a good question. When we were dealing with our Sentinel with ALOS2, one of the biggest difficulty, because it was a hilly area, is because because of the local incidence effect that you are sometimes unable to correct for, it led to the difficulty sometimes in identifying areas that were either burnt or unburnt patches. And that was because most of the time, especially if the backscatter is very high or it's very far, you cannot be able to tell whether, because of the shadow effect, you cannot be able to tell whether that patch is burnt or unburnt. And that is why we were looking at ways to improve terrain correction, especially when using ALOS data.
I am Rodrigo Cedeño.
Okay, so this is something that you might try to run some additional experiments. So okay, and then I was wondering, you were showing us a different rank of severities in your output maps. What was the criteria that did you use to decide on those classes?
Oh, that's a good question. We use the United States Geological Survey sample. However, the reason why we only did that using optical data, and because we're obtaining our training sets based on the vegetation indices. We could not be able to put burnt severity levels when we were doing ALOS2, and this is because of maybe the intensity of the fire, and also because we cannot be able to classify the levels of the fire based on the length of the band. So that is the reason why we just settled for two classes that would be easier for us to map out, which is burnt and unburnt. And the presence of our vector shapefile that was provided by the Victoria dataset highly influenced the reason why we settled for two classes as compared to the 4 classes. And then last but not least, the reason why even after classifying them into 5 classes using Landsat 8, the reason why we decided to classify them as burnt and unburnt into 2 classes, we decided to classify everything that was unburnt to remain unburnt, but as long as it's low or moderate, we all classify them as unburnt. So it was basically just a decision that was made. There was no other major reason as to why we backed it up, why we could not classify lowly burnt into unburnt. But in case we're able to do maybe more analysis, as we can see now in our conclusion, we'd like to do burnt severity level also using ALOS data to understand the differences so that you can be able to classify both as burnt and unburnt, having both burnt severity levels in both Landsat 8 and ALOS. Yep.
Excellent, thank you. Well, I haven't seen any other questions in the chat, so these were the ones I had written down from my side. And if there are no more questions in the chat, I'd like to thank you and your co-author for a really interesting presentation, and I wish you good luck in the remaining of your research and more experiments in terms of the data fusion that you say, plus the other aspects of backscattering and fire severity that you are trying to map. Thank you very much, Stella, and have a good day.
Okay.
Well, given the time, we are almost 45 minutes within this session. So our third paper is on the assessment of Sentinel-5P, the performance for ground level air quality monitoring, preparatory experiments over the COVID-19 lockdown period. The authors are a team from the Politecnico di Milano in Italy. And if we are all ready, I would like that we begin running the video.
Good morning. I am Rodrigo Cedeño from Politecnico di Milano, Italy. I am very happy to be here with you in this Geographic Information for Disaster Management Conference. I will be presenting to you The assessment of Sentinel-5P performance for ground-level air quality monitoring preparatory experiments over COVID-19 lockdown period. Our motivations and objectives. Atmospheric pollution has been largely recognized by the scientific community as a primary threat to human health and ecosystems, and represents a pressing sustainability concern, directly connected to many Sustainable Development Goals from the United Nations. It has been proved that air quality deterioration has increased the number of deaths worldwide, even at low levels of exposure. Our motivation to develop this work are the current limitations for monitoring air pollution. This is traditionally performed utilizing fixed ground sensors networks, which represents the primary air quality data source to many national and local authorities. The use of permanent ground sensor networks allows for continuous measures, thus enabling computations of air quality indicators required by the current legislation. Nevertheless, the exclusive use of permanent ground sensors denotes several limitations. The main reason is that observations from fixed ground sensors limit the spatial granularity and coverage of the measurements. With this in mind, this work presents a preliminary investigation on the contribution of satellite estimates as an alternative or a complementary data source for local air quality monitoring. The case study selected for this work focuses on the correlation assessment between nitrogen dioxide satellite estimates from the Sentinel-5P and the authoritative ground measurements available for the Lombardy region. The Lombardy region is characterized by an unfavorable geographic context for air pollution and ranks among the most polluted areas in Europe. NO2 is one of the most diffused and monitored air pollutants, which is primarily released in the troposphere. Two analysis periods were selected for the correlation analysis, respectively the months January to May in the years 2019 and 2020. Further than computation of the correlation between satellite and ground observations, the selected periods allowed for parallel quantification of COVID-19 lockdown effects of NO2, which from March 9th to May 18th, 2020, caused a massive reduction of both industrial and transport activities in the Lombardy region. Ground air quality monitoring is performed in the Lombardy region by the Regional Environmental Protection Agency through its air quality sensors network. The network is composed of more than 100 fixed ground stations providing hourly ground level measures of pollutants concentrations, including NO2, PM10, PM2.5, O3, and sulfur dioxide. Data can be downloaded in CSV format using the Open Data Portal web interface, or in JSON format through a dedicated Open Application Programming interface. Satellite estimates of NO2 concentrations were retrieved from the European Space Agency Sentinel-5P multispectral mission and are freely distributed through its Data Access Hub. Products are provided with a spatial resolution of 5.5 kilometers along track and 3.5 kilometers across track, with a global daily coverage and in NetCDS format. The available products are NO2, O3, SO2, carbon monoxide, methane, and formaldehyde, together with aerosol and cloud indexes. The preprocessing operations produce two data frames containing geolocated time series of NO2 concentrations from ARPA Lombardia sensors and NO2 tropospheric columns product of Sentinel-5P. Daily averages were computed for the ARPA Lombardia sensors and compared between the two study periods to assess the COVID-19 lockdown effects on NO2 concentrations. ARPA Lombardia sensors have an hourly sensing time period, while the satellite passage happens each day between 10 a.m. and 1 p.m., according to the Sentinel-5P Sun synchronous orbit. An iterative procedure was implemented to average the hourly sensors observations over a time window and use this average for computing correlations with the satellite observations. Correlation analysis between ARPA and Sentinel-5P NO2 time series was calculated at each ARPA sensor location. The Pearson's correlation coefficient, ρP, was computed from the pairs-wide comparison of each sensor's time series and the corresponding satellite time series to measure the linear correlation, which may represent a relevant limitation in assessing the correlation between direct NO2 measures from ground sensors and satellite estimates derived from the spectral signature analysis of the atmospheric column. The Spearman correlation coefficient was calculated to measure the monotonic statistical dependence between ranks of two variables, thus allowing assessing correlations whether linear or not. Preliminary results show a reduction of about 17.5% through the comparison of daily average NO2 concentrations between COVID-19 lockdown period and the same period of the previous year. By considering only March, when most of the restricted lockdown measures were ongoing, the reduction was about 24.5%. The results are aligned to those of the previous studies carried out on the same topic for the Lombardy region. The sharp decrease of NO2 emissions reflects the massive reduction of industrial and transport activities imposed by the COVID-19 pandemic that affected the region. Results from the correlation analysis carried out by means of the ρP and ρS computations are reported in the table, as well as summary statistics of the two coefficients. Results pointed out a global, strong positive correlation between the NO2 ground measurements and the satellite estimates, with mean values near or larger than 0.75. Correlations are stronger on average for the 2020 study period than the 2019, but characterized by a higher standard deviation. Therefore, the results suggest better agreement of satellite estimates with ground-level NO2 measurements at a lower concentration level, or eventually at a lower emission level from the industry and transport sectors. Nevertheless, the computed standard deviations indicate a higher variability of the correlation coefficients among the different sensors in this anomalous emissions scenario. Now, we can observe that the Spearman's coefficient has a better performance than the Pearson coefficient. So this points out a slightly strong non-linear correlation rather than a linear correlation. Spatial patterns of correlation coefficients can be inferred from the figures shown in this slide. It can be noticed that the lowest correlations are mostly confined in the mountain areas and valleys, while the highest correlations are mostly found in the plain and metropolitan areas. These may be connected to one or a combination of different factors. First, the orography of the mountain areas and valleys might obstacle the satellite view on the lower atmospheric column by biasing the satellite estimates with respect to ground measures. Second, microclimatic conditions, background emissions, emission sources, and general landscape characteristics. Results indicate a reduction of about 17.5% for the daily average NO2 concentrations in the Lombardy region during the lockdown period with respect to the same period of the previous year. The analysis points out a strong positive correlation between ground sensors measurements and satellite estimates, with mean Pearson and Spearman correlation values near or larger than 0.75. Spearman values outperform on average Pearsons by suggesting nonlinear correlation being more effective than linear one for inferring NO2 ground concentrations using Sentinel-5P observations. This preliminary work focused on NO2, while it can be directly extended to other common air pollutants, such as O3 and SO2. The presented exploratory analysis is a propedeutic step for future work, which allows focus on the development of prediction models to empower the regional air quality monitoring with satellite observations assets. Thank you very much for your attention. If you have any questions, please contact us.
Good morning. Do we have Rodrigo or some of the authors of the paper online?
Hello.
Hello. Good morning, Jesus. Welcome to this online version of the conference, and thank you very much for your presentation. Very interesting and quite I think very promising results for those that are interested in the remote sensing of air quality. We have some questions. We have the chat open for questions, but since I see none so far, I will start with some questions that I wrote down while you were presenting. The first one is just my interest in how you did the correlation between the points of the on-ground stations and the pixel size of 3.5 by 5.5 kilometers. So would that be the case that if you have one station within that area, this is the point that you took to do to extract the measure and make the correlations, or did you create with all the ground stations an interpolation that then you did apply the correlation?
Correct. So first of all, I created a grid with a data processing using Python, and then I correlated the results of this grid with using nearest neighbors analysis to match the coordinates of the ground sensors with those of the grid data of the Sentinel-5P.
Okay, perfect. And have you tried to apply geostatistics to make the ground grid and to make perhaps another experiments on correlating if you do apply spatial statistics for deriving your surfaces and then relating that to the satellites?
Yeah, so we have been doing some tests to correlate the different regions and different areas of the regions to try to find different trends in the data and on the results, so that we can group this data and cluster them into better groups that can help us understand what is happening with the data.
And in terms of the ground stations, because this is a data collection that is daily, and you say that the satellite pass or the overpass is between 10 a.m. and 1 p.m. So how did you choose exactly what was this an average of the time of the satellite pass, or did you select just 1 hour specific to make the correlations?
No, actually, this is a very interesting question because, in fact, it is very important to be able to get the most out of our data. So what we did is we did an experiment for all the windows time spans that could be available during one day and calculate the correlation for all of the time windows of the different lengths during the day, and in this way we could select the mentioned time window. But in fact, we tested all the time windows available in a day to find which is the time that correlates best with our results.
Okay, perfect. Yeah, that's was very good way to test what would be providing the best results. Just wondering then if you could comment a bit more about this issue of the lower concentration. I mean the higher the standard deviations, and then the difference with different lower levels of concentrations did produce you better correlations. No, how was it? The fact that for some places you got better correlations but larger standard deviations. Is that something that now that you did that sub-regional analysis, you think that applies in the way you expose, or you think that is more of a question of the importance of the topography or some other atmospheric conditions rather than the concentration?
Well, certainly there are many factors that contribute to this difference in correlations, but we truly believe that it is correlated directly to the orography and the conditions of each of the regions. So we didn't have as good correlation on the mountain region as we had in the metropolitan areas. This may also be because we have a larger amount of sensors, but definitely the conditions and the orography is making a difference in our study, and we would like to deepen a little bit more into this analysis to understand better what is happening with all these differences in conditions to be able to understand better the problem.
Okay, and my last question, say that I'm interested in having some global or regional maps using this kind of data sets. Do you think that your approach is can be transferred and adapted to produce maps that cover larger regions?
Yes, in principle, we did it with the Lombardy region because we had data available from this region, and of course, we are from Politecnico di Milano, so we are working specifically in this area. But the idea is to expand it to other regions because ground sensors cannot be expanded as easily as we can do with satellite imagery. So for this reason, we really think that it can be expanded, and we did the correlation analysis to better back up our scientific approach to this solution.
And based on your experiment, do you think that you would be able in the future to give recommendations on minimum number of point locations that should be present in an area for these correlations to hold true? Is something that you could aim at?
I hope yes. Yes.
Okay. Perfect. I see no more questions in the chat, and we still have one paper to go. So I wish you good luck with the... Yes?
There is one question from Cici. She probably just
Cici,
came recently.
excuse me. Yes, Cici mentions... Okay. There is one question here that is a follow-up of my earlier questions about the correlation. And it's about how many ground stations did you have in the mountainous areas? You know, do
yes,
you remember?
we had about 6 ground stations in the mountain areas.
As compared to how many in the flat area in the city?
So in total, we were working between 80 and 85 ground stations. So it's a little bit less than 10% the total amount of ground stations in the mountains.
Perfect. Thank you. Is there any other question before I close this question and answer?
No, there is no other question. You can keep going. Thank you.
Perfect. Jesus, thank you very much, and thank you for joining us very early in the morning from Italy, and best luck with the rest of the research, and we hope to see it more of that very interesting application of Sentinel-5P. Thank you. Have a good day.
Thank you very much. You too. Thank you.
Well, then we move to the last paper of this session on managing disaster and change. And this time our lead authors are from Nigeria, from Ahmadu Bello University. The presentation is on geospatial analysis of impervious surfaces and their effect on land surface temperature intensity in Abuja, Nigeria. So with us then the lead author and the pre-recorded presentation. Thank you.
University, Zaria, Nigeria. Presenting a paper titled Geospatial Analysis of Impervious Surfaces and Their Effect on Land Surface Temperature in Abuja, Nigeria. With rapid urbanization, natural land surfaces originally covered by vegetation are being replaced by various impervious features. Land surface temperature is an important parameter which has been employed over the years in the assessment of the environment. Now, these urban impervious surfaces are a land cover type which have higher absorption of solar radiation, and they also have high thermal conductivity. Impervious surface release heat stored during the day and night, and so the impervious surface have a warming effect on the urban land surface temperature. Over the years, impervious surface area have found relevance as it is being used as a key environmental indicator. 3 major algorithms have been created and utilized to extract impervious surface area from remotely sensed imagery. These include spectral unmixing techniques, machine learning methods, and the spectral index methods with their subcategories as seen here. The normalized difference impervious surface index belongs to the category of spectral index. And the spectral index indices have been found to measure the biophysical properties of the Earth surface more accurately than the 2 other methods. Normalized difference impervious surface index was utilized in this study to estimate the impervious surface areas. The index can efficiently enhance and extract impervious surfaces from satellite imagery, and the real proportion of the impervious surface can be represented as well. The city of Abuja is currently experiencing rapid urbanization, and so there is a rise in anthropogenic activities such as construction of roads, pavements, and residential areas. All of these give rise to the formation of impervious surfaces. The impervious surface increases the urban mean surface temperature over time, and this concern is noticed in the formation of urban heat island facilitated by impervious surfaces. Analyzing the relationship between impervious surface and land surface temperature is very important in recognizing, controlling, and mitigating the environmental impacts of urban heat islands in planning and developing the city of Abuja. This study examines the impact of the spatial distributions of impervious surface on land surface temperature in the study area for a 14-year period from 2004 to 2018 using both graphical and quantitative approach. This is with a view to investigate the impact of impervious surface on the urban heat environment. The study area is the Federal Capital Territory of Nigeria. It's popularly known as Abuja City. It is located between this latitude and longitudes. It has an area of about 8,000 kilometers square, situated at 840 meters above mean sea level. As of 2020, it has a population of about 2.99 million, and the climate, it enjoys a tropical wet and dry climate with annual mean temperatures ranging between 25 degrees Celsius to 30 degrees Celsius, and with a mean annual rainfall of about 1,631 millimeters. Now we can see a map of the study area. Next slide. Now, the method of data acquisition. The data set used in this study basically were Landsat imagery, that's Landsat 7 and Landsat 8, and here we see the characteristics of this satellite images. They all have 30-meter resolution, and these are the dates of collection with 0% cloud. After data acquisition, geometric and radiometric correction were carried out, and the reason for carrying out this correction is to correct for sensor and platform-specific distortions due to variations in scene illumination and viewing geometry. Atmospheric condition and sensor noise and response are also corrected in geometric and radiometric correction. And then under the radiometric correction as well, there is conversion of email pictures to sensor reflectance. Scanline error correction was carried out for Landsat 7 imagery, and the image was finally subset to the administrative boundary of the study area. Next, the land surface temperature was retrieved using this formula, and after that, the top of atmosphere brightness temperature was also retrieved using the spectral radiance, which was created earlier on. After this creation, the normalized difference vegetation index was used to estimate the proportion of vegetation, and the surface emissivity, which were further used to calculate the land surface temperature using this formula. In this study, the threshold method was used to obtain that land surface emissivity. This formula was used to derive the NDVI used in this study. Two reasons why the NDVI was calculated was for understanding the city's vegetation pattern, and secondly is to extract the emissivity value. Then the impervious surface were extracted. The index-based technique was used in this study to map out the impervious surface of Abuja. A normalized difference impervious surface index was estimated to depict each epoch using this equation, and this index can isolate impervious surfaces from non-impervious surfaces, such as soil, water, and vegetation. Lastly, the statistical analysis was carried out using correlation and regression analysis, which were used to examine and analyze the impact of urban surface and impervious surface on urban surface temperature in Abuja City. This was achieved by examining its quantitative relationship with land surface temperature and vegetation represented by the vegetation index. The sample points selected were distributed across conspicuous impervious surface features such as built-up area, pavements, bare surfaces, vegetation, and water. These are the results of the study. This shows the spatial distribution of land surface temperature in Abuja City for the year 2004-2008. On next slide, we see the distribution for 2014 and 2018. And also, this figure shows the summary of the trend of land surface temperature between 2004 and 2018. And we can see a gradual increase in surface temperature, both the minimum, the maximum, and the mean temperature in Abuja City between 2004 and 2018. Results show a gradual increase in mean surface temperature by at least 2 degrees Celsius over the years within the study period, a total average increase of 6 degrees Celsius between 2004 and 2018. The highest temperatures were observed in regions experiencing rapid urbanization, mostly in the south of Abuja. Meanwhile, a large portion of Abuja City experiences maximum land surface temperature of over 14 degrees Celsius in the study period. The high temperatures are detected in large commercial and residential areas due to the influx of people and the possible air heating impacts of gases emitted from vehicles, building, cooling systems, and reflection absorbance of roofing sheets. This result shows the spatial pattern of the distribution of vegetation in the study area. The high NDVI values indicate abundance of vegetative cover as compared to areas with low NDVI values. Areas of high vegetation are mostly cultivated lands, grasslands, and other undeveloped natural surfaces, while areas with least vegetation are the built-up urban areas, the bare soil, the water, and the rocks as well. The next result is the spatial pattern of impervious surfaces in Abuja. This result shows the spatial pattern of impervious surface as distributed over Abuja, Nigeria. It incorporates urban surface such as rooftops, roads, parking lots, and natural impervious surface such as wetlands and water bodies. The maps for the impervious surfaces are shown in the next slide. These maps are the maps of the impervious surfaces was recorded in Abuja in 2004, 2008, 2014, and 2018. From the result, it was found that Abuja City indeed underwent widespread urbanization, which in turn led to the creation of impervious surfaces, such as rooftops, roads, parking lots, sidewalks, and driveways. The values of land surface temperature and impervious surface were extracted to 150 sample points, identical to all epochs in this study. These sample points were used for the regression and correlation analysis. You can see the result of this analysis in the next figure, which is figure 6. So this is a result of the correlation between land surface temperature and the impervious surface index. And this result shows a positive correlation between these two variables, which indicates or implies that as surface temperature increases, as the impervious surfaces increase around the study area, the land surface temperature increases as well in all the years under study. The results indicate a positive correlation between impervious surface and land surface temperature for each epoch, which correlation coefficient values are seen here for 2004, 2008, 2014, and 2018 respectively, all at 95% confidence interval. This demonstrates that the development of impervious surface contributes to temperature rise in Abuja City. Further suggests that the surface temperature rise is high in dense impervious surface areas, and it's faster there than in lowly dense impervious surface areas. The impact of impervious surface on land surface temperature in 2018 was more prominent in other preceding years under study. The next result is the relationship between land surface temperature and the normalized different vegetation index, that's the vegetation of the area. The relationship between land surface temperature and normalized vegetation index was analyzed to test the correlation between these variables to see the effect that the vegetation in the area has on land surface temperature. The results are presented in the next figure, which is figure 7. And this figure shows a negative correlation between land surface temperature and the NDVI for all the years under study. We can see the trend line slanting downwards, which shows a negative correlation, which implies that the land surface temperature increases as the amount of vegetation in the study area decreases. The results show that there exists a very strong negative correlation between land surface temperature and the normalized difference vegetation index in the study area. The year 2018 showed the strongest correlation with the coefficient of determination at of 0.738, which is quite strong, while the weakest correlation was found in 2008 between the two variables, with coefficient of determination of 0.6425. The results imply that the vegetation cover has an influence on the mean surface temperature obtainable at a particular location, and therefore, where vegetation exists, the temperature of the area is less compared to the built environment as affected by anthropogenic activities. Furthermore, from the results obtained, the negative correlation between land surface temperature and NDVI ascertain the cooling impacts of forest, woodland, parks, and other green city spaces. This study, in conclusion, this study gives great insight on the concept of impervious surface and its spatial pattern in Abuja City, Nigeria, over a period of 14 years. It reveals that surfaces such as roads, rooftops, pavements situated in urban areas are highly impervious, while surface covered with vegetation possesses low imperviousness. In this paper, the relationship between impervious surface distribution and mean surface temperature of Abuja City, Nigeria have been studied. The broad characteristics of impervious surface and their effects in enhancing high surface temperature have also been unveiled. The impervious surface as a variable show a significant bivariate relationship to land surface temperature in each period under study. Impervious surface proved to be a true indicator of variations in land surface temperature dynamics with a positive linear relationship with land surface temperature, whereas the land surface temperature and the NDVI had a negative linear relationship. It was observed that impervious surface contributes to the surface temperature rise in Abuja, and this can be attributed to anthropogenic activities arising from rapid urbanization, which consequently form impervious surfaces. The study recommends the widespread use of highly reflective or natural surfaces for rooftops, pavements, and roofs, and that afforestation should be encouraged to increase green areas. Thank you for listening.
Thank you very much to our colleagues of Nigeria for, again, a very interesting presentation on the use of Earth observation to derive variables that could be used for topics that are related to the well-being of people in cities, and in this particular case, the direct application on such things as urban heat islands. So, good morning, and thank you for joining live to the questions from the audience. I would like to invite anyone that is online to just put questions on the chat box, and while I wait for those, I will start with one of my own. I saw the correlations that you were showing between the normalized difference in impervious surface and the land surface temperature, and the lowest one was in 2008. There is only a correlation of 0.16. Is there any particular reason for that year? The other years where the correlation was quite strong, but what is the reason for that year being that low?
Well, one can't say exactly, but I think the atmospheric condition as at the time that satellite image was called correlation coefficient in that particular study was a bit low as compared to other years on the study.
So you think it's because of atmospheric corrections or atmospheric interference, or that correlation would have been low for that particular year?
Yeah, for that particular year, I think it's a big contributing factor based on the scene of the imagery that was collected.
Okay, so you did not correct for atmospheric effects?
Atmospheric effects were corrected quite all right in the radiometric corrections. It was done, but if you look at the spatial distribution of the land surface temperatures, a slight variation from what we have in the other years and in 2008, that particular year. So despite the fact that these corrections were carried out, we still found out that the correction was what it gave experimentally as we carried out I really had no control over that.
Okay. Then you when you mentioned the correlations, a total of 150 points were extracted to do the correlations. What kind of sampling did you apply to extract those points?
Well, it was a kind of stratified random sampling where known features were actually selected, known impervious surface features were selected to carry out this particular analysis.
Okay, and the same, because the same thing then was done with the NDVI. So you chose, when you say kind of stratified, you chose a mix of areas that were greener with mix of impervious and green areas, and then others that were almost 100% impervious. That's the kind of stratification you mean?
No. It was for that of NDVI. It was a random. It was a random sampling across the whole of the study area, not for specific impervious surfaces or for vegetative.
Okay, and when you were mentioning on the importance of the impervious surface, the materials of the impervious surface, do you think that this also might have affected the correlations that you got in with some points stronger than in others? Like for instance, is the materials of the roof a factor that you think is influencing the quality of the correlations?
Yes, that's I believe can be a contributing factor to the variation in this correlation. But at the same time, since the change over time in the study area is very obvious. So places that had some of these materials at a particular year, because of the changes and the development taking place in the study area, probably those materials were no longer available there. And so you find out a place that was very impervious initially, probably might have had less imperviousness. And so you see that is the changes that we're trying to look at over the years, how the imperviousness in the study area varies over time. So yes, that can be a contributing factor to the change in correlation.
And what is there any particular use that land use planners are making of these kind of products to decide location of more green areas to decrease the amount of heat islands in Abuja?
Yes, that's the reason why we are carrying out such studies to sensitize these planners on the use of remote sensing and GIS to advise the developmental that they make within the city of Abuja. So these are like pilot studies, and we're passing the information across to them on how to make good use of available resources in the city and to develop the city such that the comfort of the people or inhabitants of the city will be topmost or a priority to them. We are trying to pass this across to developers and planners in the city of Abuja.
Excellent. And my last question would be: do you plan to apply these same techniques to Sentinel or to other satellites, not Landsat only? Sentinel being also of having more thermal channels, having different spatial resolutions. Is there a plan to try this out with Sentinel? I'm not sure. Did my question?
Yes. Yes, I got the question. We are actually looking at to further this study to make use of other data sources and other methods, comparing the accuracy and to see which is more suitable for. So we're considering using other data sources such as Sentinel and to use other methods as seen in the introduction to look at of various surfaces on the urban temperature.
Excellent, thank you. Well, I see no further questions in the chat box. So with this, we are almost under the 1.5 hours time limit of this session, and therefore I like to thank you and your team for the time of preparing the video and for you to be present online this morning to answer questions for the virtual participants. So I thank you very much, and with your paper we are concluding this session. A brief recap for all the participants. We are very grateful for the time, for the effort to prepare very good videos. that have explained the basics behind all of these papers. The full papers are available in the ISPRS website. That is the hyperlink is in the conference website. And I think from my side, I like to wish you all a very good day, and thank you for making the time to be present, to listen to these interesting presentations, and a virtual applause for everybody, and thank you to the organizers. So thank you very much, and have a good day, everybody. Bye from Sydney.
It's hard having 4 kids, and our youngest is now special needs, so it's yeah, really challenging. So he's non-verbal autistic, and that's becoming more and more of a prominent issue for us. So yeah.
How old is he now, David?
He's turning 4, so he's very young. So we're doing all the early intervention now.
Okay. Oh, I wish you all the best. That's tough. Yeah.
Yeah, it's just the way things are. Like, you know, it is just tough. So yeah, it can be tough. So I guess Jack will let us know when we're good to go, everyone.
Yes, come on, Ori, come back.
So hello everyone who's on the call so far. My name's Dave Heslop, ICC. We're just waiting for our second panellist to come in, and we'll start shortly. Thanks.
I can hear some nice birds in the background. Wow. Hello.
He's just on his way back in, so start whenever you're ready. Thanks, everyone.
Excellent. Hello, Ori. Can I just confirm that you can hear me and we can hear you?
Yeah, can you hear me?
I can, indeed. Okay. So, hello, everybody. Welcome to our panel for this afternoon. We'll be focusing on COVID-19, which is a topic I'm sure is very interesting to everyone, and the role of GIS in managing what is, of course, a global public health emergency and frankly, a disaster. So before we start and before I introduce, I'd like to show my respects and acknowledge the Bedegal people, who are the traditional custodians of the land on which UNSW Kensington is, and of elders past and present on which this meeting takes place. I'd also, so as we move forward, I'd like to firstly introduce our panellists. We've got 2 experienced and very well-respected researchers in both GIS and epidemiology here with us today. My name is Associate Professor David Heslop. I work with one of our panellists at the School of Population Health at the university, and our 2 panellists have extensive experience both in COVID-19 but also in GIS mapping of infectious diseases, not only of COVID-19 but others. So firstly we have Professor Mary Louise McLaws from the School of Population Health. She's an epidemiologist with expertise in hospital infection and infectious disease control, and she's had many COVID-19 related activities this year, including as a member of the World Health Health Organisation Health Emergency Program Experts Advisory Panel for Infection Prevention and Control, Preparedness, Readiness and Response to COVID-19. And a member of the New South Wales Clinical Excellence Commission COVID Infection Prevention and Control Task Force. She's also the focal point for the WHO GOAN in the School of Population Health. We have had an extensive collaboration over the years. I can only speak highly. I could paraphrase her work, but it would take quite a long time to do so. And in the interest of time, I might leave it at that, Mary Louise. But you may know Mary Louise from the media. She's been quite prominent and influential in guiding both government but also public opinion and perception of what's been happening here in Australia and overseas, and it's been quite impactful. Our second panellist is Dr. Ori Gudis. I hope I've said that correctly. Excuse me, but his expertise is in GIS and health, particularly spatial analysis, decision support systems, and how to develop tools that actually are usable when it comes to infectious disease and GIS systems. So he has actually quite an extensive experience through a variety of research collaborations. My understanding is through the CRCs in spatial intelligence, all the way through to numerous grants throughout the years using various different approaches to GIS, both in terms of managing health data, but also more broadly. Please welcome Ori, and we'll get on with our panel. We've got a series of questions that we'll be touching on already, and we hope to open the floor to some questions from those of you attending today as well. But firstly, I'd like to open to both of our panellists some questions I think that have been important during COVID. So if, without further ado, to our panellists, how do you think GIS capability have assisted public health organisations like the WHO or the Department of Health in managing COVID-19 responses?
Thank you, David, and welcome viewers. And thank you for inviting me to speak on this. So first of all, I'd like to remind people that as an epidemiologist in outbreak management as well, we have learned from, of course, Snow, John Snow, and he uses spot maps. So some of these supposed GIS maps are actually spot maps because they don't really have any, they're not underpinned by very complex data that Ori will explain to you later on what a really good special analysis does of mapping of diseases. So let me just run through a couple of the maps. And I think regardless of whether they're underpinned by complex analysis, they are still really informative and they help the community understand where the risk of COVID is the spread, the prevalence. So it can be very good, and the death. But there are some better than others. So first of all, there's COVID Live. Now, they don't use maps, but they certainly have some very good breakdown of Australia for local government area, metropolitan, source, active case, death, recovery, hospitalisation, ICU, positive tests, that sort of thing. And they're all on tables, but not maps, and they're brilliant. But it's not the same. Then there's Johns Hopkins, which you've all seen. Now, I would call them really spot maps. And they give a great visualization, and they were probably one of the first to do this, and Ori would be able to correct me if they weren't. But they provide an idea looking at using the bubble, or as mappers would call this, a spatial location of magnitude of cumulative incidents, active cases, incident rate, case fatality, and testing. But it's shallow. It's every time you press a button, it will show you just that. There's no underpinning of importance of the disadvantage of CIFA, the socioeconomic disadvantage, income, age, there's nothing that helps to understand why some of these things have big blobs and some of them don't. And also, there's no idea of infection by 100,000 or a million population. And then you go to the worldometer, and it does. So it doesn't give it to you in the map or even in the spot map. But my goodness, they give you great graphs, and they do give it to you by things like per million tested, per million head of population. And it's very good for a quick overview. And you can go into those graphs, have a look at, for example, England, and find out what their level is today and what it was last week. Subtract the two, and you've got an enormous problem of, I think I did it, and it was about 69,000 cases. And they think that they're at a position to lift some of the restrictions. I think they're slightly disillusioned. You can find lots of things from those graphs, but it is not mapping. Then you've got the Commonwealth of Australia, and that provides you with tables but no maps, and it gives you some very accurate information on states, by state, by deaths, by hospital, by ICU, by tests and source, but no mapping. Then, because I'm leaving the best to last, then there's WHO, and they are spot mappers. They give you cases by bubble so that you can have a look at regional. So there are 6 regions. There's the Mediterranean, Eastern Mediterranean, the African, the Americas, the Southeast Asian, the Western Pacific, and the Americas. And it will give you the growth by day or by week. So it's very good. And then you can have a look at it as a global map, and you can see where some of the problems are, particularly the daily or the weekly ones. But again, it's not underpinned by anything that gives you an idea of disadvantage. Now, you may assume that the Africas are disadvantaged and that some of the Americas are disadvantaged, but it doesn't really give you a control for the disadvantage, say, in the UK or in Australia. So then I come to the best one, and that is University of Sydney. So congratulations, they do a great job, because not only do they do a bit like Johns Hopkins, but they provide a relative, an index of relative disadvantage, an index of relative advantage and disadvantage, education, economic resources, and CIFA. And the proportion of people over 60 with, and so that is a really nice map, and you get a really good idea about what the magnitude is according to these important variables that are highly predictive of COVID. So now I've given you my idea of what I think GIS or mapping is. I'll hand over to my colleague Ori, who as a mapper will follow up. Thanks, Ori.
All right, so hopefully you can hear me clearly, and thanks for the SSI and David to invite me today to speak. Just let me know that you can hear me clearly. And I just want to add and say, and probably reinforce some of the things that Professor Mary-Louise said, is I guess in any GIS course, the first map and the very well-known or the popular is really the presentation of Jon Snow. So in GIS and health, health was probably the first where, the Tobler law of geography was used. However, only in the last maybe 5 or 10 years, it became much more popular to the use in the public health context. Now, to take the things that Mary-Louise said and maybe make them a bit more specific, Mary-Louise is right by saying that, a lot of the analyses, a lot of the GIS application that we can see out there, maybe excluding University of Sydney dashboard, are very much in the descriptive level of analysis. And I think that is, in a way, a miss of opportunity. And I was just going to support what I'm saying now. So there's so much potential that to develop this further, and I will just give a few examples. So for instance, things like identifying community risk. And I think in this example, University of Sydney dashboard has done good example by cross-tabulating different layer and presenting the end user where is the risk versus the rate of COVID-19 incidents. If I go to other practical examples, I would say model the spread of disease, which I haven't seen this well developed in Australia. There are a couple of good examples in the United States. Another practical example will be analyze prediction of hospital capacity. A very well-known example for that will be the CAMS model, which was originally came in Penn State in Pennsylvania. So that's a model that was focusing about when hospital will reach their capacity and how we can then allocate or reallocate the force in hospitals against the number of people hospitalized. Some other example will be community contact tracing. And in that topic, a lot of apps were used. And I think maybe to some degree it was used quite successfully in places like in Southeast Asia, like Taiwan, maybe to some degree in South Korea, maybe to less degree in Australia. I guess location optimization is very, very important topic looking forward of where we are now, because we just heard a few days ago that the UK approved the the green light for the vaccine by Pfizer. And I guess it will be very important for distribution purpose to know where to put all these distribution centers, because the vaccine required cold, I think, minus 70 degrees to have appropriate storage. So location optimization is another topic which I would really want to see this going forward. I guess a couple of other things in my list will be mobility analysis. We all seen the reports coming out from Google and as well as from Apple, how much the mobility reduced during the lockdown. What does that mean for active travel, for instance? We all seen these pop-up lanes coming out in Sydney CBD, which is obviously a very welcome. To those of you who may have visited Centennial Park during the pandemic, during the lockdown, Centennial Park was closed to car. What does that mean for for us going forward post the pandemic? What will active travel will look like? I think it's really, really interesting question. And another tool in my list is really measure access to open space and parks. In that example, I would definitely go to Melbourne because Melbourne were in about 12 weeks lockdown, and essentially the people were restricted to go out only about 5K. There was very, very great work by Professor Elizabeth Kendall and others who actually measured whether there's an equity or non-equity in terms of access to parks. And this is really important because that can bring also other mental issues or any other stressors. The last item in my list is really measure and avoiding crowdness. And maybe just to support that, I've seen a couple of interesting and exciting startups in these new ecosystems of pandemic, where they were trying to predict how crowded a place will be, like a supermarket, how crowded it will be, and therefore support people. People can actually understand, is it actually worth it to go out now to the supermarket? Maybe I will wait until late at night. So all of this, I think, opportunities that GIS can really quite well support in terms of spatial analysis and also in terms of embed this within dashboard and cloud-based solutions. That's my 20 cents.
Thank you.
Can I add something? So one of your guests has sent a link to the Western Australian COVID dashboard, and I've just been looking through it, and it's really lovely. So it gives an idea of confirmed cases, the possible onset of illness, whether or not they have had close contacts, the spread, and even where there are clinics. So it is a very nice one. It's not underpinned by analysis of spread by a disadvantage or a CALD population to explain the spread, but it's a great visual presentation, and that's what the public really need, that great visualization.
Thank you, Mary Louise. So we've also had another question from our group, but we'll come back to that at the end, and I promise we'll have at least 5 minutes to answer the question. But for our panelists, and back to you, Mary Louise, acknowledging the benefits and all of the different things that can be done with GIS and that we've seen with COVID that have been helpful, as you've mentioned, that aggregation of data. What do you see as some of the pitfalls associated with GIS and infectious disease management? For example, information overload or being unable to develop an understanding or situational awareness easily.
Yes, thank you, David. I think that Ori nicely located this problem already by saying that we don't know if we're, somebody in, downtown Randwick at the university wanting to know if we want to go for a walk or go shopping, how crowded it is at the time, or what to expect. So these things could be more real time and also more helpful. Certainly they need to be not just on your computer, but app-wise for the average person who, and I've been pushing this from the beginning, but it must be too difficult to do, to have a look at AS1 or AS2 or even AS3 locators, so that when you step outside the university, you know what the endemicity is in your area. People are stopping wearing masks now. They're getting, quite happy about where Australia is in terms of risk, but not understanding that the risk just doesn't go away. It's just that sometimes we don't find cases. So I think the problem is it's not specific for the user. It's great for us, but often not for the user. But there's also a problem that Ori will pick up on, and that is the tension between privacy, and so how close you can get that granularity of data. And I'd love it as granular as possible, as so that we can actually identify much better location than just a local government area, because I think that would really bring home risk to the community. You don't want to tell them all the time that they're at risk. They get fatigued with bad news. But if they open up and they go, well, I might not be at risk, but it then says, but please wear your mask when you're going into a bus or something. The other thing is, of course, is accessibility of data. It is nigh impossible, unless you work for the Department of Health, to get the data that you need, to bring it together, to have a locator, age, all of those issues where you're going to be, where you think that you acquired this, so you can get an idea of all the causality. So accessibility, for some reason, is being kept away from the population. And I think that data should be as accessible as possible without breaching privacy, because the more that researchers, academics, mappers have, the better they can sell the story. Because when you can show a story, you can tell it really well. So, Ori, do you want to take up the issue of those and other points?
Yeah, no, thanks for that. And I think Mary Louise really framed it nicely, and she said, lack of, and I will just specify that. So first, I will start with lack of accessibility. If we talk about lack of accessibility, some really great examples for that would be maybe some of you have seen that recently the ABS, the Australian Bureau of Statistics, released really nice net stories, essentially platform that shows this media as well as just data that shows the risk versus rate for maybe elderly people, maybe TIFA indices, and so on and so forth. I thought it was actually a really nice initiative, but I also had some criticism about that. And the criticism was that it was a really great way to view the data. However, the data was not extractable. So that means they didn't use any open format such as WFS, WMS, or even open standard APIs, which is a very standard thing in any open source portals like Transport New South Wales, for instance, or even Orient. So that's for me a mix of opportunity. It's obviously great intention, but it's a mix of opportunity because what other developers, researchers, and academics could do with that is really would have taken us to the next step, if that makes sense. So that's in terms of accessibility. I guess in terms of granularity, and I think again, Mary-Louise say quite correctly, is really we need to maintain that very gentle balance between the wish to access to data which is as much as granular as possible versus obviously our legal liability to maintain privacy and confidentiality. So I guess it raised really a debate, which by the way started many years before this pandemic, where this line stands, or where this and I think we are still in that debate. I guess the pandemic helped in the sense that urban planners, health planners, decision makers need really good access to data. And if you're looking at what was available, you can see that mostly it was around either postcode or local government areas. If I'm giving the example of Victoria, for instance. However, SA2 level. Why SA2 level, you ask? The reason for that is that SA2 is one of the most richest ABS geographical units in terms of data aggregation, geographical aggregation, and that enables us better than comparison with other measures such as TIFA, such as other socioeconomical measures, which would have made a lot of sense, which would have had a lot of value. So that's my point in terms of granularity. Now, the third point which I want to add is really lack of unity. And Mary-Louise really gave that really great example of University of Sydney dashboards and John Hopkins. There's some others as well. And that's also the issue. So there's a lot of different initiatives, a lot of dashboards. I actually developed a few dashboards, which was in a way the equivalent of John Hopkins dashboard, which by the way started as a PhD project. So I haven't seen any attempt to develop a dashboard that will be both useful for decision makers within, let's say, New South Wales or other health agencies, and also an attempt to make this as transparent as possible for the public. And I guess this is something that we need to take from here forward. Think about how trustworthiness our maps, how authoritative they are, to what extent we provide the metadata and the information that support that. Who is actually behind these maps? Amy Griffin provided really nice article about trustworthiness of maps. So I think all of these are really important elements that will form the debate as we go beyond the pandemic and into the post-pandemic phase.
Thank you, Ori. And so that really leads really nicely into the question from Professor Zlatanova from the university, and it relates to the granularity of data and how potentially other questions can be answered. And she's asked, would it be useful to have a third dimension to what is often a two-dimensional representation of data? Is mapping in the vertical direction, especially in high-rise buildings, useful at that level of disaggregation? Yeah.
I think Ori will talk to this as well, but just from an epidemiologist perspective, in Hong Kong, they actually tell you where the outbreak is, which high-rise building, because all the buildings are high-rise, and whether the building is an aged care, long-term care facility. So you have an idea of exactly the place on the map where these places are. So they go directly into not just AS1, but the address, the location. That's how seriously they take it. So it is difficult. You couldn't do it in residential areas because we don't want people to feel shamed that they're infected. But we all know if they're infected or at a hotel quarantine because they're staying there. But there's this fine line. But certainly high-rise buildings have problems, and they have problems with airflow change. And it seems like often hospital engineers aren't getting on with the program and realizing that airflow change is incredibly important for reducing the spread of COVID indoors. So yeah, you could do that. I think though it would be, you couldn't be able to locate the infections, how many infections there were per high rise because of the anonymity, but we probably have to do it by, block, AS1. That's probably as far as we could go. Ori, what do you think for this particular health issue?
I think it's really great point, and the example from Hong Kong is awesome because what's really was unique in Hong Kong dashboard is that the data not only was provided on a more granular level, which was the building level, but also they used 3D. I don't know if it was Cesium or some other software to really present the data in a 3D, so people could kind of fly in, fly out into areas and see this as a web scene. Get a better perspective where are the clusters. But I have one point to add to that because I think it's a really great question. So about 3 years ago, I published a paper. I actually was trying to share my screen, but I can't. But I will share this paper later in the chat. So I developed a paper which was focused on injuries by heavy vehicle in Western Australia. And one of the maps that appeared on that paper later on was part of the Med Stories competition by Esri, was actually used 3D elements. There were essentially two layers. One layer was showing whether there was consistent hotspot or sporadic hotspot or new hotspots, and that was just a matter of different colors and symbology. However, there was another map which had 3D elements, and each bin. So imagine that there's a 3D bin, and all of this is extruded, and each of these bins, each of these boxes were representing different time, and the color, such as let's say gray or red, was representing whether it was statistically significant or non-statistically significant, and each of them was representing different time because it was aggregation of 10 years time. So definitely on that example, and I'm too sorry that I cannot share that map, which is appear on my other screen now, is really was very helpful to understand. Let's say there's a new hotspot or consistent hotspot, the difference is along the time dimension. So definitely I think 3D dimension and 3D symbology in map can definitely enhance our understanding.
Thank you, Ori. So we've got, we're coming to the close of our time, unfortunately, but we do have two further questions and probably a time enough to quickly address them. Firstly, Jack has asked, do you think it's feasible to release obscured space-time data and maintain de-identification, such as mobile phone location data and so on? And that map's just come up. That was being discussed also by Ori, just to say, but for those of you on the call. But firstly, Jack's question, so do you think that's possible to actually maintain de-identification, particularly with aggregate?
Hear you, Dimitri.
Okay, here I am, Dimitri Bulatov is my name. Can you hear me now?
Yeah, we can hear you. We can hear you. Actually, we didn't stop.
Okay.
Can go.
Yeah. So our first talk in the session 10 will be given by Pietro Boccardo, and the title of the paper is Aerial LiDAR Technology in Support to Avalanches Prevention and Risk Mitigation and Operative Application at Colle della Maddalena in Italy. So please.
Good afternoon, my name is Vanina Fissore. I'm a researcher at Ithaca, a center of applied research devoted to support humanitarian activities in response to natural disasters by means of remote sensing techniques. Ithaca is based in Italy. The work I'm going to present today regards the possible improvements offered by aerial LiDAR technology in the knowledge of avalanche phenomena. This lens can in fact provide high-resolution information about topography, which is one of the main factors influencing avalanche formation and behavior through the identification and characterization of more impervious zones. So in this context, the present work describes an operative application of the use of a high point density aerial LiDAR data in support to avalanche events prevention and risk mitigation. The study area is located at the Italian-French state border along an important cross-border communication route. The name of the locality is Colle della Maddalena, nearby the village of Argentera. As you can see from the pictures, the area has a very complex geomorphology with very high slope values. Due to the extreme environmental conditions, no tree vegetation cover is present for majority of the area. Here in the winter season and during heavy snowfalls, a big part of the road is involved in intense avalanche events that negatively impact on local and border traffic. At present, in order to maintain the safety conditions of the road, regular closure periods occur quite often and can be very long, with consequent negative effects on socio-economic activities. So for this reason, regional administration decided to adopt a control activity on priority areas together with artificial detachment methods. The artificial detachment of the snowpack at a certain time will in fact reduce the road closing time span and of course minimize the risk related to people and road safety. For this reason, regional administrations have activated the Avalanche Artificial Detachment Intervention Plan in order to prevent and manage the avalanche risk in the study area. The plan provides a detailed description of the area with specific focus on avalanche sites, identifying 14 of these last as actually affecting the cross-border route annually. Moreover, the plan describes artificial detachment systems to be used and the methodology followed during artificial snowpack detachment. Specifically, detachment procedures within identified avalanche sites will be activated at a certain threshold of snowpack depth, corresponding to 30 centimeters. This will guarantee to generate smaller and controlled snow mass movements and consequently to avoid the formation of excessive snow thickness from which greater avalanche could generate. The threshold will be observed directly from the road by remote observation on ad hoc snow pulse markers positioned within the highest parts of the detachment areas of avalanche sites. When this threshold is observed, then detachment procedures are activated with simultaneous closure of the road, so as to avoid the danger and risk of larger proportions avalanche formation. With these premises, main aim of the present work was first to provide a high-quality geomorphological characterization of the area necessary for involved authorities to activate the artificial detachment intervention plan, and second, to investigate capabilities and limits of the LiDAR technology in the identification of avalanche sites, only relying on geomorphological information directly derived by LiDAR data processing. Performed analysis regarded first a series of basic cartographic data contained within the intervention plan. Specifically, a geodatabase containing feature classes was adopted. Contained information are relative to general information about the area, such as road network, administrative limits, land cover and hydrology, and to more specific information regarding avalanche sites, such as snowpack detachment areas positions, avalanche extension identified by different methods, snowfall positions, artificial detachment systems positions, etc. So all these data were used as reference data managed in a GIS environment and used to validate the other data derived from LiDAR data processing. As regard to LiDAR data acquisition, the aerial LiDAR mission was carried out on the 6th of October 2019, before the beginning of the winter season and before any snowfall event. Raw LiDAR point cloud was pre-processed using Terrascan application. For point cloud classification and filtration, due to the morphological and vegetation characterization of the slope, a geometrical LiDAR classification was preferred instead of a full waveform data processing. The slope, in fact, mainly presents exposed rocks with no vegetation, with a small isolated spot of bushes and some conifer trees. For this reason, the 80% of the dataset taken can be considered as ground point cloud with small areas that needs more classification algorithms. Digital terrain models and digital surface model with 0.5 meters pixel size were then obtained. Figures shows the part of the slope presenting tree cover vegetation so as to appreciate the difference between the two data. In order to better characterize the area from a geomorphological point of view, some terrain analyses were performed with sagages. The obtained DTM was used to compute slope, aspect, wind exposure, and convexity, and then some descriptive statistics computed for the avalanche detachment areas contained within available reference data. As you can see, all detachment areas are within the range of 30 and 14 degrees of slope and mainly southwest oriented. As regard to the convexity analysis, values above zero normally describes convex profiles, while values below zero concave profiles. Reported statistics shows that majority of detachment areas have positive values, thus convex profiles. Obtained wind exposition index values show that all detachment areas present positive values above 1, so are exposed to wind, whereas no accumulation due to wind action is in fact more likely. Moreover, a flow accumulation analysis was computed for the area to identify the watershed's position in order to show if, with the only use of LiDAR-derived data, identification of position of already known avalanche sites was achievable. So, surface depressions within the input DTM were first identified and then filled for the whole area by using the FillSync module. Subsequently, the accumulated flow was obtained by using the flow accumulation module. Validation of obtained results was then performed through comparison by overlapping with available reference cartographic data. Results show that the areas crossed by avalanche events were well identified. Consequently, the channel network generation of the study area was possible, as demonstrated by evaluation of reference cartographic data, as you can see in the map on the right. The analysis identified all the areas crossed by avalanche events reported in the intervention plan, providing information about the position of the avalanche sites. Instead, no information was achievable about the extension of the potential sliding area, since this last also depends on snow parameters such as snow depth, snowpack structure, and other. Finally, in order to understand if LiDAR-derived data by themselves were sufficient to identify potential avalanche detachment areas only relying on geomorphological parameters, a graphical grid covering the whole study area was generated. Statistics about mean values of slope, aspect, convexity, and wind exposure were then computed within the graphical cells with the aim of identifying potential detachment areas. Results, as displayed in the map, shows that almost all detachment areas of the reference data were identified, but also that a great overestimation of this last is present. Again, metric parameters about snowpack structure results to be necessary. As requested by regional authorities involved in the avalanche control activities, the high-resolution three-dimensional terrain model of the study area was also obtained by using Global Mapper software. Main conclusion of the work can be that the processing of LiDAR data permitted to obtain high-resolution derived data. In particular, high-resolution terrain models were generated and geomorphological characterization of the area was obtained. High-resolution three-dimensional digital terrain models were also obtained. Then a second kind of analysis was performed to understand capabilities and limits of the LiDAR technology in the identification of the potential avalanche detachment areas, only relying on geomorphological information directly derived by LiDAR data processing. Obtained results showed that position of the avalanche sites were correctly identified, while no information could be obtained about the extension of the sliding areas, since this last also depends on snow parameters. The same can be said for detachment areas identification, not possible only considering geomorphological parameters. Potentialities of the adopted approach could be identified in the following. A further area LiDAR acquisition during the winter season and with the snow presence on the ground would allow to know snowpack elevation value, and the knowledge of such value would permit consequently to derive snow depth information at detachment areas and then better identify, together with already computed geomorphological parameters, potential detachment areas. Then area LiDAR acquisitions done before and after an avalanche event would permit to apply a change detection analysis, allowing the measurement of the extension of detachment and sliding areas. Thank you for your attention.
You're on mute, Dimitri.
Thank you very much. So we are done with the first presentation. Unfortunately, the authors are not there. And this is why we directly step into the second one, which is done by the, I believe, Thomas Fernandez on analysis of the evaluation of gully erosions in olive groves using photogrammetry techniques, relationships with rainfall regime.
Erosion in olive groves using photogrammetry techniques, relationships with rainfall regime. In representation of a research team of the University of Jaén from several departments. This is a structure of the work starting from the introduction. Soil erosion is a global phenomenon of environmental degradation, and within it, gully erosion represents 50 to 90% of total erosion at basin scales. Geomatic techniques allow the precise characterization of this phenomenon by means of several techniques such as total station, GNSS, and especially massive point cloud procedures, LiDAR techniques, but mainly by means of image-based approaches using photogrammetric or computer vision techniques. Then images and ortho images allow surface characterization and, on the other side, generation of digital elevation model for estimation of galley depths and volumes. Moreover, multitemporal analyses are addressed with calculation of digital elevation models of differences. In this paper, we have developed a methodology for quantification of galley erosion based on photogrammetry, aerial and UIS, and LiDAR techniques. The study area of 1.8 hectares is composed mainly by Triassic rutites and sandstones. It is an active galley stretch with intense erosion processes, sometimes affecting two rural roads and paths. Regarding the materials, a set of 8 historical aerial flights from 1980 to 2016 applied from different cartographic agencies were used with resolution between 0.27 and 0.45 meters. We downloaded the images from the photo libraries of National Geographic Institute of Spain and Statistical and Cartographic Institute of Andalusia. Besides, LiDAR data correspond to the first national LiDAR coverage, which has captured in 2014 in the Andalusia region with a resolution of 1.5 square meter. They can be accessed via the download service of Geographical Institute. Meanwhile, a DGA Phantom 4 with a RTK module integrated of centimeter accuracy and a camera of 20 megapixels is used. Other GNSS equipment have been employed for ground control and checkpoints. Then the methodology starts with the data capture. The data capture was made by means of 2 UAS flights of very high resolution with a ground sample distance of 2-3 centimeters. For the first flight on April 2019, a set of 30 ground control points and checkpoints were measured by means of differential GNSS. This has the properties of flights. The other flight was made on February 2020. Once the data have been acquired and/or captured, the second step is the processing. First, the LiDAR point cloud was obtained by merging the corresponding tiles. Its quality is controlled by means of a set of 21 checkpoints extracted in constructions and building roof corners. They are measured in the field with differential GNSS. The mean vertical error was of 0.24 meters, being the standard deviation, and root mean squares of about 0.45 meters. The historical flights are oriented using a point dataset extracted from LiDAR data as second-order GCPs. Then propagated errors in checkpoints range from 0.50 to 0.95 for the vertical component. UAS flights are aligned with structure from motion, multi-view steady techniques. The first flight, taken as reference, was oriented with GCPs measured in the field with differential GNSS. Additionally, second-order GCPs are used for the orientation of the other flight. The orientation produce root mean square errors at checkpoints that do not exceed of 5 centimeters in the vertical component. Next, the generation of digital surface models and orthophotographs are addressed. DCMs are generated with a resolution of 2.50 meters for the historical flights using dense matching techniques. DCM's uncertainties were assumed as the vertical errors computed at checkpoints. The orthophotographs were exported with a resolution of 0.50 meters. From the UAS images, DCMs are generated with a resolution and uncertainty of 10 centimeters. Both images are generated with a resolution and an uncertainty of 5 centimeters. Both products are resamplings to the same resolution as the historical products. The calculation of differential models from DCMs allows the detection of areas that undergo vertical displacements, and this may be negative or positive, corresponding to mass depletion or deposition, respectively. The vertical uncertainties of the differential models are estimated in around 1 meter. From these differential models, we delimited manually the Galley area in the GIS. Then the depletion and deposition areas could be calculated as the average values of height differences. Finally, the depletion, deposition, and balance volumes could be estimated that were transformed to mass rates by surface and time. Climatic data were obtained from the databases of the European for medium-range weather forecasts and processing to obtain a grid with a resolution of 1 kilometer from 1970. From daily precipitation data, several statistics have been calculated for rainfalls of 1 day, 7 days, 1 month, and 3 months. The results regarding areas, most periods, and the total periods presented a predominance of erosion over deposition, but the uncertainty area was very high. Uncertainty was lower in the more active periods, 2009, 2011, and 2011-2013, where the depletion processes predominate clearly over deposition. In the first 3 periods, there are few differences. A little bit in the period 1996-2001. In the next periods, the differences are remarkable in the periods 2009-2011 and also in 2011-2013. And finally, in the last 3 periods, few differences are observed again. Thus, the height differences calculated from DCMs of differences show advance rates for the whole period around 4 cm year. Most balance rates show negative values or near zero, so the erosion predominates, and the balancing rates showed absolute values below 5 centimeters years, except the more active periods when the rates reach 30 to 40 centimeters year. Regarding the volumes, these were greater for the depletion than for the deposition in most cases. The balance was near 30,000 cubic meters was the volumes, and the mass rate was of around 45 tons by hectare year, but the balance rates reached values higher than 300 tons by hectare years in the more active periods. Finally, regarding the rainfalls, it is observed that the mean annual rainfall was 470 millimeters, and ranging from 200 and 900 millimeters. A slight increase, 10% of rainfalls, was observed from the first 5-year periods to the last ones. The maximum values in daily rainfalls showed an increase near 30% in the last 5 years periods. This value is lower, 10% for 7 days, 1 and 3 months rainfalls. Besides, for periods of 5 years, the number of days in which a rainfall amount has been exceeded was higher in the last 5-year periods than in the first ones, both for 1 day, 7 days, and 1 and 3 months. And for the period considered in the erosion analysis, the periods with maximum number of days with a high amount of daily rainfalls were 1996, 2001, 2009, 2011 and 2011-2013. For 7 days, 1 month and 3 months, the rainy days were maximum, especially in 2009-2011. Observing the erosion rates, the Galley Stretch present an intense activity, especially of depression processes respect to the deposition ones. Some periods presented significantly higher values with average incision of 30-50 centimeters years, and the balance mass rates higher than 300 tons hectare by hectare and year. The depletion processes that until 2011 were concentrated in the Galley Center incision mechanisms from 2011 displaced toward its lateral walls, exertion mechanisms. And regarding the relationships with rainfalls, the higher activity in the more active periods seems to be related to the increase of rainfall in these periods, in which several days had rainfalls higher than 30 millimeters. There were also events of weekly rainfalls higher than 100 millimeters, monthly higher than 200 millimeters, and 3 months higher than 400 millimeters. Nevertheless, it is difficult to conclude about the influence of climate change on the erosional activity with the clear evidence of change in the rainfall regime. A certain increase of the precipitation is observed, especially the one-day rainfall, but it is necessary to have longer datasets and more points of analysis. The existence of wet periods with low erosional activity, 96 2001, led to consider the influence of other factors such as the construction of rural paths and roads and the changes in land use and practices. The conclusions: we have developed an approach to study the erosion processes using aerial and UVIS photogrammetry techniques combined with LiDAR data. The average depletion was of 1.60 meters incision and the waste volume of 30,000 cubic meters, which led to rates of 4 centimeters years and 45 tons by hectare and year, reaching values of 1 order of magnitude higher in the more active periods. These rates are related to rainfalls, being the periods with a more intense erosion processes, those in which the precipitations are higher. Rainfall regime has increased in the last 3 years, but it is necessary more data and analysis to conclude about the influence of climate change in erosion processes. And so, the future works will be led to improve the accuracy of photogrammetric LiDAR techniques and their automation to be applied to larger stations. Then, more advanced techniques of climatic data analysis will be used.
So over to you, Dimitri.
Dimitri, you are on mute.
You are on mute, Dimitri, sorry.
Thank you very much for your presentation. The author is here, right?
Yes, he is.
I have one question from the scientific. Yes? Not. Can you hear me now?
Yes, yes, we can hear you.
Yes?
Yes, yes, we can hear you. We can see you and we can hear you.
Good. So I have a question from the scientific point of view. What was the most challenging part of your work presented in this talk.
Thomas, can you hear us? I see him online, but does not seem to react. Just a second while I'm trying to see, because he's here but doesn't seem to hear us. At least we are not hearing him.
But the question was heard by you, right?
Yes, we hear you and we saw you. So yeah, the problem is right now with Thomas. He doesn't seem to be reacting. Let me see again. He's going to. There are also a few questions. Can't hear me. Okay, yes, we cannot hear you, Thomas. So he just wrote on the chat. If you can, Thomas, if you can, I see you are on hold. So probably if you can just resume the call and join the meeting again.
Mm-hmm.
Because you're
the best.
Yes, there you go. We are hearing you. Welcome back, Thomas. Yes, we can hear you. So sorry, Dimitri, if you don't mind, if you can just repeat the question for Thomas. Not sure if he heard it.
I would like to repeat the question. From the scientific point of view, what was the most challenging part of your work in this presentation?
Yes, the most important part. Can you hear? Yes?
Yeah. Yes.
Yes, the most important part of my research, our research, is obviously the photogrammetric methodology to study erosion. This study is part of a larger study in which we have studying not only this gully, but but also other gullies in a larger extension of the province of Jaén. That it's very affected by erosion processes who are affecting to olive growth. It's a very big problem in the province of Jaén. What is the most the main producer of olive oil in the world, and it's a very big problem for the agriculture, for the farmers, and all the people. And in this moment, I am studying the influence of climate process. It's in the starting of this study, and also other factors such as the construction of infrastructures, roads, rural paths, and also the change in the land use and practices, because the olive growth is increasing in the last years, and the practices to work with the land is different regarding the previous years. Yeah.
And from the scientific point of view, what was, how can I say, because you described the application, and I agree with you. And so from the science part, what was the most challenging part, maybe, which would you say, next time I will do it in a different way, I have to figure out how to do it better. So what was the scientifically most challenging module of your work in this context?
The scientific or technical?
Scientifical.
Scientifical from the climate change point of view, for the land studies? I don't know.
Well,
our intention is to have a methodology, overall methodology to study the territory in the province of Jaén. But in this moment, the study is in its beginning, starting.
Okay. And what was the accuracy, or what was the resolution that you are aiming at? That was a question from the audience.
The accuracy or the resolution?
The accuracy and the resolution that you are aiming at to present your results.
In this moment, as I was working with historical flights, the resolution and the resolution is about 2.5 meters, and the vertical accuracy is about 1 meter. This is all I can do with historical flights, but obviously with the UAS flights, the resolution and the accuracy improves dramatically under about centimeters accuracy and resolution.
Fine. Okay, and are there some other questions to be asked? It seems not to be the case. Okay, then we go to the next presentation, which goes about integration of GIS and advanced remote sensing techniques for landslide hazard assessment, a case study of Northwest Syria. And the presentation will be given by Mohammad Hamad. Please.
Hello, everyone. It is an honor to present in this conference my presentation about integration of GIS and advanced remote sensing techniques for landslide hazard assessment, a case study of Northwest Syria. First of all, landslide susceptibility and hazard maps are important for disaster management planning. Landslide hazard mapping has been developed, providing remarkable results through the integration of remote sensing and GIS. Sometimes the terms susceptibility and hazard are erroneously used as synonyms. Therefore, some so-called hazard maps are actually just susceptibility maps, as they don't consider the temporal and intensity dimensions along with the spatial aspects. Time series interferometric techniques such as PCI can provide precise information about instability of areas suffering from landslides and deformations. Due to unforeseen landslides following heavy rainfalls, the road networks in the study area are susceptible annually to damage that threatens the lives and properties of the people living there. So the aim of this research is to use the integration of the PCI technique and GIS to obtain the landslide intensity map during a precipitation season, and also to use this intensity map with the landslide susceptibility map created from the artificial neural networks analysis to obtain the landslide hazard map as a final result. The study area extends over an area of 269 square kilometers in northwest Syria, next to the Turkish border. The highest elevation is 1,130 meters in the mountain in the north, and the daily rainfall in December and January sometimes exceeds 50 millimeters, making these heavy rains a major trigger for landslides in this area. From geological aspect, the study area is characterized by spread of ophiolite complex deposits, in addition to different Mesozoic and Cenozoic sedimentary rocks. Geotechnical reports indicate that the ribbon radulari deposits combined with pilolavas were the main lithology at most sites where landslides occurred. The data used in this research, first the CASAP topographic map from 1980s was used to represent the topographic characteristics similarly to that which were before the occurrence of all landslides participating in this study, same as the land cover and NDVI maps, which were created based on multispectral data of Landsat 5 from 1984. Since lithology is constant during the study period, Sentinel-2 data from 2017 was used for the principal component analysis and P and band ratios techniques to prepare the lithology map with the help of the geological map that was also used for preparing the fault map. Additionally, 14 Sentinel-1 images from 16 October 2018 to 21 March 2019 were used for the PCI technique. The methodology used, first of all, the pixel size for all prepared causative factors and landslide inventory maps was set to 12.5 meters, same as the recommended grid resolution of the DEM extracted from the topographic map. While precipitation was excluded in the statistical analysis of susceptibility because it is likely consistent within the relatively small study area. For the statistical analysis, multi-layer perception neural network using a back propagation algorithm was applied to the training dataset. And the structure of 9 input layers, 5 hidden layers, and 2 output layers was selected for the neural network training phase, with setting up a random subdivision of the input landslides and non-landslide training dataset into 70% for training, 15% for validation, and 15% for testing. And the resulting susceptibility map was validated using area under the curve analysis. This flowcharts shows the preparing process of SAR data of the 14 images of Sentinel-1 in SNAP to get the 2 products in order to be exported to STAMP for using it in the PCI technique to obtain the main velocity data. The methodology for landslide hazard assessment depends on the interpolating of the mean velocity data to be used together with the susceptibility map in a landslide hazard matrix in ArcGIS to obtain the landslide hazard map. The training and testing sets of landslides and non-landslides on a hillshade map in this figure, we can see the landslide dataset and the inventory map and the non-landslide dataset. Since there was no landslide inventory map for the study area before, an inventory map for all these landslides that occurred in the study area between 1984 and 2018 was prepared for the first time, based on all available geotechnical reports and all other available information. The landslide inventory map, as we can see here, contained 57 polygons representing all landslides, and the 57 polygons were randomly divided into two sets. 40 landslide polygons were used as training set for statistical analysis, and 17 landslide polygons were used as a testing set for validate the resulting susceptibility map. And the same procedure was done for the non-landslide dataset, which was prepared with the same size of the landslide dataset. As we can see, the causative factor maps were created in ArcGIS with the same spatial extent, coordinate system, and pixel size. Consequently, all 9 causative factors contained were prepared, contained all the landslides in the area were prepared. As we can see, the 9 causative factors maps is the slope, the aspect, the terrain curvature, and the distance from the stream network, and also the land cover, the NDVI, the lithology, and the distance from the faults, and also the distance from roads. As a result of using the artificial neural networks analysis, landslide susceptibility map was created. A validation process of the landslide susceptibility map was carried out using the area under the curve analysis based on just the testing sets of landslide, which was not included in the analysis. Depending on the cumulative percentage of landslide pixels in the 100 susceptibility classes created, the area under curve value was 90.228%. In course of the PCI technique, after preparing all the data in Snap software, all RAP phases contain was exported to stamps. We can noted from this RAP phases that it contain patterns of narrow frings, narrow inside frings, which indicates the presence of remarkable ground surface deformation at this location. As these frings represent half the wavelengths of Sentinel 1, so it's represent 2.77 centimeter of displacement in the line of sight direction. After exporting the data from Snap to stamps and completing all the steps in MATLAB under Linux, a multi-point data sets of 23,500 persistent scatterers were generated, as we can see here, and the main velocity ranged from -47 to 101 millimeter millimeter, which confirms the presence of ground surface deformation or landslides in the study area during the study period. As we can see, the positive values indicate movement toward the satellite, while negative values indicate movement away from the satellite. The interpolated mean values, the interpolated mean velocity map show in this figure. We ranked both positive and negative values to as 3 zones: low and moderate and high, and in order to get the intensity map of the ground surface deformation during the study period. And as a result of using this intensity map and the susceptibility map from artificial neural networks in the landslide hazard matrix, we have got the landslide hazard map during the study period, which indicate the high zones, as you can see here in red, as about 3% of the whole of the total study area. As a conclusion, this research demonstrates the potential and capability of radar satellite data and INSAR time series technique to investigate and monitor ground surface deformation and to measure mean velocity in the line of sight direction in millimeter accuracy over time using freely available data and software. The integration of artificial neural networks analysis and PCI technique with the help of GIS can be considered as an attractive method for geological hazard tasks, providing important results that can be regularly updated to be used in the disaster management planning process. Thank you for your attention.
Thank you. And as far as I see, the authors of the presentations are not here with us.
Nope, I couldn't get Muhammad joining. Sorry about that.
Then we should step into the last presentation. I will just this is about accuracy analysis of Sentinel-2A and Landsat 8 OLI plus satellite dataset over Kano State in Nigeria using vegetation spectral indices. And this presentation will be given by Mr. or Mrs. Isioye.
Yeah, good morning. The title of my presentation here is Accuracy Analysis of Sentinel-2A and Landsat 8 Operational Land Imager Satellite Data Sets over Kano State, Nigeria, using vegetation spectral indices. My name is Isioye Olalekan. I have my co-presenters, Akomola Fair and Ikweze, all from the Department of Geomatics, Ahmadu Bello University, Zaria, Nigeria. Outline of my presentation, introduction, materials, method, we have the results, and just a quick conclusion. Land-use mapping is a vital topic in the study of surface ecophysics together with vegetation, soil, building, water, and other surface elements. Amongst them, vegetation is the most stable to identifying surface climate change. Presently, remote sensing in an applied approach for vegetation appraisal by using vegetation variables, which varies vigorously in time and space. The foremost role of environmental remote sensing to land resource management is its prospects to mapping vegetation vegetation resources and to observe changes over prolonged epochs. Vegetation monitoring remains a fundamental focus within the science and practice of remote sensing, and however, the choice or accuracy of remote sensing sensors used in vegetation monitoring remains of great importance. In this study, we tried to explore the spatial temporal changes between two remote sensing sensors, that is the Landsat 8 operational imager and the Sentinel-2 over Minjibir local government area in Kano State. 4 vegetative indices were considered. This is the normalized vegetation index, leaf area index, the green chlorophyll index, moisture index for the period of 2015 to 19. As you can see, this is the study area. We have Kano. This is Kano State here. This is the map of Nigeria. We have Kano State. You can see the Minjibir local government. So the vegetation of Kano State is a semi-arid savanna zone. The zone has been described as the zone that provides the opportunity for optimal human attainment. These are the data types, as you can see here. 2 data types, as actually earlier described, the Landsat 8 and the Sentinel-2. Landsat 8 at 30-meter resolution and the Sentinel-2 at 10-meter resolution. The Landsat data was gotten from the Explorer, that is through the USGS, and we got the Sentinel-2 from the Copernicus. So this table gives a summary of the data set for the 3-year period, that's 2015, 17, 2019, the path row, the cloud cover, and the dates at which the different satellite images were up. So as part of the pre-image processing, the portion of which occurs the Minjibir local government was subsetted from each of the larger screens using ArcGIS software. Geometric and radiometric corrections were performed on them for the purpose of auto-rectification. The Sentinel-2A image were obtained as spatial resolution of 10 while that of Landsat was at 30, but we had to match up the 2 data sets to be at the same spatial scale. So during the data laying scale, all bands of the sensor's data, excluding the thermal band, were considered for layers taken. The nature of the different bands had to be considered to make a decision as to which 3 bands combination would be the most helpful for classification and visual interpretation. Thus, the first color composites was employed in this. So the image classification and accuracy, a supervised classification was performed on first color composition, that is bands 5, band 5, 4, and 3 for Landsat. Then we had band 8, 4, 3 for Sentinel-2 into the following land use and land cover classes. We had light vegetation, build up area, dense vegetation, water body, bare surface, and using the Anderson 1976 classification. So the accuracy assessment was done by determining a confusion matrix. This finds the relationship between the mapped class label and that observed on the ground or reference data for sample of cases at specific location. The overall accuracy can be determined by dividing the number of correctly classified pixels by the total number of reference pixels. So overall accuracy is considered as the most suitable method for calculating accuracy assessment. The Kappa coefficient of agreement was used to improve the overall this table shows just how the different vegetative indices were calculated. So this is the image classification accuracy report. This is the image classification between 2015 to 2019 for Landsat 8, and this is for Sentinel. This table 3 and 4 here shows us the classification in terms of, this is in the terms of the area size between the Sentinel-2A and the Landsat-A for the different years period. Then we'll have the classification accuracy also between the same period. We have the producer accuracy and the user accuracy comparison between the both of them, and they were perfect agreement. The results also, we still have this is the NDVI value for Landsat 8 and Sentinel-2 over the same period. These are just the plots. So this shows the various statistics, low value, high value, mean values between the. We also have the same for the grain chlorophyll index, also for the moisture in area index. So these are the different statistics as it applies to each of the different vegetative. So also a correlation analysis of Sentinel-8 and Sentinel-2A derived vegetative index was performed. So as we can see in the table here for the NDVI, DSI, MSI, and the LAI, for the different years, we could see the coefficient of determination and the coefficient of coefficient. So this shows the different statistics, though we can observe not too strong relationship between the two. As these are just some of the scattered plots between the two images and concern. This is for the NDVI, we have for the GSI, also we have for the MSI and for the leaf area. So in this study, multispectral analysis was performed on 2 different satellite sensors, Sentinel-2A and the Landsat-A for the Minjibir local government. Through the retrieved vegetation index, it was observed that high vegetation indexes are attributed with Sentinel-2A value with respect to Landsat-A throughout the time of study. From the comparison, it was found that the supervised classification from both the two sources are corresponding. Correlation was also made between the NDVI, MSI, CSI, and the leaf area index of the Landsat 8 and Sentinel-2. The results of correlation between the Landsat and the Sentinel-2A for the indices shows that the two are weakly correlated. However, the best average performance over the supervised classification was obtained using Sentinel-2 bands. The model based on Sentinel-2 data outperformed Landsat 8 model for all forest variables. Results were clearly shown in Sentinel-2A supervised classification due to the fine spatial resolution of 10 meters. The study recommends the integration of data sets from satellite remote sensing centers for provide optimized vegetation monitoring. I think that's just brings us to the end. Thank you for the attention. Thank you.
Thank you too. And I believe the author of this presentation is also not present in this event.
Yes, I can see him online, but I cannot reach him. So I have been trying quite a lot, but no response, it says. So maybe he has some technical issues to join.
Okay. Yeah. In other words, we are done with this session, and it's time for me to close it and to thank to all this and to all people who made it possible.
Yes,
thank you very much.
Thank you, Dimitri.
Thank you very much for.
Thanks everyone for attending.
Thanks.
Thank you, everyone.
Thank you all. It's very nice.
Hello, Brendan, and hello, Orhan. It's good.
Hi.
Hi,
Jack.
Best thing I could have seen is that we're both online and we're ready to take problems. Yeah, very good.
Very good. How's the day going?
Okay.
It's been going well. Yeah, I mean, you know, we've managed to, from my point of view, it's just I was interested in solving the tech problems, and you know, there was nothing fatal. So, good. You know, and actually the content's been great. You know, so we're going to probably just open up we've recorded everything, and we're going to open up the panel sessions for public.
Hello.
Hey,
Hello.
Orhan, how you going?
Hi, Brandon.
Nice to meet you, Orhan.
Morning. Good afternoon for you, actually.
Yes.
For me, 11 a.m. for you.
I'm going to try and not refer to time zones.
No, don't do it. Okay.
Very good. So
Very good.
I've read a little bit about your background, Orhan. You've been doing these kind of things for a long time.
Oh, almost, yeah. We started with Gi4DM also from the beginning.
keep the conversation clean.
Excellent.
No, I think we're all good to go.
How many participants you have had during the lectures?
We've had about 15 audience members between YouTube and Teams, so a very dedicated small cohort, and quite a lot of participation too from the panelists and the presenters. So it's yeah, it's actually been going very well. We've had some very good content actually. I'm looking forward to editing the videos and distributing them out to everyone.
Okay, wonderful.
Is Sissy online already?
She should be. I don't know where she is. Sissy. Okay, well, we're about to tick over to 7 o'clock, so I'm going to make this live into the live stream, and I'll leave it to you guys. Brendan, take it away as the chair when you're ready. Thanks.
Thanks, Jack. Hello, everybody, and welcome to this keynote presentation as part of the Geoinformation for Disaster Management Conference. This afternoon, or wherever you are around the world in particular time zones, we have Orhan Altan from the Istanbul Technical University Department of Geomatics to talk to us about his expertise. I'd firstly like to start this afternoon by acknowledging the traditional owners of the country on which we are at the moment. Myself, I'm in South Fremantle in Western Australia, which is Noongar country. So I'd like to pay my respects to their elders, past, present and emerging, extend that around the country of Australia, and also, given the technology we work with, globally as well. My name is Brendan McAtee. I work for an organisation called Frontier SI. Frontier SI is a not-for-profit that exists to deliver major benefits to governments, industry and the community using our deep expertise in spatial mapping, infrastructures and positioning, geology and analytics. So I have the pleasure of introducing Orhan Altan to talk to us this afternoon. As I mentioned, he's from Istanbul Technical University Department of Geomatics. His main working areas are digital and architectural photogrammetry, spatial information systems and deformation measurements, disaster and risk management. He's a member of the UN expert group of the ad hoc committee of the UN entity Space-Based Information for Disaster Management and Emergency Response, SPIDER, and chair of the Joint Board of Geographical Information Sciences or Societies, ad hoc committee on risk and disaster management. He was a former president of the ISPRS between 2008 and 2012, and the first vice president following that from 2012 to 2016. This year, he was one of the authors of Spatially Supported Data Management, Disaster Management, Introduction to the Special Issue from the Journal of Geoinformation on Geoinformation for Disaster Management. So the things we're talking about here are very close to his heart, and he has a lot of experience. Orhan will talk shortly. You can post questions in the chat if you're using Teams Live, or in the comments section if you're using YouTube, and we'll go through those in a bit of a Q&A session at the end of Orhan's presentation. Without further ado, I'll pass it over to Orhan to take control. You have the floor, Orhan. We look forward to your presentation.
Thank you. Hi, everybody from the different parts of the globe. And I think we will going as the closing ceremony. You have had a very successful conference and very successful one, despite several obstacles we are experiencing during this pandemic days. Let me say something about the Gi4DM. Sisi Zlatanova, my close friend more than several years in ISPRS, etc. She organized the first Gi4DM in Delft. And from that now on, I have participated almost to all of the Gi4DM conferences, which has been a very successful series of events, and which has been considered from the Unions, Geoinformation Societies, as the main conference regarding the disaster management. And we have organized several publications from these conferences. And also I have organized two of them, one of them in Antalya, the other one in Istanbul. So I know how difficult it is to organize such an event and also to bring people together and to have it. But I'm sure that with her skills and with the help of the organizing committee, you have had a wonderful conference. Today, I don't want to go too much of the technical details because now we are at the closing. Therefore, I have chosen a subject which is a closing and looking forward what we are going to do after the pandemics and after so many say disasters happening all over the parts of the world. So therefore, I want to give some emphasis on what was changing on this planet during the before and after this coronavirus, and how we live on this present, and what we changed in our human needs in the last years, in the last decades, in the last centuries, and what we have to do in the coming. And therefore, my outline is I will give some examples of the day, what the daily life during the coronavirus has been. Then there is before the coronavirus, what was changing in the world. And then I will talk about system of system, which I give to this emphasis, to this wording, many systems, and with 3 points at the end, and very important. And so how the society responded to these changes with Millennium Development Goals, with the UN 2030 Agenda, and then coming back, life during the pandemics and later, and then some forward-looking. This is the outline where I'm going to present you today, try to present you today. And this is the first slide. Left top is the street, the main shopping street, where you see a tram trying to go through the crowd. This is the main street, combining the main Taksim square and a crowded people. Several thousand people are. And nowadays, the government of Istanbul gave permission only 5,000 people can also be hosted at the street so that the social distance can be just maintained. But during the pandemics, the street looks like this, total still. And of course, this is a slide, maybe some of them you have seen, the fully zebra crossing every day. These are crossing, so that the life is changing. The life is changing. This is very important. And we do have also some positive effects during the pandemic, so that during this, so we have seen the nitrogen dioxide in China, how during the pandemic nitrogen dioxide has. I had to stop there because it will come one of the at the end once more. But there are some positive effects that the natural habitats of it, they are enjoying the peace and quiet. This is the street in South Africa's famous Kruger National Park. The lines, the national habitats are enjoying the warm asphalt street and the warmth of the sunshine. And this was their homeland before. And the dolphins in the port of Istanbul, they came because they stopped the ship of transportation so that the dolphins could get into the port even very much closer to the people. Here you can see the dolphins. And I will show. And of course, another positive effect from India, so that from 200 kilometers away, when the pollution because of the lockdown has been just gone away from Punjab, we can see amazingly the part of the Himalayas very far from the village. And the nighttime lights of Wuhan during the pandemics left up before, then 2 weeks later on in desert. What was the life before the pandemics? What type of disasters we have had? What type of how they changed the world? We were experiencing heavier precipitation and more intense and longer droughts, like this train, this commuter train in Chemnitz, going to Chemnitz from Berlin. And can you imagine this area of Germany is a very flat area, and it's been this train stuck in the heavier flood. And also many parts of the world having longer droughts. And the most important thing, what changes in the world is that the human population immensely, and according to these graphics, which I have extracted from the UN, they have projections that we will reach at the end of 2050, 7 million. We have exceeded this now, 9 million maybe, the medium, and or close to 11 million according to the three low, medium, and high projections. This is one of the causes of it. And because of the population growth, the urban growth in all the world, in all parts of the world, increased during the 17th century tenfold. Now, more than half of the world's population live in urban centers. And these urban centers make the disasters, and also several types of disasters. Not only the geological one, not only the floods, etc. And also if you look to the concentration of the infected people by the coronavirus, then they are also concentrated in the cities where people are coming together. Therefore, it's one of the changes in the world is before the pandemics were that the urban settlements expanded highly. Now I'm showing you a very interesting detail, which I made a project of 50 years of my development of my country, my city, Istanbul. This is, as you might know, this is the Strait of Bosphorus, dividing Europe. This is the European part, and this is the Asian part. And in 1945, according to what I have extracted from the census data and from some aerial photographs, etc., the red areas are the living areas, population where people are living. And the green areas, there were forests. And the yellowish one, the areas are lands for agriculture. Now, after several years, it changed. Now I want to show you some changes. Look, it was at 1.1 million in 1945, 1.1 million. Now, 68, it grew to 2.8, and as you see here, the red spots, the residential areas are growing. And why? Because, and another one, the forest areas are diminishing. And then afterwards, we see 88, 6.1 million people. And there is one bridge here, or the second bridge here, and along the axis of the bridges, the population growth goes to the north and destroying the forest areas and also the agricultural areas. And this is 11 million people in 2000. And you see the whole part of the is almost the central part is populated by residential areas, and almost half of the forest area and as agricultural area has been taken over by the residential area. At that time, at 2000, it was 11 million. Now it is close to 16 million people. And this condensed living structure makes the big cities vulnerable for every type of disasters, including health disasters. What was changing in the world? Coming back, this is some photographs taken from the Greenland, almost 10 years apart. On the left, you see the picture of Dan on the right, 10 years afterwards. And the ice melting. Now, if you will take it, almost, it is separated to some being and changed in some smaller islands, the Greenland. And what causes it, this ice melting? The ice melting is caused because of global average temperature. And I took this graph from the International Panel of Climate Change. This is IPCC. And the global average temperature change, you see the curves, especially after the 1950 here, 1950, it's rising rapidly. And because, parallel to this, the global sea level is also rising. We can see it here. And the other one, which is very important for some parts of the world, the northern hemisphere, snow cover is diminishing. And for some parts of the world, these two effects, sea level rise and snow cover, diminishing is very important. The sea level rise is important for, very important for causing some big deltas like the Punjab, the Nile Delta, the Amazon Delta, etc., especially in the Punjab Delta where there is a flat land. We are having a big problem. If the sea level rise is going to go like we have experienced today, now the people almost living, several million people have to migrate to the north or to the west. And if they go to west, it is India. And the India cannot accommodate so many migrants, and this might bring some of the other cause armed conflict in that area. This has been already mentioned by the UN Secretary General Ban Ki-moon several years before as one of the high points in the coming centuries. And the Northern Hemisphere snow cover diminishing is a problem also for India and also for some parts of Europe, because this is the freshwater reservoir for all these countries, especially northern India's freshwater is dependent on the glaciers. And this is also for some parts of Italy and some parts of southeast of France, etc. They do have some threat from this ice. And you see the very important glacier changes throughout the world, and the glacier balance of the mountains areas is very important for many countries and for many parts of the world, as I said to you. And you see that especially in the Alaska and coastal mountains and the Arctic, this is the Arctic, and also the Asian high mountains. These are also going down. The cumulative glacier balance is going down. And this is very important. This is also which I have got from the IPCC report. And another very important problem is the oceans, the water bodies, the big water bodies of the globe. And 80% of the world are climate change. They are affecting the sustainable living of the mountains and the depth of oceans. And how? This is a very recent report from the IPCC once more. As we see here, that the glaciers are going down and also the snow cover, the permafrost temperature is rising. This causes the snow cover diminishing and the glacier mass. It causes the sea ice and the cars also reducing, and it was a sea level rise, and the marine heat waves also rising. This means that the ocean heat content is also rising, doing pH concentration on the oxygen and the oceans going down. This is cause very big problem for the planktons, for all fishes living in these oceans. And we have to be very careful for the generations, especially for this ice. And what's happening is the disasters. There are 195 countries around the world, and most of them are affected. And almost 100 billion damages in this year, only in 2016. And the most important thing that from the extreme disaster, China, India, and Ecuador, they are having the most highest deaths, and they were affected also highly from the humanitarian part, and most of them are occurring in all these points. And in 2017, we do take care of the human lives, but we pay a lot of money because of the infrastructure damaged by the disasters, and we pay a lot of to the destroyed factories, the destroyed industry, destroyed housing, etc. And this is the graphics, which is also very recently, only published in 2018. There are several big disasters happening. In 1995, the Kobe earthquake, then the Katrina, Irma, Vilna, the US tornadoes, and hurricanes. Then the most important one in 2011, tsunami Tohoku, and then once more in US, the tornadoes of Hawaii, Irma, and Maria, which caused several deaths and large economic impacts on the country. This is the slide which I said to you in the beginning. System of systems and systems, I say to you. And this is a slide which I am showing in all my presentations, in all my classes, etc. This is the encapsulated system of systems in our globe, in our system where we are living. We are living in the water cycle. And as I said to you, if we change this water cycle, there are some effects. If we change this ecosystems, then the carbon science cycle is changing. We are changing the whole land surface through transportation, through agricultural activities, through industries, and the terrestrial radiation is rising. And what shall we do? We have to take care of this system very heavily. And this is a warning that the IPBES, this is a intergovernmental panel for platform on biodiversity ecosystem services, IPBES. This is a very big intergovernmental organization which is supported by UN, UNESCO, and International Science Council. And they say that the coronavirus pandemic will likely follow. There will be several diseases, outbreaks, unless we don't know the roots, that is called. There is a very small species caused the COVID-19. And they say recent pandemics are a direct consequence of human activity, particularly our global financial and economic system that prize economic growth at any cost. Therefore, the last red sentence, which I showed here, is very important. Economic growth at any cost. This is a very important sentence, very important. And the 2003 goals, which I'm going to say, they say we have to look into very integrated and global pensions. Future, how it will look? Rampant deforestation, uncontrolled expansion. That the future pandemics are likely to happen more frequently spread more heavily and kill more people if we don't have care over their impacts. Therefore, our Earth system is a dynamic system. If we have forces acting to the Earth system, then the Earth system responds to us. And one of the responses is the COVID-19. It is also changing so much part of the world and how the society responded to it. They have seen something is coming at the change of the century. And September 2019, leaders of the almost 200 countries came together and they have a Millennium Declaration. And this, in 2002, they have set up the Millennium Development Goals. At that time, there were 9 goals which have to be fulfilled. And for the first time, people are taking care of the environmental sustainability. And if you look at other goals, they are mostly related to the health, to the peoples living on the globe. But the Sustainable Development Goals are different because in 2015, people came together and the Sustainable Development Goals are focusing on the social and economic factors. And therefore, it is more universal than the Millennium Development Goals. And these 17 goals and almost 170 targets and several indicators hopefully will help us to overcome the problems the societies are experiencing. And all states have signed this agreement, but as you know, the Paris climate change agreement has been also signed, but one country or some countries has withdrawn from this Paris agreement. Hopefully they will realize that this cannot be the problem of their country. This is a global problem which will affect also their countries. Now we have living together. Infectious diseases are expansionally coming. Containment means we are experiencing very big spreading, limiting transportation, exchange of goods, and causing some fear and social isolation should not be the sustained weapon against the pandemics, etc. We have to look for the future, okay? We do have the social distancing, we do have contact tracing, but with all these contact tracing, etc., we will have to overcome the problems of the pandemics. But several countries and several inhabitants of these countries are against the social distancing and contact tracing, and this causes also some problems for us. And this is one of the weapons we do have means in order to combat this pandemics. And through this tracing, we can have a success after the pandemics. And of course, there is privacy risks during the social distancing and tracing people. And therefore, there is a personal information. We have to take care, the governments should take care of that this privacy is being kept down. And the European Union, digital solidarity, they are calling this, but big data, big responsibility to the governments and this is a very important that we have to take care of the privacy and look after the big data handling. And this is the geomatics area. And big data, we are not only having the photogrammetry and other remote sensing and Earth observation techniques, and we have to take care of the data, what we are driving through different observation systems. And therefore, after the post-pandemic, we have to take care of the data sharing, and this data sharing, how the value of the data sharing could be benefiting from each country. And therefore, we have to take care in the economy, in the society, in research, etc., education, and government. And therefore, a good example is the Landsat that seeds downloaded after the Landsat seeds has been open data policy. The annual economic benefit internationally rising totally globally to $2 billion of if after the Landsat seeds being open for everybody for use. Now, we have in the last centuries coming from Industry 1 to Industry 4. And the first industrial revolution was a mechanical production equipment. The second one, a mass production with T lines, etc., assembly lines. Third industrial revolution was based on the IT technology and automated production, programming machines. Fourth, where we are living now, based on the use cyber and physical systems, so that can turn. But we are having a complex degree of interdependence. And this means a new area is approaching. A very new area is so that we machine, man, human beings and men are connected to each other. The industrial upscaling will be very important, that we have systematically prevent waste and wasting during systematic events. If we don't do this, we will have look for another planet maybe to live it. And the connectivity is that we have to take care connection of all sensors. We have to take care what does it mean for geosciences. Between the satellites circling several thousand now on the globe for space sciences, all satellites have to take it. And there are some bottlenecks, of course, the connectivity. And the connectivity, some of them has been just doing it. Some companies in Germany and US, they are having this problem, laser communication, especially through the satellites, which gives a very high rate of data transmission from satellite to satellite and from satellite down. This gives us some possibilities for the future. Now, I want to come to a slide which I like very much. Sometimes I show this slide. But let me read this. It is a very important one for me, how the society changed. Beginning on the humankind, science was a means to help inhabitants of this earth to ease their lives in harmony with the nature. But unfortunately, it is forgotten later. A wonderful example is this definition from the discrepancies between the Native Americans and people who conquered America. It is reflected Chief Seattle. Chief Seattle is an Indian chief, and his very famous speech, this speech is being engraved on a marble plaque in Seattle. And he says, as at the first preamble, how can you buy or sell the sky, the warmth of the land? The idea is strange of us. If you do not own the freshness of the sparkle of water, how can you buy them? And I think there are several similar ones with the inhabitants or former inhabitants of the Australia, New Zealand, and Africa, which we can quote here. This is Chief Seattle. Now we have to look for the future as scientists. We have to take care of the new approach. We have to advance science as a global public good, not for something else. Global public good, not for a region public good, global public good, because we are interdependent. And the science tells us we will have a, once more the slide I'll show you. If we don't have realized that economic system that drives economic growth at any cost, if you don't change it, then this is not a public global good. And we will have the future pandemics, which will happen more frequently, spread more rapidly, have greater economic impact, and kill more people. And if we fight with the pandemics, we may get the first round. This is the first round. We may win the first round, but there is another bigger one is waiting on the queue, and we have to take care of it. Actually, this is my last slide, but I have, as you, Roberton, already mentioned, that I am the chair of the International Science Council Joint Unions ad hoc group of disaster risk management. I want to add 3 more slides with your permission. International Science Council is a non-governmental organization with a unique 40 international scientific unions and associations and 140 national and regional scientific organizations. Among these 40 international scientific unions, ISPRS is one of them, and several joint unions are together with them. And I was, as the preceding ones, executive board 7 years in the ICSU executive board. It is the only international non-governmental organization bringing together the natural and social sciences and the largest global science organization of its type. And we do have joint unions, a collection of international unions, we call them, and we do have a steering committee, and we do have from every union. What are they? Astronomical union, cartography, geography, quaternary research, ISPRS, Union of Geodesy, Geophysics, Geological Sciences, Soil Sciences, and Radio Sciences. These 9 comprise the joint unions, and the steering committee, which had a meeting in Paris at the joint unions centenary, gave me the task to form a committee, ad hoc committee. And this committee has been formed now and started working this summer, beginning of the summer, where our very good friend Sisi Zlatonova is a member of this committee representing ISPRS. And please follow us at the ISC GeoUnion's ad hoc group disaster and distress management COM. This is the GeoUnion's ad hoc committee webpage, and we will have the first policy brief immediately next week, hopefully going around the world and advising the societies, NGOs, and national government some advices on the temperature monitoring and meteorological observations. Thank you very much for listening to me. I haven't looked to the timing, but I hope it was adequate. This is the end of my presentation.
Well, thank you very much, Orhan. Timing is perfect, and you've covered a real lot of ground, I have to say, and all very, very prescient where we sit at the moment. I might ask a question of you using my prerogative as the chair. So when we're dealing with the global change that you've been talking about, and you talked about it as describing it as a system of systems, and indeed more than nested than that, a system of systems, and so on. I'd like your perspective on how or whether humans are suited to dealing with that level of complexity. And if so, what data do we need to actually drive action, successful action on the things that you've been talking about?
Yeah, this is a very important issue. This is actually the essence of what we are living. This is not disaster management or risk management. This is the essence of human planet living. And therefore, I want to say something. In the economics, where people give always a big value, there are two important, let's say, definitions: macroeconomics and microeconomics, micro and micro. And they took care of both of them, as well as macroeconomic, set of them microeconomic. And this system of systems, we have to take care of all microsystems so that it is not changed. And we have to take care of the macro system that it is under stable conditions, doesn't change. Therefore, if you do look only for one, if we want to prevent one disaster, we should be careful so that by our prevention, we don't cause any other disaster. We don't affect other systems. This is what I mean in this one.
Thank you very much. Perhaps a slightly different question. So if I think now about Turkey, where you're from, what in that part of the world, what are the highest risk natural disasters for Turkey in that part of the region, and what do you see are the key geoinformation needed to respond to these?
Yeah, the most important thing is that we are prone to, Turkey is like US West. I'll show you on the slide, which I don't have it now, but I have it. The African plate is moving upwards to the north, then it causes a plate, and it causes along the north part of Turkey a very high vulnerable fault line, and we call it North Anatolian fault line. There are two active fault lines in the world. One of them is this North Anatolian fault line. The other one is starting from US San Andreas fault line in California, going down to the west coast of South America, and this is one of the two. Therefore, Turkey is, from the geoinformatics, we have to take care of the stress accumulation. You can measure by several transducers, and by several observations, the stress accumulation predict. But the statistics in that sense play a very important role. Not only the geological hazards cannot be predicted, unfortunately. So therefore, but another one disaster which happens very much is the landslides. And you can measure the impact of these landslides coming from meteorological data. When the rainfall is heavily coming down, you can predict which part of this one. Having some the geological parameters into your model, you can use it in very high sense, the geoinformation technologies in the landslides. And of course, several other disaster types which occurs here are the high temperature droughts affecting now through climate change. As I am based now in Istanbul, we are having a water shortage maybe in the coming weeks as the rainfall is very low since 2 years. This is some of them which we can measure, which we can predict now.
Thank you very much. One of the other things that you referred to, and the quote that you referred to from Chief Seattle, and that's one of my favourite quotes as well, and I think often about that. In thinking about that description of the natural world, what's your perspective on do we need to give the warmth of the land and the sparkle of the water, do we need to give that an economic value, or do we need to change the systems which we live, the way to describe? What does change look like in that?
Everything should be in balance. This is the most important thing, is that without any economic value, we cannot live. But without taking care of the warmth of the water and sparkle of the water, etc., we will not enjoy. So we have to take care the essence of living from the beginning in our education. Education starts from the birth. And we have to take care of what is the success of a human being. Being a very rich man, being a very successful soccer player, a football player, or having a very good scientist doing some extraordinary. What makes us happy? We have to change the parameters, our way of thinking, what makes us happy living on this earth. And this is a very different and very deep philosophical change in the minds of the people.
I think you're absolutely right. So it's a very big philosophical change. So another point that you talked about around connectivity and the increase in connectivity, which is coming, which is required to start addressing these complex system of systems. Here's a bit of a devil's advocate question. So the idea that if we're making these sensors ubiquitous, and all these ubiquitous collection of Internet of Things sensors require materials and different materials to make them, are we creating another problem that we need to solve through that ubiquitous nature of IoT sensors and developing that level of connectivity that you're talking about?
Yeah, we are creating, but we have to take care, as I said to you, of this connectivity in a positive way, not destroying the microsystems. The microsystems, which I told you, is very important for the human living. But this has this connectivity and the sensors which are connected to each other, the data which they serve us, they should serve the human being, making the human needs much not complex, making the human needs much simpler, and we have to train ourselves to be more simple, to be more happy that we achieved simple questions, answers. This is it. We have to take care of our living philosophy. This is a very important issue. And as I said to you, and also several times in my, let's say, discussions during dinners, etc., and also some think tank groups, we need politicians who is also not only politician, good speakers, also good thinkers, good philosophers. And the world needs these philosophers and these, let's say, gray people.
Yeah, I think they're really interesting perspectives. And one of the other things that I think about when we talk about these kind of big ideas and these philosophies is, you gave the quote from Chief Seattle there, and I started the session today talking about, the First Nations people of Australia, and they have a lot of traditional knowledge about, systems and those kind of things. How do you see that knowledge, which I'll call as very, very old knowledge, becoming new again? And do you see that as important in the kind of changes that we're talking about?
Yes, this is a very important context. And the International Science Council has decided 5 important areas for study in the next years. And look for indigenous culture. Invest in the indigenous culture. This is one of the points of the science should go in the future. If you wish, I can give you a detailed, forward you a detailed brief on it, because indigenous, not only Australia, not only in New Zealand, also in Africa, and also some parts in South America and Latin America, they are very valuable, especially seen in many parts of the science, very important. Yeah, Brendan.
Once again, I certainly agree. So we talked about, we did cover a lot of ground and a lot of systems of systems. When you move out, get a bird's eye view of what's going on and how those systems interact. We talked a lot about coronavirus and pandemics. Is that the most pertinent, I guess, threat or disaster that you see? What other ones are close behind, and what do we need to start thinking about to minimise those impacts?
I don't have any just in German it's called Wundermittel. I don't have any magic solution for this, but I can say we have to take care that we are humans and that we humans where we are vulnerable. We are vulnerable from a very single species. And this very single species is attracting all the humankind living on this planet. So I see that there should be an change of understanding of living. Yeah. And there will be many other disasters which will happen similar to species. Whether this species is being natural one, whether this is being just manufactured in a laboratory, etc. Somehow it has been flipped out outside. We cannot say anything about it because the most important thing is the real knowledge, how it has distributed, and we don't know the source of the distribution. We don't know the creation, how this was created and how it has been made. We don't know the essence of this disaster. Therefore, I cannot tell you whether it will be more these type of disasters or not.
Thank you again. I'm going to ask one last question. We're almost coming up to time. We can certainly keep chatting on the Teams Live part. The YouTube feed will move on to something else. The closing of the conference. I'm going to ask you, Orhan, we've talked about a lot of possible dangers. We've talked about disasters. I like to leave these things on a positive note. What's your message of hope?
My message of hope is if we stick to science for global public good, everybody will be good.
I like that. And I know you don't have a magic wand to wave to make it happen. What's the number one thing that we as a society, and perhaps going down to us as scientists, what should we do? What do we need to do, and what does science need to do?
So that the politicians recognize science is a wundermittel.
And how do we do that? Just quickly. How do we do that?
I don't have this one. I cannot understand how we do with this one. And some parts of the world realize this. You are lucky that Australia is one of the countries who realize this. And your neighboring country, New Zealand, is one of the countries who realize this, that science is a wonderful one, because I'm attracting many scientists from both countries in different areas, in chemistry, in environmentality, etc. I know how the science is being valued in your country, science advice in your country and in some countries. This is the most important thing, that the scientific advice is being taken as a means to interact for the politicians and funding.
It's been a pleasure talking with you.
It was my pleasure to talk. Yeah.
Thank you very much on behalf of everybody who's been listening this afternoon. The YouTube channel will now split off. We're still here on Teams Live for a little while.
Actually, no, we're all in the same meeting now. We've fused them into this one meeting. So YouTube will just continue, and then we continue. Yeah, we have reached 8 p.m. And we can segue. We can keep going here if we wish, or segue across to the awards. So there are some quick questions in the comments, but I've got a vested interest because one of them's mine, and also my boss asked the other one. But everyone, please feel free to put in any questions if you do. Yeah, thank you. Brendan, can you see the Q&A?
I can't see any Q&A.
Oh, okay. If you go up to the little icon at the top with the like a little text bubble, the chat. Can you see like a chat?
I can't see a chat bot.
Oh, okay.
Top.
Well, maybe I could actually ask one of the questions. Well, we should just, just for a brief. Well, actually, I'll ask my boss's one first. Do we need new geospatial technologies to be able to manage the systems of systems?
Of course.
Yes.
This is one of the most important observation technologies which we are having now as a magic tool in our hands. We need it. We need it because we are one of the sciences which has the capacity to connect the different type of sensors, different type of observations coming to a single end. And this is one of the important facts that the geospatial technology gives the possibility to the humankind.
Okay, there's another question from Mitko. How do you think people will fight the problems related to climate change? Through technology or by changing the parameters?
Both, not only, both of them. This is a balance, and you have to take care of both balance. I
think my question alludes to that a little. it was a bit of a loaded question. I've said, has the COVID epidemic hurt economies or demonstrated commerce can rapidly adapt in the positive?
Could be, because we changed the way of living now during the pandemics.
Yeah, very
and
rapidly.
It changed also, yes, very rapidly, and we are having the internet connection with all the shopping markets, etc., and the deliveries. They changed the living positively, but doesn't change the economy, the public economy very much. The micro economy is maybe in some parts are rising, but the macro economy is not very much.
Well, Brendan, I think I'll throw it back to you to conclude this session, and then we can segue across to Petra for the next.
Fantastic. Thanks, Jack. And I'd just like again to thank Orhan for that really comprehensive discussion around where are we in the world, what does COVID-19 mean for us, and as humans, how do we start to deal with these systems? I think that's really important. I think, as you talked about, we have the capability to do it. We have the data to do it. I might just throw to you for one last comment, Orhan. If you could do one thing, what would it be?
One thing. It sounds like my last wish. I don't say this.
If you have your magic wand?
No, I don't have it.
All right. Thank you very much for a wonderful discussion again.
Thank you.
Thank you all who have been listening throughout, and I will pass over to you, Petra.
Thanks a lot, Brendan, and thanks a lot.
Petra, may I interrupt you before you start?
Of course you can. Of course you can. If somebody can,
sorry, I want to say something very important. Actually, the conference, we are already at the end of our conference, Gi4DM, and most of you know that this is not the only conference. So we started with SSSI, and Europe 2 is continuing. Tomorrow they have also sessions. And actually these 3 days, Gi4DM, they were very intensive, much more intensive than a normal physical conference. I believe the team behind the screens is completely exhausted, but somehow it is also sad that we have to finish the conference. It was very nice and very fruitful. And actually the speech that Professor Altan gave, it's really like bringing the point of all these conferences to human being, to climate change, and what we can do to preserve our planet for our kids. So it was a very nice conference, and we have prepared for your presentation with summary of all the events. And it's going to be given by Petra. But before she starts talking, I want to say something about her. Actually, because she's a big factor in all this event, and I have to acknowledge it. So Petra Helmholtz, sorry Petra, is a senior lecturer, photogrammetry and special sciences in Curtin University. She got her PhD from Germany, and in 2006 she started working already with University of Melbourne. It was some kind of collaboration between Leibniz University Hanover and the University of Melbourne. And apparently she liked it here in Australia, because in 2012 she moved to Curtin as an academic staff member. And she is very dedicated to her job, but she is also very dedicated to binding photogrammetry, remote sensing here in Australia. She is chair of the Remote Sensing and Photogrammetry Commission of the Australian SSSI, Surveying and Spatial Sciences Institute. And she is also regional committee member of Western Australia. So actually, because of her, we couldn't attract SSSI working together with us for this week of events. And I have to say thank you, Petra. It was very interesting. And now you can go further with the summary of Gi4DM.
That was a very, very nice introduction, Cici. Thanks a lot. And I will show at the end of the presentation that there were lots of helpful hints for this conference, but I completely agree with everything you said. I have to say that online conferences are more intense than face-to-face. And that's not the only reason why I hope that soon in the future we can do face-to-face conferences again. Thanks a lot for the very nice introduction. It was a bit of a surprise. But yeah, I will try to get started with the presentation and then hand over to you later on again. So I will share my screen and I hope that everything will work fine. And I hope that you all can see my screen.
Yes, thanks. Yep.
All right.
Yeah, it's all good. Yep.
Thanks, Jack. So yes, I have the, Cici had the pleasure to open the conference, and I have the pleasure to have the closing session. But before I start, I also want to acknowledge the traditional owners on the land we meet. And as for Brandon, it's for me the Nuna people, so the Watcher people of the Nuna Nation. But I would like to extend my acknowledgement to country to all of the traditional owners, which not just includes Australia, but also New Zealand, Canada, the US, in Latin America and other parts of the world. And if something was clear, not just from Oran talk, but also from talks during the conference, is that there's a big immense of knowledge. And if we want to stay alive as a humankind, I think we have to go back to the roots, basically. And Oran, I think in the future I will refer to the phrase, how can I buy or sell the sky? I think it's a very nice phrase, and thanks for sharing that with us. All right, so now my presentation disappeared. As Cici already mentioned, it was or still is a very eventful week. It was not just the Gi4DM, which was running for the last 3 days, but it's a whole week which focused on climate change and disaster management. So on Monday, we had the New South Wales and WA online conference, and that's also due to COVID-19, as that's 2 states on the opposite side of the country. And while we're in the same country, we're still 5 hours by plane apart, could organize this conference together. So thanks a lot for all of the people contributed for this conference. Then Gi4DM, where I will provide lots of more details. And then Cici already mentioned that the Urban Resilience Asia Pacific 2 conference is ongoing. The start today and will run into tomorrow. The URAP is a free conference, so if you are interested in the topic further, please join the team. Just some brief information about Gi4DM, so Geoinformation for Disaster Management. Cici, who is still very active in this field, and thanks for bringing the conference to Australia. With you, that would not have happened. And thanks to Oran and all of the other active members in the society, in the group of Gi4DM, that the 13th edition could take place in Australia. So Gi4DM started in 2005, directly after the Indian Ocean tsunami in 2004, and since then it's an annual event. And I think the next 2 points were summarized by Oran quite lovely. There are some people not on mute. Jack, could you please fix that? As what Oran nicely summarized that, yes, we have a rapid urbanization, so we have increased population, increased density, and therefore the prediction and monitoring and the prevention and governing of man-made hazards and natural disasters becomes very, very relevant for many parts of this world. But as also Oran mentioned, we have different sources, we have different experts, we have different knowledge. We have to try to get those together to talk in order to advance the science and to raise awareness also to politicians and policymakers. We have lots of data sources available. So in the last decades, there was a shift from getting data to actually start to process and analyze the data. And I think the conference the last few days made this clear as well. The challenge is not anymore to gather the data, but the challenge is to implement technologies, geospatial technologies and techniques which can be rapidly used in case of disasters. That includes the prevention or the early warning phases. It includes then actually in the case of the disaster to react in the most efficient way, but then also the recovery phase, which was mentioned in a number of talks in this conference as well, especially looking back to the 2019-2020 fire season on the east coast of Australia. So Gi4DM is a very good platform to try to provide or to get people together so we actually can collaborate, so that we not have just the researchers, which of course is a major group of this conference, but that we also have the disaster managers and the emergency responder attending. And to be honest, I think we could achieve this because one of the keynote speakers, Jeremy Futel, is actually the lead of the fire and rescue in New South Wales, and he could nicely show in his talk of how they actually use the technologies which are provided from our professionals. And as already previously mentioned as well, it's important that it's international cooperation. That's Gi4DM is co-organized, so it's not just us. It's the ISPRS, the ISCRM, which Oran mentioned, the UN, OOSA, ICA, FIG, OGC, EuroSDR, and AGIA. So it's important to consider all of the different professionals, but also to different organizations and societies, but also to bring decision makers on board. And that's maybe what we can try to do in the future, so we can have more positive science impacts in policy making. The map of Gi4DM conferences is shown here, and there were many places where Gi4DM already took place, mainly in Europe, so specific in the Netherlands. I think there's a high correlation with CC as well. France and Italy. Oran already mentioned the conferences in Turkey, which is of course not part of Europe, but part of Asia. So we had the Czech Republic in Europe as well. We had overall 4 countries in Asia, in India, Vietnam, China, and Turkey. And we had it also in North America, in Toronto in 2007. So Gi4DM 2020 was the first one in the Southern Hemisphere. And if you're from Australia, you know this phrase, but yes, we have the biggest skyscraper in the Southern Hemisphere. But now we can say we also were the first to host Gi4DM in the Southern Hemisphere. And also the first time in Australia and Oceania. And Gi4DM 2020 is also unique because it's the first fully online, and therefore I think the first fully global event in the series, which as already covered, was due to a disaster which appeared globally. And I think if you all think back what we did 1 year ago, it's just amazing of how quick something can impact the whole society, not just parts of the Earth, like in the past, but the global, the whole globe. And I think one of the main reasons is the connectivity, which has lots of advantages, but in this case had also some major disadvantages. That it was a truly global conference also shows the countries where the participants came from. So we had over 247 people attending the conference. We had, due to the time zone, lots of people dialing in from of course, Australia, but also China, New Zealand. We have representation, or we had participants also from Africa, from Latin America, South America, North America. I think truly global. The only one missing is Antarctica, but maybe we can change this in the future, because due to the technology, there should be we should not be limited anymore. If you break it down in numbers, you can actually see that not just Australia was very active, but also Italy. So again, Europe was quite active, and that's shown on my next slide as well. But you can see they had also, yes, Nigeria, Singapore, South Africa, China, Dominican Republic, Germany, Greece, so truly internationally. And you can see, yes, the majority of the participants were from Europe and Australia, Oceania, pardon me, on the second. The conference had 4 keynotes. I really appreciate that Jeremy, Susan, Oran, and Philip took the time out to give this your keynote speaks. They enriched the conference a lot, and I think Oran's keynote at the end really summarized the event quite nicely. And Oran, I already took one of your screenshots. It was very impressive to see the changes in your images, but similar images from across the globe. But then also the talk from Jeremy, from Philip, and Susan as well. Sorry, quick. So overall, we had next to the 4 keynote speaks, we had 10 scientific sessions, which cover a wide range of topics connected to disaster management. One of the big topics were warming and cooling, and the impact of urban heat and heat islands, which I think in the future will become a major issue, especially for the dense populated areas in regions such as Australia, but also parts of America, Turkey, and in Asia as well. The second session title focused on fire and flood. Fire, I already mentioned the 2019-20 fire season in Australia, but also fires such as in California or in Europe, which become more and more frequent, and flooding events especially. So Susan's talk covered a lot about this when it comes to cyclones and flooding events. The shift away from the data more to intelligence and recovery was shown in the section where we had lots of different platforms such as mobile mapping, scanning, or UAVs, which then were used to actually provide analysis, spatial precise analysis for decision makers. And one of the talks I have in my mind is the talk from Italy, where they use mobile mapping scanning to actually analyze what is the best way of how to react to COVID-19 and social distancing rules. We had the next session, or a number of papers focusing on remote sensing for disaster management, and it's a topic which has been part of Gi4DM for a long time, and especially where we have more and more data available, high resolution satellite data, drone data, airborne data, the analysis and the processing of the data to make it accessible for decision makers in disasters is very important and ongoing topic. And the last session title was Managing Disaster and Changes and Applications, where we try to use the systems of systems to actually get to the information required. Overall, we had 38 scientific talks. All of them were recorded. Lots of the presenter took the time to provide video recordings. They were online. Some of the people got up very early or stayed up very late. So I much appreciate all of the contributions. And the 38 papers, scientific talks, have papers, overall 22 ISPS archive papers and 16 ISPS annals papers. And those papers have been published already on the ISPS webpage. So if you found one or the other topic very interesting, I motivate you, go to the page, find the paper and get in touch with the authors. Thanks a lot to the chairs. So I was very busy in taking screenshots in the last couple of hours, days. Thanks a lot to Celia, Nancy, Dimitri, Charles, Korosh, Chris, Alice, and G as well. It was sometimes a tough time, but I think the chairs and the presenters helped to deliver a very successful event. Back to the authors. So overall, mentioned we had 38 papers, and here you can see the distribution of where the authors came from. Again, Australia and Italy are the strongest, but you can see that the third strongest nation is Vietnam, and then USA, Spain, and lots of European nations. So it's very good to see the shift also to countries which are very much under risk to become more active in Gi4DM, so that Gi4DM actually can provide a platform for everyone who not only does the research, but also can benefit from the research which is undertaken. And some more screenshots from the presentations. And yes, again, thanks a lot to all of the people who came online to present it, some live, but to answer questions and to actually make this a very successful event. Without all of the presenters, we could not have achieved what we have achieved in the last few days. Let's have a look of what was actually presented. And Jack prepared this lovely cloud of words in form of echidna. So the animal you can see, the shape is echidna. It's Australian marsupial. And hopefully at one stage you actually can travel to Australia and have a chance to have a look at not just echidnas, but all of the other native animals as well. But if you compare about the titles, or compare the titles between the annals and the archives, you can see that study or case and data are very prominent in both. Whereas in the archives, we have more the disaster and the risk and the GIS component, and in the annals we have also some more sensor data, such as the cloud-based point clouds, LiDAR, and more the data-driven topics. If you go to the keywords which were used, in this case presented in the shape of a koala and a kangaroo, we can see that the keywords again has some overlap. In archives, pretty obvious, GIS is the strongest, followed by data, disaster, risk, but also UAV, 3D system mapping and management. And again, with the annals, we have lots. We have more the model and data keywords, LiDAR, Landsat, UAS, so UAV systems as well. Just to give you an overview, idea of the keywords which were used in the papers. All of the papers could not have been published and the presenters could not have been provided with the feedback without the reviewers. So overall, we had 103 reviews. Each paper got reviewed by at least 2 reviewers, sometimes 3 or more. And again, it's a truly global distribution. This time mostly from Australia, but you can see also many cases from Belgium, Canada, Germany, New Zealand as well. So thanks a lot to all of the reviewers who were very busy and active to review the papers and to provide feedback to the authors. Something which we introduced for Gi4DM for the online versions were the panels. And the panels try to break from just looking at the screen to see more interactive discussions. So overall, we had 6 panels, and at least from my point of view, they was very successful. If you think that's something which should be kept for the future as well, or if you enjoyed the panels or other aspects, please let us know. It would be good to get your feedback. So I will present all of the different panels on the next slide, because then you actually can see the faces as well. And Sissy, I put you on here on the panel because you had the opening, but then we had a panel discussion about First Nations, where we especially tried to cover some of the aspects Brandon and Oran just discussed. We had a special panel about COVID-19 and geotechnology, and Marie is actually part of the WHO, which made this panel very interesting. We had one panel about education for Gi4DM, because with more and more data available, with more and more users, it's very important to put a high emphasis also on the education, which helps to make this information or the analysis, the outcomes actually accessible to a wide audience, not just spatial professionals. We had one session about managing warming and cooling environments, and that was a good panel which also showed how citizen science can work, so how we actually can engage with the let's say everyday audience who actually will be impacted by, in this case, warming the most. We had one panel just about the Australian 1920 bushfire season, which basically summarized as well that as an aspect of not just having the data available, but also the analysis and next steps. And the last panel, the panel number 6, was the panel about remote sensing for DM, where Peter Kinner, together with representatives from industry, from high-resolution airborne and satellite platforms, but also drone capture, tried to discuss of the challenges, and especially the challenges also from getting the information we can capture to the decision makers, and where the bottlenecks are and what we maybe should change in the future. On Tuesday, before the official start of the conference, we also offered 6 tutorials. Professor Clive Fraser from the University of Melbourne gave a tutorial about structure for motion and photogrammetry. I think it's something not just in my, I say this not just because it's in my field, but to educate people of using the tools which are available in the most efficient way. It's very important. Then Bruce Forster talked about the introduction of radar remote sensing, and this tutorial was in the morning, and then Deepak Powday from S3 picked up on the topic and discussed how radar, or better SAR interferometry, can be used for dam safety. Mitko Alexandrov presented or gave a tutorial about the creation of local-based AR apps with Unity and Mapbox. And I think while, yes, we can use radar or photogrammetry to produce models and analysis tools, it's very important to also present it and to make it accessible. And that was tutorial could achieve this very good. Then David McMeekin from Curtin University presented about semantic web tools and technologies. So just a different way of going away from the traditional way of finding information to use semantics and the semantic web to enrich data by just trying to connect them with each other, in this case using semantic tools. And then Ori Goods, also from University of New South Wales, gave a tutorial about visualizing bushfires and especially using open source tools. And I think the open source tools are important because if we want to make the workflows and the technology accessible to everyone, then I think open source is a very important aspect of it. As a conference chairs, I have mentioned this here a number of times, but I also would like to mention explicitly David Sanderson. So David is the chair for the Urban Resilience Asia Pacific 2 conference, which started today and will carry on until tomorrow, and also Mary Ellen Finney, who was the main driving factor behind in organizing the conference on the first day, the IIIWA New South Wales conference. Big thanks also to Clive and Meg, who were conference chairs and who contributed significantly, and also big thanks to our co-chairs. So Bruce, who gave the tutorial, Chris was one of the chairs, Deepak gave a tutorial as well, Ivana was part of a panel discussion. David could not be a chair because of other commitments, but he was very busy with reviewing papers. Brandon, thanks for chairing the last session, and Nancy, who chaired a session early on today as well. But all this, and that's truly, I mean it very truly, all this could not happen without the guys on the slide. To change to fully online, we knew there would be some challenges, but I think the only people who truly know which challenges were there and were very busy in the background is Jack and Mitko and the team of Abdullah, G, Zheng, Lee, Nina, and Mohammed. So thanks a lot, guys. That was a very big effort. And I apologize that I was a pain in the backside with sending so many emails. YouTube doesn't work or whatever, but you did a fantastic job, and thanks a lot. And just to give you some faces as well, you have on the top the control center. Maybe some of you have seen Jack online. So that's the strange wall with the green sign in the background. Now you have a spatial context of it. But everyone else shown as well. So Midcore is on the bottom left. So thanks a lot. And lucky enough, because of you guys, you didn't see as often the screen on the top right side, the technical difficulties that was well under control. Thanks a lot. And of course, the conference also could not happen without the sponsors. The sponsors are, first of all, the 4 universities, the Curtin University, the ANU, the Australian National University, the University of Melbourne, and the University of New South Wales. And also truly an effort of universities from different states, from West Australia, from Canberra, from Victoria, and from New South Wales. Thanks a lot also to the ISPRS, who has been connected with Gi4DM for a long time, and where the papers are published, and the SSSI, so the Surveying and Spatial Sciences Institute of Australia, which is the umbrella for all spatial professionals, which includes not just, as Sissy already mentioned, photogrammetry and remote sensing, but also GIS, mining engineering surveying, and catastrophe surveying. Then we had sponsors, Black Ash and Mercury, and big thanks for their support for the conference. And before I hand over to Sissy, I just want to again say thanks a lot to, first of all, not mentioned yet, but our Auntie Yvonne Sims, shown on the top right side, for the welcome to country, to the 4 big universities, to the sponsors, to the keynote speakers, to the tutors, to the moderators and the panelists, to the authors and co-authors, the reviewers, the participants, the organizers and technical support. Thanks a lot to Sissy for enabling to get the conference here. Thanks a lot for to Jake Mitko and the UNSW team to make it actually happen. And I hope at one stage I can see you in person again when we can travel again, and then I can say the appreciation the true Aussie way. And yes, thanks a lot for all the efforts of all of you guys. And with this, Sissy, I would like to hand over to you to present the last slides.
Thank you very much, Petra. It's really wonderful summary that you gave for our conference, and I think you make many people jealous that they, for one or another reason, couldn't follow all these presentations. Now we are coming to the one very beautiful moment within the closing ceremonies, the awards. We have 2 awards. One of them is for best paper and the other one is for best presentation. And I must say that it was a really very tough competition. We had very good papers and also very good presentations. Actually, I must say I realized that the presentations that were given as a virtual pre-recorded presentations were much better than the presentations that usually are given at face-to-face conferences. I don't know why it's this, probably because people can try and make a very nice presentation, but everything was really kind of excellent. And the competition was really very tough. We have a committee, different committees for the 2 awards. The first committee on the best paper also included the chairs, and actually also we consider how the reviewers look at the papers. And yeah, we have winner. And Petra, if you go to this slide, to the next slide, best paper, best paper award is for Pravita Sharma. And actually there are a lot of people within this paper that contributed to it. And the paper is Disaster Aware Global Alerting Platform for Flood Events. I checked the paper, all the authors are from United States, and I don't believe anybody of them is at the moment here. It's probably 4 o'clock in the morning in the East Coast and probably 1 o'clock in the West Coast. But they will receive the award and also a small gift virtually, because it is a virtual conference, so everything is going to be sent virtually to them. So congratulations, Pravita Sharma and the rest. Very well done. The next award is for best presentation, and the best presentation award is for Sunny Singh for the paper Experimental Study to Compare Factors Influencing Exit Choice Behavior in Emergency Evacuation Situations using Virtual Reality Techniques. So Sunny is from Australia, and I wonder whether he's still here. Sunny, if you are here, could you switch your video.
Thank you so much, Professor. Yes, I am still here. Am I audible? Can you hear me?
Yes,
we can hear you. We cannot see you.
Let me try and turn on my video. See if that works. Hey.
Hey, Shani. Congratulations for the award.
Thank you so much.
You deserve it. It was really a very nice presentation.
Thank you so
much. Yeah, we can give him some applause. Since here. Yeah.
Thank you so much.
Virtually.
This is breathtaking.
So you can say something. Of course, this is a word. Say something.
Yeah, well, I have not prepared an acceptance speech, to be honest, because honestly, I wasn't expecting it. But yeah, throughout the journey, like the support that I've received from Professor Sisi herself, and then my co-author, Professor Miad as well. So much hard work goes into everything that was presented here. I'm pretty sure everyone else's presentation was equally. I personally attended quite a lot of presentations as well. It was such a level field. Everyone did so well. It's such a great honor to actually be recognized for the work that I was able to contribute to the conference. And I mean, at the end of the day, we all strive to make our world better every single day, right? So I hope my presentation and my research would contribute towards that. And let's just keep striving towards being better.
Thank you. Very nice speech, although I'm not prepared. And now, when we finish with these awards, actually, we don't have anything more to say. Probably only to see where we are going next year or the years after. And actually, we are going to have a conference next year. It's going to be in Beijing, in China, and it's going to be organized by the team of Professor Jing Jie in the University of Civil Engineering and Architecture. It's actually Beijing University of Civil Engineering and Architecture. The university is The university is relatively young, but actually it's growing, and they have a nice, huge, beautiful campus in one of the very isolated parts of Beijing. To go there is really kind of experience. But anyhow, they have all the facilities